You might not know it yet, but by clicking on this video, you've just hit the jackpot when it comes to IT training. This course is by far the most complete, beginner-friendly IT training course available. And here's the best part. It's absolutely free. That's right. No subscriptions and no hidden costs. Just pure, focused training designed to prepare you for the CompTIA Tech Plus certification exam. This course was built from the ground up, with nothing but your success in mind. With that said, if this is the first time you have heard of us, allow me to officially welcome you to the Certification Cynergy community, and to our CompTIA Tech Plus complete training course. We are excited that you have chosen us as your guide while you begin your journey into information technology, and we appreciate the opportunity to share our expertise with you. Whether you're a student exploring future career options, a working professional considering a career shift into IT, or someone who simply wants to understand how technology works, this course is for you. And yes, it's completely self-paced and 100% free. But one word of advice. Don't tell your archenemy about this course. If they find out about this amazing training course, they will pass too. And you don't want that. So, why choose this course over the thousands of IT tutorials scattered across the internet? It's simple. We offer superior structure and clarity. Certification Cynergy doesn't just throw information at you. We walk you through a carefully organized learning journey. With each IT concept building upon the last, we guide you forward with clear intent. So think of this course as your personal treasure map. It will be easy to follow, well-marked, and focused entirely on helping you succeed. So why get lost in a labyrinth of random tutorials, when a proven pathway lies right in front of you? At Certification Cynergy, we value your precious time. That is precisely why we have bottled a vast ocean of learning into a potent elixir of knowledge. And the best part? You're in control. You can go fast or slow, rewatch lessons as needed, and focus on the topics that matter most to you. Some learners will be able to complete this course in a single day, while others might choose to stretch it out over a few weeks or even months if needed. No matter how you approach it, we're here with you every step of the way. Now, what else makes us the best IT training in town, besides our strategic and orderly presentation of IT topics? That's easy. We break down tech concepts in a way that feels simple, approachable, and stress-free. With Certification Cynergy, you can expect to learn from vivid, comprehensible video segments, all seasoned with a dash of humor, to keep the experience fun. This course isn't just a learning pathway, it's a guided experience from start to finish. So do you think you're ready? Then buckle up. Because the first step of your IT journey starts right now. But before we dive into any technical topics, we need to discuss the path that lies ahead. And more importantly, how this course fits into your bigger goals. By choosing to start with the CompTIA Tech Plus certification, you will be laying down a strong foundation. This certification teaches the essential building blocks of IT concepts that are used across every area of technology. Think of Tech Plus as your launchpad. It's designed to help you feel comfortable with the fundamentals before taking on more advanced topics. And once you've mastered what's here, you'll be ready for what comes next, like the CompTIA A+, which takes a deeper dive into troubleshooting and IT support. Or the CompTIA Network Plus, where you will explore how devices connect and communicate. And then there's the CompTIA Security Plus, your entry into the world of cybersecurity. Each of these certifications builds on what you are about to learn. So while this may be your first step, it's a powerful one. With your pathway laid out ahead of you, it's time to break down what exactly you will be learning in this course. The CompTIA Tech Plus certification is designed to teach you the core skills and foundational knowledge that every entry-level IT professional should know. As you move through this training, you'll build confidence in several key areas. You'll start by understanding basic computing concepts, things like how data is processed, stored, and used by digital devices. You'll also learn how to identify and work with different types of IT infrastructure, including hardware components and connected systems. Next, we'll explore how devices connect to networks, and how to troubleshoot basic connectivity issues when things don't go as expected. You'll also discover how software and applications function, how they're installed, configured, and used in both personal and business environments. From there, we'll dip into software development concepts to help you better understand how programs are built and organized. We will also talk about databases, including what they are, how they're used, and how to manage data effectively. And finally, you'll learn how to recognize common security threats and take steps to protect systems and information from harm. Each of these topics plays a critical role in today's tech landscape, and by the time you finish the course, you'll be well prepared to demonstrate your knowledge on your Tech Plus exam and in the real world too. Moving on with our introduction to Tech Plus, we come to the exam details. The current version of the CompTIA Tech Plus exam, officially known as FC0-U71, was released on July 16, 2024. This version reflects the most up-to-date expectations for entry-level IT professionals, so everything you'll be learning in this course is aligned with the skills the industry values today. When you sit for the exam, you'll be presented with up to 70 multiple-choice questions. You'll have a total of 60 minutes to complete the test, which means time management will be important. The passing score is 650, and the exam is scored on a scale that goes all the way up to 900. Now, the scoring system for the CompTIA Tech Plus exam might seem a little confusing at first, especially since it's based on a scale that goes up to 900. So, to make things clearer, here is a helpful breakdown we use at Certification Cynergy. If your score falls below 500, it simply means you need a bit more time with the material, and that's okay. Everyone starts somewhere, and progress is part of the process. If you score between 500 and 649, you're getting really close. A few more focused study sessions, and you'll be ready to go. If you score between 650 and 749, congratulations. That means you've officially passed the exam and earned your Tech Plus certification. If you land in the 750 to 799 range, it shows that you've mastered most of the material and really know your stuff. And if you score 800 or higher, well, you didn't just pass, you crushed it. And finally, if you happen to earn a perfect 900, contact us immediately. We want to hire you. Just kidding. But in all seriousness, be proud. Even seasoned IT professionals rarely achieve a perfect score. Now here's something every test taker should know. And trust me, it's a game changer. When it comes to preparing for your Tech Plus exam, the CompTIA exam objectives are your absolute best friend. This document is not just a general overview, it's a detailed guide that outlines everything you need to know before exam day. It breaks down how many questions to expect, what types of questions you'll see, like multiple choice, and most importantly, the exact topics you're expected to understand. Think of it like your official study roadmap. It tells you what to focus on, how the content is organized, and where to spend your time. It's almost like having a cheat sheet, but completely legal, because it comes straight from CompTIA themselves. Many students skip over this resource, but those who take the time to review it carefully usually feel much more confident walking into the exam. So don't treat it like optional reading, treat it like your secret weapon for passing. According to the exam objectives I just mentioned, the Tech Plus exam is structured around 6 core domains, each representing a major area of knowledge that you'll need to understand. These domains aren't just random categories, they help shape the exam itself. Each one is assigned a specific percentage, which tells you how much of the exam is focused on that area. For example, IT concepts and terminology makes up 13% of the exam. Infrastructure, which includes hardware, networking, and cloud-related topics, is the largest portion at 24%. Applications and software account for 18%, covering operating systems, productivity tools, and web browsers. Then there's software development concepts at 13%, which introduces the basics of programming and logic. Data and database fundamentals also come in at 13%, focusing on how data is stored, organized, and accessed. Finally, security makes up 19% of the exam, an increasingly important area in today's tech landscape. Together, these 6 domains give you a complete picture of what to expect, and knowing how they're weighted can help you study smarter, not harder. Once you're familiar with the 6 exam domains, the next step is to understand how each domain is organized. Every domain is broken down into exam objectives, and these objectives outline the specific knowledge and skills you're expected to master within that topic area. Think of the domains as chapters, and the objectives as the lessons inside each chapter. Let's look at Domain 1 as an example. This domain is called IT Concepts and Terminology, and it kicks off with Objective 1.1, Explain the Basics of Computing. This objective includes 4 key ideas, or topics, that form the foundation of how digital systems operate. The topics are input, processing, output, and storage. And with these topics, you will learn how information enters a computer, how it's handled inside the system, how results are produced, and where everything is stored. From there, the objectives gradually expand into other fundamental topics, like the notational systems, binary, hexadecimal, decimal, and octal, as well as units of measure such as bits, bytes, and throughput speeds. You'll even learn how to apply basic troubleshooting methodology, which is critical when diagnosing common tech issues. And if any of this feels unfamiliar right now, don't worry. That's exactly why this course exists. We will take our time walking through each topic in a way that's clear, approachable, and focused on your success. So, why are we putting so much emphasis on the exam objectives before getting into the technical topics? Because they truly matter. They're one of the most valuable tools you have when preparing for the CompTIA Tech Plus exam. While they're often overlooked, the exam objectives provide the clearest and most direct path to success. They outline exactly what you need to know, so you're not wasting time guessing what might be on the test. You can use them to guide your study as you move through the course, and once you've finished, come back to them as a final checklist. A last-minute review of the objectives can help you focus your thoughts and spot any weak areas before test day. To help you get started, you can download the official exam objectives using the link we've provided in the video description below. Now, here's how to get the most out of this course. Watch each video segment at your own pace. Pause when you need to. Rewind if something doesn't quite click the first time. And feel free to revisit any topic as many times as it takes to feel confident. This course is here for you, whenever and however you need it. And while you're here, go ahead and hit that subscribe button. That way, you'll always know where to find us, and you'll stay up to date with all the free training content we're constantly adding. Countless learners just like you have already used Certification Cynergy to kickstart their IT careers. And now, it's your turn. You've taken the first step, so let's dive into the first lesson. And get you certified. Exam Objective 1.1 – Explain the basics of computing. Before we start throwing around a bunch of terms like binary and processors, we need to talk about the big picture. What exactly is a computer, and what does it do? At its core, a computer is simply an electronic device that manipulates information or data. That's it. Whether it's a powerful workstation or a tiny smartwatch, every computer performs the same four essential functions: input, processing, output, and storage. These four actions are the foundation of everything we do in IT, and they show up in every system you'll ever work with. Now take a look at this image. It shows a great way to visualize how a computer works at a very simple level. Just think of it like a four-way intersection. At the center of it all is system memory, acting like the crossroads where everything meets and temporarily passes through on its way to somewhere else. When you press a key on your keyboard or click a mouse, that action becomes an input, or information entering the computer. Once it's inside, the processor handles the processing, which means the computer is performing calculations, comparing values, or making decisions based on a set of programmed instructions. If the result needs to be saved for later, it's sent down to storage. Or, if the result is something the user needs right away, like text appearing on a screen or a document being printed, it becomes an output, and heads in that direction. Everything moves through system memory, which acts as a kind of temporary staging area. It holds the data while the computer figures out what to do with it. System memory is fast, flexible, and as you can see, it is central to the entire operation. Now, let's talk about hardware. That's the physical elements of a computer that makes all this happen. The keyboard, mouse, monitor, processor, and hard drive. These are all examples of hardware. In the world of IT, we often refer to hardware as infrastructure. And looking back at our traffic intersection example, hardware would be represented by the actual roadways. It creates the physical paths that allows data to move around the system. But roads alone aren't enough. We also need something to guide the traffic. That's where software comes in. Software is the set of instructions that tells the computer what to do. In IT, we sometimes use the word logic to describe software-based decisions. So if hardware is the roadways, software is the traffic lights and street signs. It directs the data, manages the flow, and ensures that everything happens in the right order at the right time. And finally, we can't forget about peripheral devices. A peripheral device is an auxiliary device that connects to and works with a computer, and is used to put information into or get information out of the computer. In simpler terms, these are external components that help us interact with the system. Things like keyboards, webcams, mice, gaming controllers, monitors, printers, and scanners all fall into this category. If it connects to the computer and either sends data in or takes data out, it's considered a peripheral. These devices play a key role in how we input commands and receive output, making them an essential part of the overall computing experience. So, when you put it all together, you have a system that takes an input, performs processing, sends results to output, saves information using storage, and coordinates everything through system memory, all moving along hardware pathways and following instructions provided by software. Exam Objective 1.1 Explain the basics of computing. Input and output. Now that you understand the overall functions of a computer, let's focus on two of its most visible roles, input and output. These two functions are how users interact with computers in everyday life. Let's start with input. Input occurs when the computer receives data from a user through a peripheral device that connects to and works with a computer. In other words, when you're giving instructions or data to the system, whether by typing, clicking, speaking, or scanning, you're using an input device. Some of the most common input devices include a keyboard, which lets you enter text and commands, a mouse, which captures movement and clicks, a camera, which inputs visual data, and a scanner, which inputs printed documents and images. Each of these devices feeds data into the computer so that it can be processed, stored, or acted upon. Now let's look at the other side of that process, output. Output occurs when the computer displays, plays, or distributes data to a user through a peripheral device that connects to and works with a computer. This is the system's way of communicating results or feedback back to you. Examples of output devices include a monitor, which displays text, images, and video, a speaker, which outputs sound such as music or voice, a printer, which converts digital documents into physical ones, and a projector, which displays computer content on a larger screen for group viewing. If the computer is sending data out to you in any form, the device doing that job is considered an output device. Of course, in today's technology, many devices don't just do one or the other, they do both. These are known as multifunction devices, and they can send and receive data depending on how they're being used. A good example is a headset. It includes a microphone for inputting your voice and headphones for outputting sound. A touch screen is another great example, as it accepts touch gestures like taps and swipes as input, while also acting as a display for visual output. And a multifunction printer can scan documents into the system as an input and then print documents out as an output. So to sum it up, input brings data into the computer, output sends it back out to the user, and some devices do a little bit of both. By recognizing the role of each peripheral device, you will better understand how computers work. Exam Objective 1.1 Explain the basics of computing. Processing. Now that we've talked about how data enters a computer through input and leaves through output, it's time to focus on what happens in between, which is processing. By definition, processing is the manipulation of data by a computer's processor. It's the step where raw data is transformed into something meaningful and useful. When the computer receives input, like a button press, a typed sentence, or a scanned image, it doesn't just sit there. The processor gets to work. It takes that input, or even data that's already been stored, and manipulates it based on instructions it receives from software programs. These instructions might tell the computer to perform calculations, organize information, sort data, or make logical decisions. Once the data has been processed, it has a couple of options. It can be sent to an output device, like a screen or a printer, where the user can see the result. Or, it can be sent to storage, where it's saved for future use. This cycle, taking an input, manipulating it during processing, and sending it to output or storage, is the heartbeat of how all computers function. So whenever you're using a device to check email, edit photos, or even play music, just know there's a lot of behind-the-scenes processing happening in the background, making sure everything runs smoothly and the data ends up exactly where it needs to be. Exam Objective 1.1 Explain the basics of computing. Storage. So far, we've explored how a computer receives information through inputs, processes that data, and sends results back out through outputs. But there's still one more essential function that we need to cover. And that is storage. Storage is a process through which data is retained for future use, and this data retention can be either temporary or permanent. In simple terms, storage allows a computer to hold on to information, whether just for a few moments or for much longer, so that it can be accessed when needed. When a computer is running, it needs a place to hold data that it is actively working with. This is where system memory comes in. Think of system memory as a short-term workspace. It temporarily stores the information the device needs right now to function smoothly. Whether you're opening a document, loading a web page, or watching a video, that data is held in system memory while the computer processes it. But once the task is finished, or the computer is powered off, that temporary storage is cleared, and the data is no longer available. Of course, not all data is meant to disappear. Sometimes, we want information to stick around even after we shut the system down. That's where permanent storage comes into play. Permanent storage holds onto your saved files, installed programs, downloads, and more. It keeps your data safe until you choose to delete or move it. When you open a saved file, that data is retrieved from permanent storage and sent back into system memory so the computer can work with it again. Whether that means displaying it on screen, printing it, or making updates. Storage plays a key role in the entire computing cycle. After data is received and manipulated by the computer's processor, it's often stored either temporarily or permanently, so it can be retrieved later, shared, or reused. Without storage, there would be no way to hold on to your work, no way to save progress, and no way to keep data around for when you need it next. Exam Objective 1.2 Identify Notational Systems. Decimal. Let's kick off this exam objective by looking at a number system you already know very well, even if you didn't know what it was called. It's called the decimal notational system, and it's the one we use every single day without thinking about it. The decimal system is a number system that has 10 possible digits for each place value. These digits are 0 through 9. If the word decimal sounds too technical, just remember, this is the same system you learned when you first started counting fingers and toes. Whether you're setting an alarm for 7 a.m., entering a 4-digit PIN, or checking the battery level on your phone, you're likely using decimal. Now let's look at how it works. In decimal, each place value increases by a factor of 10 as you move left. So the digit in the tens place is worth 10 times more than the digit in the ones place. Move one more to the left, and you're looking at hundreds, then thousands, and so on. This structure, based on multiplying by 10, is what gives decimal its power and consistency. And just in case you're curious, the prefix DEC in the word decimal means 10. You've seen it before in words like decade or decathlon. It tells us that this number system is built on 10 unique symbols, 0 through 9. Now, while computers don't use decimal internally, this system is still incredibly important in the world of IT, because it's designed for us, the human user. Binary might be the computer's native language, but it's not very readable. That's why programs often convert and display binary values in decimal form. It's easier to interpret, easier to communicate, and far less intimidating to work with when you're troubleshooting, configuring a device, or just reading a log file. So even though decimal isn't the language computers speak behind the scenes, it's still essential. It acts as a bridge between the digital world and the human world, helping us interact with technology in a way that feels natural and intuitive. Exam Objective 1.2 Identify Notational Systems. Binary. In the last segment, we explored the decimal system, the one we use every day without thinking about it. But when it comes to how computers actually store, process, and transmit data, they don't use decimal. Instead, they rely on something much simpler and much more powerful for machines, the binary notational system. Binary is a number system that has only 2 possible digits for each place value. Those digits are 0 and 1. That's it, just 0 and 1. And just like the prefix DEC in the word decimal means 10, the prefix bi in binary means 2. You'll see the same prefix in words like bicycle, which has 2 wheels, or biweekly, which describes something that happens every 2 weeks. That prefix reminds us that binary is all about 2 options. That's why you won't find the digits 3, 4, 5, 6, 7, 8, or 9 in binary. Just 0 and 1. Now, let's talk about how binary works. While decimal has each digit's place value increasing by a factor of 10, the binary notational system behaves a bit differently. Here, each place value only increases by a factor of 2. So the first position is worth 1, then 2, then 4, then 8, and so on. As you move left, the place value doubles. While this may look very different, this structure still allows binary to represent any number, just like decimal does, but in a way that fits perfectly with digital hardware. So why would a computer use a number system with only 2 digits? Well, it comes down to how computers are built. At the hardware level, computers are made up of billions of tiny electronic switches called transistors. These switches have just 2 states, off or on. And binary maps perfectly to this. 0 represents off, and 1 represents on. That's why binary is the computer's native language. It's a direct match to how the machine works physically. But binary isn't just useful for powering hardware. It's also a great way to represent 2-state ideas in software. Things like true or false, yes or no, or whether something is enabled or disabled, can all be stored and processed using binary logic. Now let's pause for a moment and look at a simple conversion chart. This chart shows how decimal values line up with their binary equivalents. For example, the decimal number 2 is written as 10 in binary. And the number 9 becomes 1001. Because binary only uses 2 digits, it usually takes more characters to express the same value compared to decimal, but remember, binary is still the more efficient choice for machines. So, the next time you see a long string of zeros and ones, don't let it intimidate you. It's just binary. And while it may look complex, it's the most natural and direct way for a computer to operate. Exam Objective 1.2, Identify Notational Systems. Hexadecimal. Now that we've seen how decimal is designed for people, and how binary is perfect for computers, it's time to meet a third notational system that acts like a bridge between the two. And that system is hexadecimal. So what exactly is hexadecimal? The hexadecimal notational system is a number system that has 16 possible values for each place value. That means, in a single digit, you can represent any value from 0 all the way up to 15. But here's the twist. When using hexadecimal, the symbols don't stop at 9 before moving to the next place value. Instead, hexadecimal continues counting using letters. Specifically, it combines the digits 0 through 9 with the letters A through F. That gives us 16 unique symbols in total. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. And just like we saw in previous videos, the name gives us a clue about how the system works. The prefix, hex means 6, and decimal means 10. Put them together, and you get hexadecimal, a system based on 16 unique symbols. So far, we've said that hexadecimal uses both numbers and letters. But how exactly does that work? Let's take a moment to look at the chart behind me. This shows how hexadecimal aligns with decimal values from 0 to 15. Everything matches up at first. You can see that 0 through 9 are exactly the same in both systems. But once decimal hits 10, hexadecimal switches to letters. So instead of writing 10, hexadecimal uses A. B stands for 11, C is 12, D is 13, E is 14, and F is 15. This gives us 16 total symbols, 0 through 9, and A through F. Now we will talk about how hexadecimal works. In the decimal system, each place value is worth 10 times more than the one to its right. In binary, each place is worth twice as much. And in hexadecimal, each place value increases by a factor of 16. So, for example, the far right digit is worth 1. The next digit to the left is worth 16. Then comes 256. Then 4096. And it keeps multiplying by 16 as you move left. So if you see a hexadecimal number like 2F, it's not just a 2 and a letter F. It's a compact way of representing a much larger value. With a bit of understanding and some basic arithmetic, that hexadecimal number can even be converted to decimal or binary with ease. Okay, but why use hexadecimal at all? That's a great question. Why create a scenario where we have to introduce letters just to have enough symbols to work with? Why not just stick with decimal or binary? Well, the answer is all about efficiency. In binary, even simple numbers can turn into long strings of ones and zeros. For example, the decimal number 255 is written in binary as 8 ones. That's a lot to read, and a lot of chances to make a mistake. But in hexadecimal, that same value is written as just FF. 2 digits. That's a huge improvement in readability. And when you compare them side by side, it becomes even more obvious that each hexadecimal digit can represent the same amount of data as 4 binary digits. So with fewer characters, you get the same information, just packed into a cleaner, more efficient format. While using numbers that are 8 binary digits in length can still be manageable, the real challenge shows up when the numbers get bigger. Take something like a 48-digit binary value. That's a massive string of ones and zeros, not only hard to read, but easy to miscopy and difficult to troubleshoot. This is exactly where hexadecimal shines. Instead of writing out all 48 binary digits, we can represent the same value using just 12 hexadecimal characters. It's clean, compact, and much easier to manage. This kind of shorthand isn't just about convenience, it's practical. And it's one of the biggest reasons hexadecimal is so widely used in IT. Speaking of IT, one of the most common real-world uses for hexadecimal is the MAC address, also called a physical address. It's a unique identifier used to label network devices so they can be recognized on a local network. Each MAC address is made up of 12 hexadecimal characters, typically grouped into sets of 2 or 4. You'll often see them separated by hyphens, colons, or even periods. But no matter how they're formatted, what you're really seeing is hexadecimal working behind the scenes, compressing 48 binary digits into a string that's far more readable. And MAC addresses are just one example of hexadecimal's many uses. Hexadecimal also plays a vital role in how we manage internet addressing. IPv6, the most recent version of the Internet Protocol, built to handle the massive and growing number of internet-connected devices around the world, also utilizes hexadecimal. In its binary form, an IPv6 address contains 128 digits. That's a lot of information to process. If we had to write it all out in binary, that would be exhausting, and frankly, not very useful. So instead, these addresses are grouped into 8 blocks of 4 hexadecimal characters, separated by colons. This format doesn't just look cleaner, it makes the address easier to read, easier to copy, and way less prone to error. Now, for our final example, let's shift gears from networks to something a little more visual and discuss hex color codes. These compact color codes can be found just about everywhere. They are used in web design, digital graphics, and even user interface customization. A hex color code is made up of 6 hexadecimal digits, and it tells your device exactly what color to display on the screen. Here's how it works. The first 2 hexadecimal digits represent the red value. The next 2 represent green. And the last 2 represent blue. Each of those color channels can range from 00 to FF in hexadecimal, which equals 0 to 255 in decimal. That means when you combine all 3 channels, you can create over 16.7 million unique colors, and it's all represented in just 6 simple characters. As you can see, hexadecimal shows up in more places than you might expect. Whether you're identifying a device, managing internet addresses, or selecting just the right background color for a website, it is quietly simplifying things behind the scenes. In short, hexadecimal takes long, detailed binary data and turns it into something far more manageable, making our interactions with technology faster, more efficient, and a whole lot more human-friendly. Exam Objective 1.2, Identify Notational Systems. Octal. We've already looked at 3 notational systems. Decimal, the one we use every day. Binary, the one computers rely on. And hexadecimal, which helps simplify large amounts of binary data. Now it's time to meet a 4th system. You might not hear about this one as often, but it still plays an important role in IT. It's called the octal notational system. The word octal includes the prefix oct, which means 8. You've probably heard it in words like octagon, a shape with 8 sides, or octopus, a creature with 8 arms. In the same way, the octal system is based on the number 8. So what does that actually mean? The octal number system uses 8 digits. Those digits are 0, 1, 2, 3, 4, 5, 6, and 7. That's it. Just those 8. In octal, the count stops at 7. After that, it rolls over to the next place value. This might feel a little abstract at first, especially if you've only ever used the decimal system. Decimal is so deeply built into our daily lives that we rarely even think about how it works. We just count from 0 to 9, and once we reach 10, we add another digit and keep going. It's automatic. But octal is different. In the octal system, you only have 8 digits to work with. 0 through 7. That's it. There's no 8. There's no 9. So, when you count an octal and reach the value of 8, it doesn't get written as an 8. It rolls over to the next place value, just like decimal does after 9. Let's say you're counting in decimal. You go from 8 to 9, then 10. In octal, you go from 6 to 7, then 1 0. That 1 0 in octal doesn't mean 10 in decimal, it actually means 8. And that's the key difference. When we look at the systems side by side, it becomes easier to understand what's happening. Octal may look a bit different, but it's still using a place value system, just like decimal, binary, or hexadecimal. It's simply based on 8 symbols instead of 10, 2, or 16. Once you see the pattern, it all starts to make sense. Now let's talk about how octal works. Just like decimal increases by factors of 10, and binary increases by factors of 2, octal increases by factors of 8. So the place values in octal go like this. The far right digit is worth 1. The next digit to the left is worth 8. Then comes 64. Then 512. After that, the pattern continues, multiplying by 8 each time you move to the left. So why would we use a system like this? Just like hexadecimal, octal was created to make long binary numbers easier to manage. Each octal digit can represent exactly 3 binary digits. This made octal especially useful in the early days of computing. Back then, memory was limited, and simplicity was key. Octal gave programmers a compact way to work with binary data without needing to type or read long strings of zeros and ones. It was fast, efficient, and matched the technology of the time. But as computers got more powerful and systems became more advanced, hexadecimal started to take over. Hexadecimal could handle even larger values using fewer digits. Over time, it became the standard for most modern digital systems. Today, hexadecimal is far more common. But you might still see octal in some older technologies, or in legacy systems that were built before hexadecimal became the go-to solution. So knowing and understanding octal still has its uses. Exam Objective 1.3, Compare and contrast common units of measure. Up until now, we have been referring to a single 0 or 1 as a binary digit, but a more common name for this quantity of data is a bit. A bit is a single binary digit, and is the smallest increment of data for a computer. The next unit of measure we will discuss is a byte. A byte is a unit of measure that contains 8 bits, or a series of 8 zeros and ones. It is also important to note that a bit is represented with a lowercase b while a byte is represented with an uppercase b. Get these two measures confused and you will be off by a factor of 8. Now you are a master of measures. Okay, not quite. But at least you now understand the foundational measures bit and byte. From here, every other measure we will need to know will just add a prefix to the front of these two measures. Let's start with a single bit and add our first prefix, kilo. Kilo means 1,000. So a kilobit equals 1,000 bits. Our next prefix is mega. Mega means million. So a megabit equals 1,000,000 bits. This is followed by giga. Giga means billion. So a gigabit equals 1,000,000,000 bits. Then, tera. Tera means trillion. So a terabit equals 1,000,000,000,000 bits. The last prefix we need to know for the CompTIA Tech Plus exam is peta. Peta means quadrillion. So a petabit equals 1 quadrillion bits. These same exact prefixes also apply to the base measure of byte. Let's start with a single byte and add our first prefix, kilo. Kilo means 1,000. So a kilobyte equals 1,000 bytes. Our next prefix is mega. Mega means million. So a megabyte equals 1,000,000 bytes. This is followed by giga. Giga means billion. So a gigabyte equals 1,000,000,000 bytes. Then, tera. Tera means trillion. So a terabyte equals 1,000,000,000,000 bytes. And then there is peta. Peta means quadrillion. So a petabyte equals 1 quadrillion bytes. Exam Objective 1.3, Compare and contrast common units of measure. Storage units. We will get to the units of measure that we use for data storage in a moment. But first I want to address the concept of data at rest. Data at rest in information technology means data that is housed physically on a storage drive in a digital format. Now, with that concept out of the way, we can go ahead and take a look at the specific measurements used for data storage, or as we just learned, data that is at rest. Storage units are measured in bytes. That is uppercase B for bytes, not lowercase b for bits. The storage unit, bytes, can measure anything from a file, a group of files, or the contents of an entire storage drive. The storage drive itself will also have a capacity measured in bytes. Anytime you have data that is not being accessed and is stored on a physical medium like a storage drive or even in system memory, which is often referred to as RAM, the preferred unit of measure will be bytes. As a few bytes can only store a minimal amount of information, we will have to deal in much larger quantities of bytes to meet today's demands. Some relevant quantities are kilobytes. Kilobytes are quantities measured in thousands of bytes. This is an expected size for a text file or smaller images. We also have megabytes. Megabytes are quantities measured in millions of bytes. This is an expected size for larger images or smaller videos. Then there are gigabytes, which are quantities measured in billions of bytes. This is a common size for full-length cinematic movies, and many modern hard drives have storage capacities in this range. We also have modern RAM capacities falling in this range as well. Now we are getting into some big storage units. Up next is terabytes. Terabytes are quantities measured in trillions of bytes. Newer hard drives are now exceeding the terabyte threshold. The last storage unit we need to know for the CompTIA Tech Plus exam is petabytes. Petabytes are quantities measured in quadrillions of bytes. You might find these units of measure in large company servers, data centers, or other places where significant quantities of data are stored. At some point, you will undoubtedly have to convert between different storage unit sizes. This chart will help a bit visually. But I will also talk you through it and hit some key points for you. First, as you study, I want you to commit the order of sizes to memory from smallest to largest, which would be byte, kilobyte, megabyte, gigabyte, terabyte, and petabyte. And now from largest to smallest, petabyte, terabyte, gigabyte, megabyte, kilobyte, and back to a single byte. Next, you should know that moving from any storage unit measure to the next closest measure is always a factor of 1000. Example: 1 kilobyte is 1000 bytes. 1 megabyte is 1000 kilobytes. 1 gigabyte is 1000 megabytes. 1 terabyte is 1000 gigabytes, and so on. Understanding the relationship between these storage unit sizes will assist in converting between them when needed. Before I wrap this topic up, I wanted to do at least one measurement conversion with you. For our example, we will start with 44.6 megabytes. I will now convert this to kilobytes and then gigabytes. For those of you who don't trust your math skills, no problem. The most important part is to follow the decimal point, which I will now make red. As the difference from each storage unit size to the next closest size is a factor of 1000, we will see the decimal point move 3 place values to the left if going up 1 storage unit size, or to the right 3 place values if we go down 1 storage unit size. I will start with converting 44.6 megabytes to kilobytes. As we went down a storage unit size, we have moved the decimal point 3 place values to the right. Now we can see that 44.6 megabytes is equivalent to 44,600 kilobytes. Now I will convert 44.6 megabytes to gigabytes. As we went up a storage unit size, we have moved the decimal point 3 place values to the left. Now we can see that 44.6 megabytes is equivalent to 0.0446 gigabytes. Exam Objective 1.3, Compare and contrast common units of measure. Throughput units. Throughput units are used for data in transit. Data in transit refers to digital data that is actively moving between two different computer systems, applications, or locations. Throughput units are measured in bits per second. That is lowercase b for bits, not uppercase b for bytes. The throughput unit, bits per second, can measure any digital data that is traveling from one point to another. This includes measuring the speed of network connections between computing devices or internal connections between computing components. Anytime you have data on the move, the preferred unit of measure will be bits per second. As a couple bits is not even enough to store a single character of data, we will have to deal in much larger quantities of bits to meet today's demands. Some relevant throughput unit quantities are kilobits per second. Kilobits per second are quantities measured in thousands of bits per second. This is a relatively low throughput rate for modern computing. We also have megabits per second. Megabits per second are quantities measured in millions of bits per second. Throughput rates in this range are common for internet connections in rural areas that are using slightly outdated technologies, where throughput rates are limited as a cost-saving measure, or where limited network infrastructure exists. Then there are gigabits per second, which are quantities measured in billions of bits per second. This is a common throughput rate for modern internet connections in urban areas. Gigabit connections are more than sufficient for most residential demands and many corporate environments. Now we are getting into some super fast throughput rates. Up next is terabits per second. Terabits per second are quantities measured in trillions of bits per second. Throughput rates in this range are relatively new and not very common. Unlike a bit, which is a static measurement, bits per second is a dynamic measurement. As such, I think it is worth breaking down this topic a bit further. Yes, that was an intended pun. Now for the breakdown. Let's start with bits. This is a quantity of binary digits, no different than we learned about prior. Per second is a measurement of time. The passage of time is what makes this measurement dynamic. Last, the division symbol makes this a ratio. In this case, a ratio of bits to seconds. Putting all these pieces back together, we can conclude that bits per second is a numerical way of representing the number of bits that pass a fixed point every second. So do you feel ready for a measurement conversion challenge? Great! For this challenge, we will compare 3 different throughput measures, each using a different unit, and determine which throughput speed is the fastest. Here they are. In the top we have 0.458 gigabits per second. In the middle we have 49,896 kilobits per second. And down at the bottom we have 432 megabits per second. To compare these measures, I find it best to convert each value to the same throughput unit. Looking at my 3 values, I am going to choose megabits per second as my unit of choice. Back at the top we see gigabits per second, which has a measure that is 1,000 times larger than that of megabits per second. To convert from a larger unit of measure to a measure 1 unit smaller, we will move the decimal point 3 place values to the right. This results in 458 megabits per second. Returning to the middle value, we see kilobits per second, which has a measure that is 1,000 times smaller than that of megabits per second. To convert from a smaller unit of measure to a measure 1 unit larger, we will move the decimal point 3 place values to the left. This results in 49.896 megabits per second. At the bottom, 432 megabits per second is already in the correct unit of measure, so no conversion is needed. Comparing these values is now much easier as they have all been converted to the same throughput unit of measure. Taking a quick peek at our original values, we can now see 0.458 gigabits per second is the fastest of the 3 values. Exam Objective 1.3, Compare and contrast common units of measure. Processing speeds. Processing speeds are a unit of measure for what we call data in use. In information technology, data in use refers to data that is currently being processed or acted upon by the system's processor. Every modern computer has an internal clock, and that clock acts like a metronome, keeping everything running on beat. The clock speed controls how many cycles the processor can execute per second. And when we measure those cycles, we use a unit called hertz. A hertz is a unit of frequency that equals 1 cycle per second. Just one. And at first glance, that might seem incredibly slow, especially when we're talking about high-speed computing. But here's the thing, computers almost never operate at just a single cycle per second. Instead, they move at astonishing speeds, handling millions or even billions of cycles every single second. That's why we don't just stop at hertz. Instead, we attach prefixes to scale the measurement up. These prefixes help us talk about much larger quantities without writing out endless zeros. For example, mega means million, so megahertz is millions of cycles per second. Giga means billion, so gigahertz is billions of cycles per second. These prefixes are essential when describing how fast a processor can execute instructions or how frequently a signal is repeated in a system. So while 1 Hz is technically 1 cycle per second, in the world of technology, we almost always see measurements like 1.8 GHz, 3.2 GHz, or even higher, because that's the level of speed modern processors operate at. That's billions of operations, every second, all thanks to the simple but powerful measurement called Hertz. But Hertz isn't just used for processors. You'll also see this unit of measurement when talking about a display's refresh rate. In this context, Hertz measures how many times per second the display refreshes the image on screen. The higher the Hertz, the smoother the motion appears. Exam Objective 1.4. Explain the troubleshooting methodology. Troubleshooting is simply the process of problem solving. In the world of IT, you will be called upon to solve problems on a regular basis. Having a step-by-step approach to troubleshooting will help make this task much easier. Fortunately, CompTIA has outlined a troubleshooting process for us to follow. CompTIA's troubleshooting methodology can be broken into 8 steps. 1. Identify the problem. 2. Research knowledge base or internet, if applicable. 3. Establish a theory of probable cause. 4. Test the theory to determine the cause. 5. Establish a plan of action to resolve the problem. 6. Implement the solution. 7. Verify full system functionality and, if applicable, implement preventive measures. 8. Document findings or lessons learned, actions, and outcomes. Each of these steps will be covered in subsequent videos. For now, I want you to commit these steps to memory and be able to place them in order. Not only will you be asked to recall these steps on the CompTIA Tech Plus exam, but you will also see this troubleshooting methodology on other CompTIA certification exams as well. Exam Objective 1.4. Explain the troubleshooting methodology. Identify the problem. The first step in CompTIA's troubleshooting process is to identify the problem. To do this, we must turn to the left side of our brains and think logically. Fortunately, we have a few guidelines that can help keep us on track during this stage of troubleshooting. The main objective, at this stage in the troubleshooting process, is to gather information. Information can be gathered in many ways. You can try duplicating the problem. Observing the issue as it occurs can give great insight. You can question the users. If a user is experiencing the problem, they will have first-hand knowledge of the issue. Also, don't discount that the issue could be user error. Computing systems and their programs, at times, can be complex, so misuse is always a possibility. Identifying the symptoms will help narrow down possible causes for an issue. Symptoms could include error messages or physical conditions. Many times, we can use our sense of smell, sight, touch, or hearing as diagnostic tools. Though I would probably avoid taste. Determining if anything has changed is another way to identify a problem. Commonly, issues arise after changes or updates have taken place. Finally, if there are multiple problems, treat them as separate issues, at least until you're certain they are related. Assuming multiple symptoms are related to a single cause can lead to occasional misdiagnosis. Exam Objective 1.4. Explain the troubleshooting methodology. Research knowledge base. Step 2 in CompTIA's troubleshooting process is to research a knowledge base. A knowledge base is a self-serve library of information about a product, service, or topic. A knowledge base could be compiled by a company, manufacturer, or simply the internet, which would probably be the biggest knowledge base of all. The whole idea behind a knowledge base is to pull from the experience of those who have come before you. In other words, don't waste time reinventing the wheel. If someone has already experienced the same problem and has documented the solution, and you trust the source, then maybe their solution can work for you too. Exam Objective 1.4. Explain the troubleshooting methodology. Establish a theory of probable cause and test the theory. Step 3 in CompTIA's troubleshooting process is to establish a theory of probable cause. In other words, based on the symptoms and information gathered, what's the most likely reason the issue is happening? This naturally leads into Step 4, where you test that theory to see if it holds up. These two steps often go hand in hand and may need to be repeated. After all, not every first guess will be right, and as the saying goes, if at first you don't succeed, try again. If you have completed Step 1, identify the problem. And Step 2, research a knowledge base. Then you hopefully have gathered sufficient information about an issue to proceed to step 3, establish a theory of probable cause. Here you will begin to think about possible causes to an issue with the hopes of narrowing down the list of suspects. When you first tackle a problem, start with theories that are easy to test and be sure to question the obvious. Assumptions at this point can be catastrophic. Let's say we receive a complaint that a user's laptop is not working. An example of questioning the obvious would be to check if it is even charged. It also helps to think outside the box and consider multiple approaches. You could even work with another technician to attack the problem from different angles. You could work on one theory while your coworker tries another theory. This approach is referred to as divide and conquer. Step 4 in CompTIA's troubleshooting process is to test the theory to determine the cause. Coming up with a theory was a great start, but now you need to test it. While testing is the logical step after establishing a theory, we need to remember these two steps are an iterative process and we might need to repeat them a number of times. Testing a theory will require some kind of experiment or action to confirm the cause of an issue. This can include changing out a component for a known good component or performing an experiment on a test system. Once your theory is confirmed and you have found the root cause of an issue, the next step is to resolve the problem. If testing does not confirm your theory, establish a new theory. At some point you may run out of ideas, and that is okay. At that point you need to find a way to escalate the problem. A form of escalation could be seeking help from another technician, a supervisor, or a specialist in the area you are having an issue with. Exam Objective 1.4. Explain the troubleshooting methodology. Establish a plan of action to resolve the problem. After determining the root cause of an issue, you can move on to Step 5 in CompTIA's troubleshooting process. Establish a plan of action to resolve the problem. Within your plan of action you are likely to come to one of three solution measures: repair, replace, or ignore. Ignoring a problem as a solution measure is self-explanatory, so I will focus on repair and replace. The choice between repair and replace will usually come down to cost. Repairing is usually a cheaper alternative to replacing, but not always. When establishing your plan, start by deciding if you will repair, replace, or ignore the problem. The rest of your plan will fall in line after that. Another item to be aware of when establishing a plan is to identify the potential side effects of your plan. Many times in IT, systems are interconnected. A change to one system can often have unintended side effects on another system. You may not be able to prevent every side effect, but proper planning can at least keep these to a minimum. Exam Objective 1.4. Explain the troubleshooting methodology. Implement the solution. Once you have established a plan of action, according to Step 6 in CompTIA's troubleshooting process, it is time to implement your solution. The biggest concern with implementing a solution is minimizing disruptions and obtaining authorization. If you did a thorough job while establishing your plan, it should include everything needed to make the change go smoothly. That means laying out each step in detail, identifying the resources you'll need, like tools, personnel, and downtime windows, and, most importantly, preparing a rollback or backout plan just in case things don't go as expected. That rollback plan is your safety net. It gives you a structured way to return things to normal without causing chaos. Having all of these elements in place, clear steps, defined resources, and a backup plan, will help the implementation process run more smoothly and reduce stress during the change. At this stage, your goal is to minimize disruption. You want the existing systems and their users to feel as little impact as possible. In larger organizations, the stakes can be even higher. Changes might affect multiple departments, critical services, or hundreds of users. That's why it's often necessary to get formal authorization before moving forward. This approval might come from a direct supervisor or, in more structured environments, a change advisory board. Exam Objective 1.4. Explain the troubleshooting methodology. Verify full system functionality. After the implementation of a solution, it is time for Step 7 of CompTIA's troubleshooting process, which is to verify full system functionality. While you may have only made a change to one system, in IT, it is common that multiple systems will be interconnected. Thus, in addition to verifying that you resolved the initial issue, you will need to verify the system, as a whole, continues to function properly. After solving the problem and verifying that everything is working properly again, there's one more step that separates a good technician from a great one, and that's prevention. Once the issue is fixed and the system is stable, it's time to ask, How can we stop this from happening again? This is where implementing preventative measures comes in. And while you won't always have control over every factor, there are often small steps you can take to reduce the chances of a repeat incident. For example, you might identify a training gap and offer some basic user education. Sometimes just showing someone a better way to do something can eliminate the issue entirely. Other times, the root of the problem might be the process itself. If that's the case, you might suggest a change to the workflow that makes it more reliable. In some situations, it may even make sense to switch to a different piece of software or hardware that better fits the environment. Implementing preventative measures is more than just fixing today's problem, it's about improving the system for the long haul. When you take this extra step, it shows foresight, professionalism, and a real commitment to quality support. Exam Objective 1.4. Explain the troubleshooting methodology. Document findings, lessons learned, actions, and outcomes. The final and last step in CompTIA's troubleshooting process is to document your findings. Again, the last step is to document everything. Document the symptoms, document your actions, document your outcomes, and document any lessons learned. That way, when a problem is resolved, there is a complete record of everything that transpired during the entire troubleshooting process. This can be extremely helpful when providing any technical support in the future. Do you remember Step 2, research a knowledge base? Well, where do you think a company's knowledge base comes from? Knowledge bases evolve and grow over time as issues are experienced. So do your best when documenting any issues you resolve, as people other than you may come to rely on it in the future. Exam Objective 2.1. Explain common computing devices and their purposes. There are many different types of computing devices. In this video, we'll go over some of the most common ones you'll encounter, starting with mobile phones. A mobile phone is a portable device designed for wireless communication over a cellular network. That sounds like a pretty simple definition, especially when you consider everything modern mobile phones can actually do. Today's mobile phones let you make calls, send texts, browse the internet, run apps, use GPS, take photos, and even scan documents. No wonder people now refer to a mobile phone as a smartphone. To make all this happen, mobile phones rely on a combination of hardware and software. They use internal antennas to connect to cellular networks and compact processors that are designed for both power efficiency and performance. It's a lot of capability packed into a device that fits in your pocket. Up next is the tablet. A tablet is a portable device designed for wireless communication over a cellular or Wi-Fi network, just like a smartphone. Tablets use compact processors, include internal antennas, and offer very similar functionality. But the key difference lies in the screen size. While smartphones typically range between 4.5 and 5.7 inches, tablets are much larger, usually between 7 and 10 inches or more. This makes tablets great for media consumption, drawing, and mobile productivity. Closely related to the tablet is another device used primarily for reading. This device is an e-reader. An e-reader is a portable computing device designed specifically for reading digital books and documents. These devices use specialized screen technology to reduce eye strain and maintain visibility in a variety of lighting conditions. Whether you're reading in low light or direct sunlight, the display stays sharp and easy on the eyes. E-readers are also lightweight, energy efficient, and designed for extended use, often lasting weeks on a single charge. Next, we move to laptops. A laptop is a computing device that integrates the display, system components, and multiple peripheral devices within a single portable case. It runs on an internal battery but can be powered externally as well. Most laptops include a built-in keyboard, touchpad, touchscreen, webcam, microphone, and speakers. Laptops strike a balance between mobility and power and are ideal for work, school, and home use. From laptops, we scale up to workstations. A workstation is a type of computing system that is designed to be used on a desk or a fixed location. You might also hear this referred to as a desktop PC. Unlike laptops, workstations favor external peripherals like keyboards, mice, and monitors. These systems are generally more customizable and upgradable than laptops. Then we have servers. This is where things can get a little tricky, so let's slow things down. A server, in a general sense, is a computing device that provides services to other devices. For example, it might store files, handle email, or serve up web pages. But for this exam objective, we are focused on the physical device. So sticking to its physical nature, a server is a powerful computer designed to support a number of users simultaneously. It contains the same basic components as a workstation, but server components are purpose-built for higher performance, greater reliability, and longer runtimes. Our next device is the gaming console. A gaming console is a specialized computing device designed primarily for playing video games. You've probably heard of the big names like Sony PlayStation, Nintendo Switch, or Microsoft Xbox. These consoles don't just run games, they also use embedded operating systems optimized for gaming performance. Some models offer media streaming, social features, and even cloud gaming support. Now let's talk about virtual reality systems. A virtual reality system is a computing device designed to create a fully immersive digital experience. It typically uses a headset with built-in screens and sensors to track head movement and simulate a 3D environment. These systems might also include hand controllers or motion tracking devices to interact with the virtual world. Virtual reality is often used for gaming, simulations, and training. Finally, we have augmented reality systems. An augmented reality system is a computing device that overlays digital content onto the real world. Unlike virtual reality, which fully replaces your environment, augmented reality enhances what's already there. For example, smart glasses or smartphones that show turn-by-turn directions or other information while you walk around are using augmented reality. These systems rely on cameras, sensors, and display technology to blend the physical and digital worlds together in real time. Exam Objective 2.1 – Explain common computing devices and their purposes. IoT. We have covered the major types of computing devices in the previous video. But what about everything else that is embedded with processing and networking functionality? Well, we have a category for them too. They are classified as IoT devices, where IoT stands for Internet of Things. These things are physical devices, objects, and sensors that are connected to the internet and can collect, exchange, and transmit data. These devices, which can range from everyday household objects to industrial machinery, come with sensors, embedded operating systems, and network connectivity to enable communication and data sharing. This Internet of Things allows these devices to interact with each other, as well as with humans, to gather and analyze data, automate processes, and enable remote monitoring and control. IoT devices have been deployed in various ways. You can find IoT devices in home appliances, home automation systems, modern vehicles, IP cameras, streaming media devices, and even in medical devices, just to name a few. IoT devices have transformed the functionality of home appliances, including refrigerators, ovens, microwaves, washers, and dryers, making our lives more convenient and efficient. With IoT technology, smart refrigerators can offer features such as tracking food items, their expiry dates, and even suggest recipes based on the available ingredients. Ovens and microwaves equipped with IoT capabilities allow remote control and monitoring through smartphone apps, enabling users to preheat, adjust cooking settings, and receive notifications when meals are ready. IoT-enabled washers and dryers offer remote control and scheduling options, allowing users to start or pause cycles and receive alerts when clothes are ready for the next step. In addition to home appliances, IoT devices have paved the way for advanced home automation. IoT devices for home automation, including thermostats and security systems, revolutionize our living spaces. Smart thermostats offer remote temperature control and energy management, optimizing comfort and efficiency. IoT-based security systems integrate cameras, sensors, door locks, and doorbells for remote monitoring and real-time alerts. These devices enable personalized schedules for lighting, entertainment, and centralized control through mobile apps, enhancing convenience, energy savings, and home security. The use of IoT devices in modern cars has greatly enhanced the driving experience and safety features. Connected car technologies allow for real-time monitoring, analysis, and communication between vehicles and the surrounding environment. IoT-enabled features include GPS navigation systems with live traffic updates, vehicle diagnostics, maintenance alerts. Or my personal favorite, remote lock, unlock, and start capabilities, all from an application on my smartphone. The integration of IoT with IP cameras has revolutionized surveillance and monitoring systems. IoT-enabled IP cameras offer advanced features and functionalities for enhanced security and remote monitoring. These cameras can connect to the internet, allowing users to access live video feeds and recordings from anywhere through mobile apps or web browsers. With the integration of IoT technology, streaming media devices, such as smart TVs, streaming sticks, and set-top boxes have become more than just devices for content consumption. They now offer seamless connectivity, personalized experiences, and a wealth of innovative features. By connecting to the internet, these devices provide access to a vast array of online streaming platforms, allowing users to enjoy their favorite movies, TV shows, and music with ease. Another important area where IoT technology is making a big impact is healthcare. IoT-enabled medical devices, like wearable health trackers, smart implants, and remote monitoring tools, allow for continuous tracking of vital signs, medication usage, and overall patient health. These devices can securely send real-time data to doctors or healthcare systems, helping with early detection, faster response times, and better ongoing care. It's a powerful example of how connected technology is improving lives far beyond convenience. IoT devices are also finding a home in fitness. Many modern exercise machines come equipped with sensors and network connectivity, allowing them to track your heart rate, calories burned, and workout performance in real time. Some equipment even syncs with fitness apps or displays virtual classes and progress reports on screen. It's like having a personal trainer built right into your treadmill or stationary bike. And finally, we have wearable devices. These are small, body-worn gadgets designed to collect and display real-time information. Think smartwatches, fitness bands, and even smart rings. They track everything from steps and sleep to notifications and weather updates right from your wrist. Many of these devices also sync with your phone or cloud account, keeping you connected and informed throughout the day. Wow, now that is a lot to take in. IoT devices really are everywhere. Exam Objective 2.2. Explain the purpose of common internal computing components. Motherboard. A motherboard is the main circuit board in a computing device that connects and allows communication between all the other computing components. Another way to think of it is to consider the motherboard as the backbone of the system that ties a computer's components together. Without the motherboard, none of the computer's parts could interact or function as a whole. This component sits at the center of the system, and every other component must be compatible with it. That includes things like the processor, system memory, and storage devices. And while motherboard is the most common term, you may also hear it referred to as a system board. The motherboard will have built-in functions, like basic graphic support, audio support, and network adapters. It will also offer a range of sockets, slots, and ports to connect all the other components that are needed to make a fully functioning compute device. Exam Objective 2.2. Explain the purpose of common internal computing components. BIOS. The topic of this video is BIOS, but before we can understand BIOS, we need the definition of firmware. Firmware refers to a type of software that's built directly into an electronic device. It provides the most basic control over that device's hardware. Unlike general-purpose software applications that can be installed and uninstalled, firmware is designed to be more permanent and is essential for the basic functioning of the device. Firmware is responsible for managing and controlling various hardware functionalities, such as booting up the device and controlling input and output operations. Overall, firmware plays a crucial role in the operation and functionality of electronic devices, ranging from simple devices like computer peripherals to complex motherboards. In the case of motherboards, the firmware is typically called the BIOS. BIOS is short for Basic Input-Output System and is firmware that is stored on a computer's motherboard. It provides the fundamental instructions and settings necessary for the computer to start up, initialize hardware components, and establish communication between the hardware and the operating system. Without it, your computer's operating system would never get off the ground or launch. Now, while BIOS was the standard for many years, technology doesn't stand still. So let's bring things up to date and introduce you to its modern replacement. On modern motherboards, UEFI, which is short for Unified Extensible Firmware Interface, has become the standard. It is defined exactly like we defined BIOS, it is just newer and has more features. UEFI offers enhanced features and capabilities compared to the older BIOS, including support for larger storage devices, faster boot times, and options for a more secure boot-up process. Additionally, when making configuration changes to the firmware, you will be provided with a graphical user interface, known as a GUI, instead of the text-based interface that was available with BIOS. Here we have a BIOS configuration screen. For now, just notice the text-based interface. And here is the UEFI interface. Now your interface may look a bit different, and that is okay. I just wanted to give you an idea of what to expect when accessing the BIOS or UEFI for configuration purposes. As for accessing the BIOS or UEFI on a computing device, you will need to start or restart your computer. Once powered on, your computer will only be able to access the BIOS or UEFI for a brief period of time. Once the BIOS or UEFI initializes and launches your operating system, the window of time will have closed. Look for a key prompt during the boot process. As your computer starts up, pay attention to the screen for any messages that indicate which key to press to access the BIOS or UEFI settings. Common keys include F1, F2, F10, delete, or escape keys. Press the indicated key before the operating system starts loading and you will be directed to the BIOS or UEFI configuration interface. Exam Objective 2.2. Explain the purpose of common internal computing components. RAM. RAM, or Random Access Memory, is a form of computer memory that stores working data or programs currently in use by a computer. RAM is also the type of memory used for the system memory of most computing devices. In case you forgot by now, I introduced you to the topic of system memory back in Exam Objective 1.1, and to avoid confusion, just think of RAM and system memory as interchangeable. At least for now. Anyways, once a software program is started, its instructions are loaded into the system memory and remain there until no longer needed by the computing device or until the computing device is powered off. System memory is different from long-term storage devices such as hard drives because it provides much faster access to data. When the processor needs to receive or output data, it can interact directly with the system memory, which allows for faster execution of instructions by the processor. The amount of RAM in a computer is an important factor in determining its performance. More RAM allows the computer to store and access larger amounts of data, which is particularly useful when running memory-intensive programs or when several applications are opened simultaneously. On the other hand, insufficient RAM can lead to slower performance, as the computer may not be able to store all the data it needs in system memory all at the same time. Exam Objective 2.2. Explain the purpose of common internal computing components. CPU. The Central Processing Unit, or CPU for short, is the primary component of a computer responsible for executing instructions and performing calculations. The CPU acts as the brain of the computer, carrying out essential tasks such as arithmetic operations and logical comparisons. It interprets and executes instructions from computer programs, allowing the computer to perform tasks and run applications. It is also worth noting that the CPU generates more heat than any other computing component. Probably because it works so hard. Worse, if you work your CPU too hard, it may overheat, which can lead to unexpected reboots or shutdowns. Now, not all processors are created equal. While most laptops, desktops, and servers use powerful, high-performance CPUs, mobile devices like phones and tablets often rely on a different kind of CPU, called an ARM processor. ARM stands for Advanced RISC Machine, and it's built on what's called a reduced instruction set computing, or RISC, architecture. These processors are designed to be smaller, more energy efficient, and generate less heat, which is perfect for compact devices that run on batteries. That's why ARM processors are such a great fit for mobile phones and tablets. The trade-off, though, is that ARM processors offer less processing power compared to their full-size desktop or server counterparts. Still, they get the job done. Exam Objective 2.2. Explain the purpose of common internal computing components. GPU. A GPU, or a graphics processing unit, is a specialized processor designed to rapidly process and render graphics, images, and videos. A GPU will have the primary function of producing visual output to a monitor or other display device. So obviously they are great for gaming PCs. GPUs can be both internal or external. Internal GPUs are integrated directly into the computer's motherboard or as a partitioned portion of a CPU. External GPUs are separate graphics processing units that can be connected to a computer system externally. They are typically housed in an external enclosure and connect to the computer via high-speed interfaces. If a simple GPU is not enough, you can step up your game with a graphics card. Now let me warn you. The terms GPU and graphics card are often used interchangeably by those who are not lucky enough to be taking my course. But I will make sure you know better. A GPU and a graphics card actually refer to different aspects of a computing system. To demonstrate, let me strip off the cooling unit and the cover on the graphics card behind me. That's better. Okay, here is the GPU. It is just a part of the graphics card and only handles the processing. A graphics card is actually much more. A graphics card has its own circuit board, dedicated memory, the GPU of course, and interface ports. One last fact, just like a CPU, a GPU generates a lot of heat too. Let a GPU overheat, and just like a CPU, it can lead to unexpected reboots or shutdowns. Exam Objective 2.2, explain the purpose of common internal computing components. Internal storage. Internal storage refers to the storage drives within a computing device that are used to store digital data. These drives are responsible for holding your files, applications, and the operating system itself. Unlike RAM, which only stores data temporarily while the device is powered on, internal storage provides long-term storage. That means the data stays in place even after the device is turned off. Because it offers a more permanent storage solution, internal storage becomes the primary location for critical system files, installed programs, user documents, and more. Whether you're saving a photo, launching an application, or booting up your operating system, it's the internal storage that makes it all possible. Two common types of internal storage drives are the hard disk drive and the solid-state drive. These are among the most widely used solutions for storing operating systems, software, and user data. You'll also encounter other storage options like NVMe drives, optical drives, and external flash drives. These drive types and a few others will be explored in more detail when we reach Exam Objective 2.3. For now, it is sufficient to understand that internal storage provides long-term access to data, making it essential for running your system and saving your files. Exam Objective 2.2, explain the purpose of common internal computing components. NIC. A NIC, or Network Interface Card, is a computer hardware component that allows a computer to connect to a network or other computing device and acts as a communication link enabling the transfer of data. The primary function of a NIC is to convert the digital data generated by the computer into electrical signals that can be transmitted as an output. Also, they need to be able to receive data by converting electrical signals back into digital data as an input. NICs can come in many different forms. When classifying NICs, the first thing we can consider is whether they are wired or wireless. Wired NICs use physical cables, such as Ethernet cables, to establish a network connection. They generally offer faster and more reliable data throughput rates. Wireless NICs, on the other hand, utilize wireless technologies, such as Wi-Fi, Bluetooth, NFC, or even cellular to connect to a network without the need for physical cables. You can also classify NICs into two more groups. They can be integrated into the motherboard of a computer. We refer to these as onboard NICs, or they can be added as a separate expansion card or add-on card. An integrated NIC is built directly into the motherboard of the computer. It is already present and does not require any additional installation. This may seem like a benefit, but it does pose some restrictions as we lose the ability to upgrade in the future. Add-on NICs, however, can be easily replaced or upgraded. If you want to change or upgrade your network connection, you can simply remove the existing add-on NIC and install a new one. Exam Objective 2.3, compare and contrast storage types. Volatility. Storage volatility refers to the degree to which stored data will remain accessible over a given period of time. In general, storage volatility can be categorized into two main types: volatile storage and non-volatile storage. Volatile storage refers to a type of storage that requires a continuous power supply to retain data. Random access memory, or RAM, is the most common example of volatile storage. When the power is cut off or the system is turned off, the data stored in volatile storage is lost. making this your temporary storage option. Non-volatile storage, on the other hand, refers to a type of storage that retains data even when power is lost or the system is turned off. Examples of non-volatile storage include hard disk drives, solid-state drives, NVMe, optical disks, and flash drives. This is your more permanent storage option, ideal for saving your operating system, applications, and files you want to keep even after the device shuts down. Exam Objective 2.3 Compare and Contrast Storage Types. In this video segment, I will be covering the various storage types used to store digital data. There are several types of computer storage, each with their own characteristics, including speed, capacity, volatility, which we just covered, and cost. To align with the CompTIA Tech Plus Exam Objective 2.3, I will break these into 3 specific storage categories. These categories will be local device storage, local network storage, and cloud storage. Now let's learn more about each of these categories. Local device storage encompasses hardware components used to store data on a computer device locally, as opposed to remotely or on another device. The types of local device storage we will cover in upcoming video segments will include hard disk drives, solid-state drives, NVMe, optical drives, and flash drives. Next up, we have local network storage. Local network storage refers to the various types of storage systems that are accessible over a local area network connection, allowing multiple devices to share and access stored data. The types of local network storage we will cover for the CompTIA Tech Plus exam include file servers and network-attached storage. The last storage category we will discuss is cloud storage. Cloud storage refers to the practice of storing and managing data on remote servers accessed over the internet. It involves using the infrastructure of a cloud service provider, which maintains large-scale data centers to store and protect the data of individuals and organizations. Some of the largest cloud service providers are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. In the following video segments, we will further discuss each storage type with greater detail, with the exception of RAM, as this topic was covered in Exam Objective 2.2. Exam Objective 2.3 Compare and Contrast Storage Types. Hard disk drive. A hard disk drive, or HDD, is a type of local device storage where digital data is stored magnetically on a spinning disk. HDDs are known for their large storage capacities and relatively lower cost compared to other storage technologies. They are widely used in desktop computers, laptops, and servers. However, HDDs are mechanical devices and are susceptible to wear and tear over time. They can also be slower in terms of data access and retrieval compared to solid-state and NVMe drives. The basic structure of an HDD consists of one or more magnetic disks or platters that rotate at high speeds. Each platter has a magnetic coating that stores the data. The platters are stacked vertically on a spindle, and the entire assembly is enclosed in a protective casing. To read or write data, an HDD uses a read/write head that hovers just above the surface of the rotating platters. The read/write head moves rapidly across the platter's surface to access the desired data. When reading data, the head detects the magnetic changes on the platter's surface and converts them into electrical signals that can be processed by the computer. When writing data, the head applies a magnetic field to the platter to encode the information. It might go without saying, but keep these devices away from strong magnets, as they could seriously damage your HDD drive. Exam Objective 2.3 Compare and Contrast Storage Types. Solid-state drive. A solid-state drive, or SSD, is a type of local device storage where digital data is stored on non-volatile flash memory chips. SSDs have many benefits when compared to HDDs. First, SSDs are faster. That means they can access and store data at a higher rate. They are also more resistant to physical shocks, vibrations, and extreme temperatures due to their lack of mechanical components. Additionally, with no moving parts, SSDs can operate silently. While SSDs offer many advantages over traditional HDDs, they are generally more expensive per unit of storage. However, the cost of SSDs has been decreasing over time, making them more affordable and popular for both personal and professional use. The main component of an SSD is NAND flash memory, which is a type of non-volatile memory that can retain data for long periods without the need for power. Access to the NAND flash memory is provided by the SSD controller, which acts as the interface between the computer and the flash memory. The controller manages data read and write operations. The last piece of the puzzle is the cache. To enhance performance, SSDs often incorporate a cache, or high-speed buffer that stores frequently accessed data for quicker retrieval. Exam Objective 2.3 Compare and contrast storage types. NVMe. A non-volatile memory express drive, or NVMe, is a type of solid-state storage designed for high-speed data access using a computer's direct connection to the motherboard. NVMe drives offer several advantages over standard SSDs. Most importantly, they are much faster, especially when reading and writing large amounts of data. This makes them ideal for tasks like gaming, video editing, or any application that demands quick access to files. Because they're solid-state, NVMe drives also operate silently and have no moving parts, just like standard SSDs. One of the most common form factors for NVMe drives is the M.2 interface. This is a small, slim connector built directly into the motherboard, allowing the drive to slide in and lock into place without the need for cables. Because the M.2 form factor connects the drive straight to the motherboard, it saves physical space inside the system and allows for faster communication between the NVMe drive and the rest of the components. That compact design, combined with high-speed performance, makes the M.2 NVMe drive one of the most efficient storage options in modern computing. Exam Objective 2.3 Compare and contrast storage types. Optical drive. An optical drive is a type of local device storage where digital data is stored optically on a spinning disk. Optical drives are classified based on the type of optical disks they can read and write to. The three main types of optical disks are CDs or compact disks, DVDs or digital versatile disks, and Blu-ray disks. As for how an optical drive works, it consists of a tray or slot where you insert the disk. When you insert a disk, the drive uses a laser beam to read the data stored on the disk's surface. The laser scans the disk, reflecting off its surface, and the drive interprets the reflected signals as digital data, such as audio, video, or computer files. Similarly, when writing data to a disk, the optical drive uses a laser to etch or burn information onto the disk's surface. This process creates pits and lands on the disk that represent the data being written. Once the data is written, it can be read by any compatible optical drive. Another topic worth discussing with regard to optical disks is their storage limits. According to the CompTIA official study guide, the maximum storage limit for a CD is 700 megabytes. That is roughly 74 minutes of uncompressed stereo digital audio. The maximum storage limit for a DVD is approximately 17 gigabytes. And the maximum storage limit for a Blu-ray disc is 128 gigabytes. Exam Objective 2.3 Compare and contrast storage types. Flash drive. A flash drive is a portable storage device that uses non-volatile flash memory to store digital data. While it uses the same type of flash memory as an SSD, the key difference is portability. Flash drives are small, compact, and easy to carry, making them perfect for transferring files between devices when network options aren't available. A flash drive may also be called a thumb drive, or a USB flash drive if it has a USB connector. Just like an SSD, flash drives use flash memory, a type of non-volatile memory that retains data even when power is removed. This allows you to store files on the drive and access them later without the need for a continuous power source. Flash drives have a connector or interface on one end, which plugs into a computer, laptop, or other compatible device. The interface provides both data transfer and power to the flash drive, eliminating the need for additional cables or power adapters. Once connected to a computer, the flash drive appears as a removable storage device in the operating system. From there, you can simply drag and drop files or folders onto the drive to store them. Similarly, you can copy files from the flash drive to your computer for accessing or editing. Memory cards can also be considered a form of flash drive. These too use flash memory technology to store and transfer data. However, there are some differences in terms of form factor and usage. Memory cards are typically smaller and thinner than traditional USB flash drives. They are designed to be inserted into specific memory card slots on devices such as cameras, smartphones, tablets, and other computing devices. Common types of memory cards include secure digital or SD cards, mini SD cards, micro SD cards, compact flash cards, and XD picture cards. Exam Objective 2.3 Compare and contrast storage types. Local network storage. In this video segment, we will cover two options for local network storage, starting with a file server. A file server is a type of local network storage in which a general computing device provides centralized storage and file sharing capabilities to multiple users on a network. When a computer is part of a network, any internal or external local drives can be shared with other computers. When a computer shares its directly attached storage, the computer is acting as a file server. To simplify things, a file server is a general computer or server that has been configured with the purpose of sharing and storing files with other computing devices on a local network. While a file server is a general computing device that can be purposed for many different functions, network-attached storage devices, or NAS devices, are a dedicated device with a specific function. NAS devices are primarily focused on file storage and sharing. While they may offer additional features such as media streaming, their primary function is to provide reliable and efficient file storage capabilities. NAS devices are designed to be user-friendly and easy to set up. They often come with a web-based interface that allows users to configure settings, manage file shares, and set access permissions without requiring deep technical knowledge. That is why they are commonly used in home networks, small businesses, and environments where a simple file sharing solution is preferred. Exam Objective 2.3 Compare and contrast storage types. Cloud storage. The last storage category we'll discuss is cloud storage. Cloud storage refers to the practice of storing and managing data on remote servers that are accessed through the internet. Instead of saving files directly to your computer's local drive or a local network storage option, cloud storage uses the infrastructure of a cloud service provider to keep your data safe, secure, and accessible from anywhere. These providers maintain massive data centers that handle everything from storage capacity to backups and security. For users, this means convenience, scalability, and the ability to access their files from multiple devices, whether you're working from home, school, work, or on the go. In an earlier video segment, we discussed some of the largest cloud service providers: Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Now let's narrow it down and talk specifically about cloud storage services. A cloud storage service provides a cloud-based file storage and synchronization service developed to allow users to store, access, and share files and folders across various devices, such as computers, smartphones, and tablets. Now take a peek at the icons behind me. Recognize any? These four services are some of the largest cloud storage services on the market. From left to right, we have Microsoft OneDrive, Google Drive, Dropbox, and iCloud. Chances are, you've used at least one of these already, and if not, you probably will soon. Because in today's world, storage isn't just local, it's global. Exam Objective 2.3 Compare and contrast storage types. Read and write. It is time to break away from the exam objectives for a moment and do a bit of bonus learning in order to discuss read and write. These two actions are fundamental in the world of computing, with applications that stretch across software development, database management, data analysis, and file storage. So, let's start with read. A read operation involves retrieving information from a storage device and bringing it into the computer's system memory for processing. In other words, you're pulling information from storage so it can be used. You might also hear it described using terms like access or retrieve. And because data is coming out of the drive, this action is considered a drive output operation. Now that we've defined a read, let's flip the script and talk about a write. A write operation is essentially the opposite of a read. Instead of retrieving data, a write involves storing or updating information on a storage device. This could mean modifying existing data or adding new data. In simple terms, you're sending data to the drive so it can be kept there for later use. And since information is going into the storage device, a write is considered a drive input operation. It's the other half of the equation that makes data storage possible. Exam Objective 2.3 Compare and contrast storage types. ROM. Now that you understand what it means to read and write data, it's time to introduce a special kind of storage that does only one of those things. It's called ROM. And ROM stands for read-only memory. As the name suggests, ROM is a type of storage that is designed to be read, but not written to. The data stored in ROM is placed there during manufacturing, and it doesn't change. This makes it perfect for storing important information that the system always needs. ROM is also non-volatile, which means it keeps its data even when the computer is turned off. In IT, ROM is often used to store the BIOS or UEFI firmware found on a motherboard. It's also used in embedded systems like printers, routers, and smart devices, where it holds the firmware that controls their core functions. Because ROM can't be easily modified, it's ideal for storing information that must remain consistent and unchanged. Exam Objective 2.4 Given a scenario, install and configure common peripheral devices. Device setup. With Exam Objective 2.4, I will be teaching you about common peripheral devices, basic configuration settings, and some installation types you might encounter along the way. The images I will be using will be based on the Windows 11 operating system. This is because CompTIA exam content and questions will lean more toward Windows than any other operating system. Well, with the exception of the Linux Plus exam, of course. For device setup, Windows 11 has two main utilities: Control Panel and Windows Settings. Together, these tools let you view and change a wide range of system settings. Both utilities include applets that allow you to configure user accounts, manage accessibility features, and adjust network settings. And most importantly for this exam objective, you can use them to add, remove, and configure various peripheral devices. Exam Objective 2.4 Given a scenario, install and configure common peripheral devices. Printer and scanner. We will cover printers and scanners together as they are fairly similar. In fact, it is very often that printers and scanners come packaged together as a single unit known as a multifunction device, or MFD for short. A printer is a peripheral device which makes a physical rendering of digital data, usually on paper, or creates a physical object from a three-dimensional digital model, in the case of a 3D printer. Some of the most common printer types are laser printers, inkjet printers, thermal printers, impact printers, and 3D printers. While a printer outputs digital data, a scanner does the exact opposite. A scanner is a peripheral device that optically scans images or objects and converts them into digital data. The most common scanner types are flatbed scanners and sheet-fed scanners. When connecting a printer or a scanner, we have multiple options available. For a printer or scanner that is directly connected to a computer, also referred to as a local connection, you would most likely use a USB interface. And probably a USB Type-B connector. Though less common, a wireless, Bluetooth connection can also be used as an alternative for a local connection setup. If the printer or scanner is to be made available to an entire network of devices, a wired network connection would be made with an Ethernet CAT cable that uses RJ45 connectors. And last, the wireless alternative for a network connection would be Wi-Fi. In order to add, delete, or configure a printer or a scanner in Windows 11, you would need to open the Windows Settings utility and navigate to Printers and Scanners. From here, you'll see a list of all currently installed printers and scanners. If you need to add a new printer or scanner, simply click the Add Device button. Windows will automatically search for nearby devices and guide you through the setup process. You can also select an existing device from the list to manage it. Once your printer is installed, you'll also have access to several configuration options that can fine-tune how documents are printed. One useful feature is duplex printing. Duplex allows the printer to automatically print on both sides of a single sheet of paper, instead of just one side. This can be a great way to save paper and reduce the overall size of a document, especially for longer print jobs. It's also a more environmentally friendly option. Another option you'll often see is collate. When collate is enabled, the printer keeps multi-page documents in the correct page order, copy by copy. So, let's say you're printing 3 copies of a 3-page report. With collate turned on, the printer will print pages 1, 2, and 3 in order for the first copy, then repeat the same for the second and third copies. Without collate, the printer would print all the page 1s first, then all the page 2s, and finally all the page 3s. That means you'd have to manually sort and stack each set after printing, which isn't ideal, especially for larger print jobs. You can also adjust the orientation of your prints. This setting controls whether the document prints in portrait mode, which is vertical, or landscape mode, which is horizontal. Choosing the right orientation ensures the document fits properly on the page and matches how you want it displayed or bound. Exam Objective 2.4. Given a scenario, install and configure common peripheral devices. Keyboard. A keyboard is a peripheral device used to input data and commands into a computer or other electronic device. It's one of the most essential tools for interacting with a system, whether you're typing a document, entering a password, or using shortcuts to navigate faster. When configuring a keyboard in Windows 11, you will notice the configuration options are spread out between Control Panel and Windows settings. Let's start with the Keyboard Properties applet found in Control Panel. To access it, open the Control Panel and select Keyboard. Once the applet opens, you will be able to adjust how the keyboard responds to your inputs. You can customize things like repeat delay, repeat rate, and cursor blink speed, all of which affect how quickly characters appear when a key is held down or how fast the system responds to rapid typing. Now, for additional keyboard settings, head over to Windows Settings. In this tool, navigate to Time and Language, then select Typing or Language and Region depending on what you're looking for. Here, you can add new keyboard layouts, set a default input language, or switch between different input methods. Exam Objective 2.4. Given a scenario, install and configure common peripheral devices. Mouse. A mouse is a handheld pointing device that allows users to control the movement of a cursor or pointer on a computer screen. It's used to click, drag, scroll, highlight, and interact with elements in a graphical user interface, making it a core part of most computing experiences. When configuring a mouse in Windows 11, you will be able to access the mouse configuration options from either Control Panel or the Windows Settings tool. For now, let's start with Control Panel. To open the Mouse Properties applet, navigate to Control Panel and select Mouse. Here you can adjust button configurations, double-click speed, and customize your on-screen cursor or pointer. You can also control your pointer speed, or how fast the cursor will move across your screen. If you prefer using the Windows Settings app, open Settings, go to Bluetooth and Devices, and then select Mouse. This section offers quick access to basic options like scroll direction, mouse speed, and primary button selection. Exam Objective 2.4. Given a scenario, install and configure common peripheral devices. Camera. A camera is a peripheral device that records video images using a digital sensor. It can be an external device connected through a wired or wireless interface, or it might be built directly into a device, like what you'll find on most smartphones, tablets, laptops, and even some smart TVs. Many cameras also include a built-in microphone, allowing them to capture both video and audio at the same time. The configuration options for a camera in Windows 11 mostly revolve around privacy. After all, no one wants their camera turning on without their permission. To make sure your camera is only used when you want it to be, open the Windows Settings tool, select Privacy and Security, and then click on Camera under App Permissions. From here, you can manage which apps are allowed to access the camera. Now, if you're trying to add a new camera, go to Bluetooth and Devices, then select Cameras. Windows will list any connected cameras and give you the option to troubleshoot, configure, or add a new one. Exam Objective 2.4. Given a scenario, install and configure common peripheral devices. External hard drive. An external hard drive is a peripheral storage device that connects to the exterior of a computing device. These external hard drives are commonly connected using a USB or Thunderbolt interface and are designed to provide additional storage space, above and beyond what a device's internal storage can offer. Configuration options for an external hard drive aren't found in the control panel or Windows settings like many other devices. Instead, all system drives, whether internal or external, are managed using the Disk Management utility. In Windows 11, you can open Disk Management by right-clicking the Start button and selecting Disk Management from the menu. From here, you can view, format, assign drive letters, or partition the external hard drive to suit your needs. This tool gives you full control over how the drive is recognized and used by the system. Exam Objective 2.4. Given a scenario, install and configure common peripheral devices. Speakers and headsets. Speakers are a peripheral output device that convert digital data into audible sound. They allow us to hear music, system alerts, video calls, and any other type of audio generated by the computer. Whether built into a laptop or connected externally through a headphone jack, USB, or Bluetooth, speakers serve as the final stop in the digital audio journey, turning zeros and ones into sound waves we can actually hear. You may also hear them referred to as playback devices, especially when selecting or switching between audio options in your system settings. While speakers handle the output side of things, sometimes you need a little more versatility, especially when communication is involved. That's where headsets come in. A headset is a wearable device that combines both speakers and a microphone in one convenient package. This allows it to function as both an input and output device at the same time. Headsets are especially useful for video conferencing, voice chatting, online gaming, and remote work. Just like standalone speakers and microphones, headsets show up as separate playback and recording devices in your audio settings and can be configured to handle system audio output and voice input as needed. When configuring an audio output device like a pair of speakers or a headset in Windows 11, you have two main options: the legacy sound applet accessible through the Control Panel utility or the modern Windows Settings tool. To open the sound applet, go to the Control Panel and select Sound. In the Playback tab, you can choose which output device you want the system to use. Also, it is common for a computer to have multiple playback devices, so it's a good idea to check here first if you're not hearing sound from the expected playback source. As for the Recording tab, this lets you do the same thing for microphones. Now, if you want to use the Windows Settings tool, you would navigate to System and then Sound. Under the Output section, you'll see a list of available playback devices. Here, you can select the one you want to use and even test the audio directly from this screen. Scroll down a bit further to the Input section, and you will have the ability to manage your recording devices, including which microphone is active. Exam Objective 2.4. Given a scenario, install and configure common peripheral devices. Displays. A display is a peripheral output device that converts digital data into visual images we can see and interact with. Some of the most common types of displays include computer monitors, which are typically connected to desktop computers. Built-in screens, like those found in laptops, tablets, and smartphones. Projectors, which cast images onto a surface, usually a screen or wall, for large-scale viewing. And smart TVs, which combine traditional television functions with internet connectivity and app support. When connecting a display device, we are going to need a graphic device interface. Luckily, we have multiple options available. For older display devices, we have VGA and DVI, and for newer display devices, we have HDMI and DisplayPort. Many of today's displays come with touchscreen capabilities. A touchscreen acts as an alternative to a mouse and/or keyboard. With a touchscreen, a user can interact directly with the display through a series of touches or hand gestures in order to input data. When configuring your display, or displays, in Windows 11, you'll be using the Windows Settings tool. Start by opening Settings, then navigate to System and select Display. From here, you can manage a variety of display-related settings, including scaling options, which control the size of text, apps, and other items on your screen. Display resolution, which determines how sharp and detailed your display looks. Display orientation, which lets you rotate the screen to landscape or portrait mode. And how your device uses multiple displays, whether you want to duplicate your screen, extend your desktop across monitors, or show content on only one screen. Now, let's take a closer look at each of these settings. First up, we have scaling options. This setting controls how large text, apps, and other items appear on your screen. If things look too small to read, or maybe way too big, you can adjust the scaling percentage to better fit your needs. This is especially helpful on high-resolution screens or smaller displays like laptops. It can also make a computer display much easier to see and use for individuals who are visually impaired, helping to improve overall accessibility. Next we have display resolution. Display resolution is a configuration option that adjusts the number of pixels displayed on a screen, thus, determining the level of detail and clarity in the visual content displayed. A pixel can be thought of as a single dot of color. The more dots of color included in a fixed area, the more detail we can achieve. So to understand a resolution, we need to build upon this idea of pixels. Looking at the list of display resolutions to my left, we see the first resolution on the list is 1920 by 1080. The 1920 is the number of pixels or dots of color that a display will have extending from the left side of the screen to the right side of the screen. Thinking of this in a grid or table format, the 1920 would be the number of pixel columns defining the width of the screen in pixels. The 1080 would then be the number of pixels or dots of color that a display will have extending from the top to the bottom of the screen. Once again, thinking of this in a grid or table format, the 1080 would be the number of pixel rows defining the height of the screen in pixels. Put these two numbers together, 1920 by 1080, and you have an overall display resolution defining the width and height in pixel counts. If you multiply the two numbers together, you will also get the total number of color pixels displayed on the screen. So I hope you are a curious learner, and you are now wondering why the word recommended is displayed next to 1920 by 1080. Well, that is a great question. Thank you for bringing it up. For every display, a manufacturer has designed their device to perform optimally at a specific resolution. Even though you can select from many different display resolutions in order to suit your needs, you will always see the word recommended next to the intended resolution for that display. The recommended resolution is also called the native resolution. Moving on, we have display orientation. This setting adjusts the direction or alignment in which content is displayed on a screen. It determines whether the content is displayed in a portrait orientation, meaning vertically, or landscape orientation, meaning horizontally. And finally, to wrap up this exam topic, we will discuss the 3 common configuration options for multiple displays. First, the duplicate option mirrors the same content on all connected displays. This is ideal for presentations or sharing information. Next, the extend option allows a user to drag and arrange windows, applications, and content across multiple screens. This gives a user the flexibility to customize the arrangement, resolution, and orientation of each screen according to their individual needs. And last, there is also the option to display content on only one display at a time. This allows a user to view content on only the primary or PC display, or if desired, just the secondary display, even though 2 displays may be available. Exam Objective 2.4, given a scenario, install and configure common peripheral devices. Installation types. Our first installation type for peripheral devices is plug and play. Plug and play refers to an installation type that allows a peripheral device to be easily connected or installed without the need for complex configuration, setup processes, or software installation. As the name suggests, just plug in the device and it's ready to go. This installation type allows for seamless integration and immediate functionality, reducing the need for an average user to be technically proficient. There is a downside though. With a plug-and-play installation, you will only have access to basic peripheral device features. The next installation type involves the installation of a device driver. A device driver is a software program that facilitates communication between a computing device's operating system and a specific peripheral device. The device driver acts as a translator, allowing the operating system to understand and utilize the features and functions of our peripheral device. Installations requiring a device driver to be installed results in a slower overall installation process and requires the installer to be technically proficient. The upside is that you will be able to access a device's complete range of features. To help compare a plug-and-play installation to a manual driver installation, I have selected the mouse peripheral type. And before you ask, no, this is not a plug for the HP, FC0-G160 gaming mouse. The graphic just fit the scenario and layout well. Okay, so let's start with the mouse on the left. It will have the ability to left-click, right-click, and scroll. These are features that can be found on most every mouse. So why would a peripheral device manufacturer or operating system developer want to make a user go through the process of locating and installing a custom device driver to get this mouse to work? Why not have a stripped-down version of a driver already loaded and available in the operating system? Voila, that is plug and play in a nutshell. Now the mouse on the right has a bunch of custom features and additional programmable buttons. Well, we cannot expect the operating system to be prepared with every possible feature for every device on the market, so a more specialized device, like the mouse on the right, will come with a device-specific driver that you would need to manually install on the operating system in order to unlock the bonus features. Without the custom device driver, you could still use the mouse, but only those most basic features of left-click, right-click, and scroll. The last installation type we'll cover is IP-based installation. IP stands for Internet Protocol, which is the language devices use to identify and communicate with each other on a network. Each device on the network, like a computer, printer, or camera, is assigned its own unique IP address. With IP-based peripherals, such as network printers, IP cameras, and some scanners, installation takes place over this network connection rather than plugging directly into your computer. These devices use their IP address to connect and communicate with other systems on the same network. This kind of setup is especially helpful in office environments where multiple users need access to the same device, all without the need for individual physical connections. And since these devices live on the network, many of them are configured through a web-based interface. Just open a web browser, type in the device's IP address, and you'll be taken to a setup portal. From there, you can adjust settings, update firmware, and manage features, all without needing to install extra software. It's a simple, flexible way to manage and maintain network-connected peripherals. Exam Objective 2.4, given a scenario, install and configure common peripheral devices. Power redundancy. While we are supposed to discuss the uninterruptible power supply at this point in the course, I have decided to go above and beyond and cover the broader topic of power redundancy. Power redundancy, within the context of information technology, refers to the strategy of ensuring that systems remain operational even if the primary power source fails. And in the world of IT, we have a multi-layered approach to ensure you're never left in the dark. One of the primary ways to achieve power redundancy is through redundant power supplies. Consider a server in a data center. Instead of relying on just one power supply, which could become a potential point of failure, the server is equipped with 2 or more power supplies. If one fails or encounters an issue, the other takes over, ensuring the server continues its operations without interruption. In situations where there are sudden and unexpected power interruptions, a UPS, or uninterruptible power supply, becomes an invaluable asset while providing a certain level of fault tolerance. A UPS is a device designed to provide immediate and uninterrupted emergency power to connected equipment when the main power source is lost. This seamless transition of power is especially important in IT environments, where servers are constantly processing and transmitting data. Even a momentary power disruption can lead to unsaved data being lost or systems shutting down improperly, which can cause potential damage. When there's a sudden loss of power, a UPS instantly kicks in, ensuring that there's no break in the electricity supply. This immediate response allows IT professionals the time to either switch to a longer-term power solution, like a generator, or to safely shut down systems and save critical data. In situations where power outages extend beyond just a few minutes, the importance of having a reliable long-term backup power solution becomes evident. This is where a generator steps in as a savior. A generator, in its essence, is a marvel of engineering that transforms mechanical energy, often derived from fuel sources like diesel or gas, into electrical energy. This conversion ensures that even when the regular power grid fails, businesses and operations don't have to. When the primary power source is compromised, a generator can be activated either manually or automatically to take over the role of supplying electricity. However, it's important to note that a generator's response is not instantaneous. There's typically a brief delay before it fully powers up and starts delivering electricity. Now, both UPS devices and generators are essential for maintaining uninterrupted power. While the UPS provides immediate backup to prevent any power interruptions, the generator offers a solution for extended outages. By using both, you will have established a comprehensive power backup system. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. When dealing with computing components, an interface is a physical connection across which two or more separate components of a computer system exchange information. Each interface type will conform to a standard. These standards are really what we will be talking about in this exam objective. The interface standards create a uniform way of encoding, transmitting, receiving, and decoding the binary bits being sent from one computing device to another. For the CompTIA Tech Plus exam, we will be grouping device interfaces into 3 categories. These 3 categories are: networking interfaces. Networking interfaces will allow communication from one computing device to another computing device. An example would be an interface that creates a connection from a laptop to a smartphone. The second category is peripheral device interfaces. Peripheral device interfaces will allow communication from a computing device to a peripheral device. An example would be an interface that creates a connection from a laptop to a printer. And the third category is graphic device interfaces. Graphic device interfaces will allow you to transmit visual data for display purposes from a computing device to a graphic device. An example would be an interface that creates a connection from a desktop PC to a computer monitor. With our 3 categories aside, we can also classify interfaces as being either wired or wireless. Wired interfaces will require a cable to extend between 2 devices. These cables will terminate with a connector, and these connectors will plug into a port on the device. Now let us quickly sort out the difference between connectors and ports. A connector is the side of a connection with a pin or pins. In the graphic displayed, the connectors for many common computing interface standards are lined up along the bottom. A port is the side of a connection with a hole or holes. In the graphic behind me, the ports for many common computing interface standards are lined up just above their corresponding connectors. Plug the connector into its port and we now have a physical connection with which to transmit data. For desktop computers, you may have ports on the front and back of the case, while laptops will typically have ports positioned around the edges of the case. Then there are the ports on a smartphone, tablet, television, projector, printer, and so on. Quickly, you begin to see computing ports are everywhere. Thank goodness there are interface standards that keep device manufacturers all on the same page. If there is no cable, connector, or port we can see, then our interface must be wireless. Now before going any further, I would like to address a big misconception about wireless. Wireless does not mean a physical connection does not exist. Wireless connections use radio frequencies, or RF for short. Radio frequencies are an electromagnetic signal used to connect computing devices without wires. This electromagnetic connection, even though invisible to the eye, is still a physical property that allows information to be transmitted from one computing device to another and is therefore classified as a physical interface. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. Electrical signals. In this video segment, I would like to do some more bonus teaching. While electrical signaling is not an official CompTIA Tech Plus exam topic, it will help with your understanding of interfaces, especially graphic interfaces. So what is an electrical signal? An electrical signal is when electricity is used to convey information. This is usually accomplished by manipulating the electrical property, voltage, up and down, as it travels across a medium, such as a copper wire. The most basic example of this was sending Morse code across a wire back in the day. As for the electrical signals themselves, there are 2 main types: analog signals and digital signals. An analog signal is a signal that produces a smooth and continuous curve. In this type of signal, the binary ones and zeros that we transmit are represented by the highs and lows of the signal voltage. Here is a visual example of an analog signal. Notice how the signal produces smooth and continuous upward and downward curves. Unlike analog signals, a digital signal represents data as a sequence of discrete values where binary zeros and ones are represented by the presence or non-presence of voltage. An upside to digital signals is that they support higher data throughputs. This is probably why digital signals have mostly replaced analog signals in present-day computing. Here is a visual example of a digital signal. We can see that the gradual increases and decreases in voltage are replaced with discrete values, causing the square corners you see in the signal. Great, now you know the basic difference between analog and digital signals. Now keep an eye out for analog and digital signals as we move forward with this exam objective. You are sure to see it again. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. RJ45. RJ45 is a wired networking interface standard that has been around since the late 1980s. RJ45, where the RJ stands for registered jack, is a common connector used to terminate Ethernet CAT cables, which are the most common internet cables in use today. The RJ45 connector has 8 pins or positions into which wires can be inserted. Just to make sure I didn't lose you when I mentioned CAT cables a moment ago, here is a quick breakdown. Category or CAT cables are a type of twisted pair cabling. Inside a CAT cable are 8 individual wires. These wires are grouped into 4 pairs. Each pair is color-coded and then twisted together. The cable is then terminated with an RJ45 connector. Most of you have likely experienced these twisted pair CAT cables, also referred to as Ethernet cables, when connecting your home router to the internet or your computing devices to the router. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. SFP. SFP stands for Small Form Factor Pluggable, but don't let the long name scare you. At its core, an SFP is just a modular network port that lets you choose the type of connection you want to use. Pretty cool, right? While it might not show up on your home router, SFP is a big deal in enterprise networks and data centers. It gives network engineers the flexibility to plug in different modules, depending on the type of network connection they need. Here's how it works. Some network devices come with a small empty slot called an SFP port. On its own, the port doesn't do anything, it needs an SFP module to be useful. An SFP module is a small, removable piece that slides into an SFP port and determines what kind of cable and connection type the device will support. If you want to connect to another device using a fiber optic cable, which is great for long-distance, high-speed data, you would insert a fiber SFP module. On the other hand, if you're just connecting over a short distance using a standard Ethernet cable, you would insert an Ethernet SFP module instead. The key thing to remember is this: the port itself stays the same, but what it does depends entirely on the type of SFP module you plug into it. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. Networking tools. Before we move on to wireless network interfaces, let's take a quick detour and focus on 2 essential tools used in wired networking. These tools help ensure that the physical parts of a network, like the cables and connectors, are set up correctly and working the way they should. The 2 tools we'll cover are the crimper and the cable tester. Let's start with the crimper. A crimper is a hand tool used to attach a connector to the end of a cable. In general, crimping is how you physically bond the wires inside a cable to the metal pins inside a connector, so data can flow through the connection properly. To make this more concrete, let's walk through a common example, such as making your own Ethernet cable using a CAT cable and an RJ45 connector. First, you cut the cable to the length you need. Then, you carefully strip off the outer jacket to reveal the 8 individual wires inside. These wires are arranged in a specific color-coded order, then slid into the RJ45 connector, that's the clear plastic plug used on Ethernet cables. Once everything is lined up correctly, you place the connector into the crimper tool and squeeze. The crimper pushes small metal pins down into each wire, locking them into place and creating a solid electrical connection. If you skip crimping, the cable won't work, there's no complete path for the signal to travel through. So crimping transforms a loose set of wires into a fully functional network cable. Crimpers are especially useful when you need custom cable lengths, are replacing a damaged connector, or are working in an environment like an office or data center where neat and precise cabling matters. Now let's talk about the tool that helps you check if a cable is working properly, the cable tester. A cable tester sends a signal through the cable and checks whether the wires inside are connected correctly. If there's a break in the wire, a short circuit, or if the pins are out of order, the tester will let you know something's wrong. This tool is especially helpful when troubleshooting a connection issue, because sometimes, the problem isn't with the device or the settings. It's the cable. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. Bluetooth. Bluetooth is a wireless networking interface and peripheral device interface standard that was introduced in 1998. Bluetooth uses radio frequencies to transmit and receive data over a short distance of a few meters. That makes this wireless networking interface perfect for connecting devices that are relatively close together, like pairing your smartphone with wireless earbuds, a keyboard, or a portable speaker across the room. To establish a Bluetooth connection, start by opening the Settings menu on your device. This process is generally the same whether you're using a computer, smartphone, or tablet. After that, the steps may vary slightly depending on the device, but the general process is the same. First, make sure Bluetooth is turned on. This activates the built-in antenna so your device can search for and communicate with other nearby Bluetooth-enabled devices. Once Bluetooth is enabled, you'll be able to scan for available devices and complete the pairing process. Next, you will need to search for and select the device you would like to pair or bond with. Pairing is the process of establishing a Bluetooth connection between two devices. For the last step, some devices will use an authentication passcode for security. If used, this passcode will be displayed at the time the pair request is initiated. At this point, just enter the passcode to accept the connection. Once the pairing process is complete, and any required passcode has been entered, you're ready to start using the Bluetooth connection. But what exactly can you do with it? Bluetooth is a versatile interface standard that supports both networking and peripheral device connections. That's right, it pulls double duty. On the networking side, Bluetooth can be used for tethering, which means sharing an internet connection from one device to another. It can also handle file sharing, allowing you to transfer files between two Bluetooth-enabled devices. Just keep in mind, Bluetooth has relatively low data speeds, so it's not ideal for large files. As a peripheral device interface, Bluetooth is commonly used to connect things like keyboards, mice, speakers, printers, and even game controllers, all without the need for cables. As long as the devices are within a few meters of each other, Bluetooth makes the connection clean, simple, and wireless. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. NFC. Near-Field Communication, or NFC, is a wireless networking interface standard that was introduced in 2003. It uses radio frequencies to share data, but only over a very short distance, typically just a few centimeters. NFC has many different applications, but by far the most common is contactless payment. Think about how often you pull out your credit card or smartphone and tap it against a payment terminal. Each time you do, you're using NFC to send your payment information securely to the device. It's fast, easy, and built into more of your daily routines than you might realize. NFC creates a one-to-one connection that supports bidirectional communication, meaning both devices can send and receive data. This allows for real-time interaction, where each device not only sends information but also receives a response immediately. This two-way exchange is what makes NFC useful for more than just simple transfers. It enables fast, seamless transactions and confirmations. On top of that, NFC includes built-in security protocols that help protect your data during the exchange. These security features are especially important when NFC is used for sensitive actions like contactless payments or identity verification. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. 802.11x. To understand the topic 802.11x, we first need to talk about Wi-Fi. Wi-Fi, short for wireless fidelity, is a wireless networking interface technology that allows computing devices to connect to and communicate with other computing devices wirelessly. It's most commonly used in homes, small offices, coffee shops, airports, just about anywhere you need wireless network access. Now that we've defined Wi-Fi, let's talk about how it's standardized. Wi-Fi is not just one fixed technology, it has gone through many improvements and versions over the years. These versions are based on a series of standards, all beginning with the numbers 802.11. These standards define how devices communicate wirelessly, including things like speed, frequency, signal strength, and range. These standards are created by a professional organization called the IEEE, which stands for the Institute of Electrical and Electronics Engineers. The IEEE is responsible for developing and maintaining many of the world's most important technical standards, especially in fields like networking, telecommunications, and computing. Since Wi-Fi first hit the scene in 1997, the IEEE has introduced several versions of the 802.11 standard, like 802.11a, b, g, n, ac, and the more recent 802.11ax. Each version has brought faster speeds, better performance, and improved reliability. Now, let's talk about 802.11x. This term might sound like a specific version, but it's actually not. 802.11x is often used as a placeholder or shorthand to refer to any of the 802.11 wireless standards. Think of the X as a variable, it simply stands in for whatever letter version you're discussing. So if someone says 802.11x, they're not referring to a specific version. Instead, they're referring to the entire family of wireless networking standards under the 802.11 umbrella. This kind of shorthand is helpful when you're talking about Wi-Fi in general, or when you don't need to get into the specific technical differences between the various versions. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. USB. USB, or Universal Serial Bus, is a wired peripheral device interface standard that was first introduced in 1996. And true to its name, it has been adopted almost universally. Today, USB is everywhere. You'll find it on desktops, laptops, smartphones, tablets, printers, game consoles, and more. It's become the go-to standard for connecting all kinds of computing and peripheral devices. But what exactly makes USB so popular and widely used? Sure, the shape of the connector plays a role in its familiarity, but there's much more to it than that. What really sets USB apart is the built-in functionality that makes it incredibly easy to use, reliable, and versatile across a wide range of devices. Let's take a look at 3 key features that explain why USB became the global standard for connectivity. Feature number 1, Plug and Play. USB devices are designed to be plug and play, which means your computer can automatically detect and configure the device as soon as you plug it in. There's no need to install drivers manually or go through complicated setup steps. Just plug in the USB device, like a flash drive, mouse, or webcam, and you're ready to go. This feature completely changed how we interact with hardware, making it much more convenient and user-friendly. Feature number 2, Hot Swappable. USB devices are also hot swappable. This means you can plug or unplug a USB device while your computer is still on. No need to power down or restart the system. This makes it easy to switch out accessories on the fly, whether you're grabbing a new keyboard, connecting a phone to charge, or plugging in a USB drive to move files. Feature number 3, Power Delivery. USB doesn't just handle data transfer, it also supplies power to devices. That's why you can charge your phone through a USB port or power an external device without needing a separate adapter. A standard USB cable contains 4 copper wires, 2 for data, send and receive, and 2 for power, positive and ground. This dual function, data and power in a single connection, makes USB incredibly efficient and versatile. Now that we've covered what makes USB such a powerful interface standard, let's take a quick look at the different types of USB connectors and ports you might encounter. Most of them will probably look familiar, so I will just cover what is needed for the CompTIA Tech Plus certification exam. First, USB Type-A is the classic rectangular plug you've seen for years. Next, there is USB Type-B. This might not be familiar to everyone. It's bulkier and mostly found on older printers and external devices. Not exactly a fan favorite, but it played its role for a little while. Then we have USB Type-C, which has quickly become the go-to standard for modern devices. One of the first things you'll notice about USB-C is that it's reversible or non-keyed. That means you can plug it in either direction. But USB Type-C isn't just about convenience. It's also incredibly versatile. In addition to handling power and data, USB-C can also carry video and audio signals. That's right, USB-C can function as a display interface, letting you connect directly to monitors, projectors, and even docking stations. This means a single USB-C cable can deliver power, data, video, and audio all at once. It's a cleaner, more efficient solution that reduces cable clutter and simplifies your entire setup. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. Thunderbolt. Thunderbolt is a newer wired interface standard that stands out for its versatility. It functions as a networking interface, a peripheral device interface, and a graphical device interface, all in one connection. Originally developed by Intel in collaboration with Apple, Thunderbolt was first released in 2011. In its early days, Thunderbolt was used primarily with Mac workstations and laptops, making it especially popular among creative professionals who needed fast data transfers and high-resolution display support. However, over time, Thunderbolt has expanded well beyond the Apple ecosystem and is now supported on many Windows-based systems and high-end PCs as well. Thunderbolt builds on many of the great features already offered by USB, such as hot swapping, power delivery, and plug-and-play support. But what really sets it apart is its speed and bandwidth. Thunderbolt supports ultra-fast data transfer rates, can power external devices, and can transmit video to multiple high-resolution displays, all through a single cable. Another cool feature is Thunderbolt's ability to connect two Mac devices together by forming a network connection, known as a Thunderbolt bridge. This is what makes Thunderbolt a networking interface. Thunderbolt's latest versions have even become compatible with USB and even use the USB Type-C connector. Uh-oh. How do you avoid confusion then? Easy. Look for the Thunderbolt icon next to the port. Without the Thunderbolt icon, you will not get Thunderbolt's bonus features. One more detail about Thunderbolt, like USB-C, Thunderbolt connectors are reversible or non-keyed, meaning you can insert a Thunderbolt connector into its port with either side facing up. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. Lightning. Another common wired connection type you'll come across is the Lightning connector. Lightning is a wired peripheral device interface standard that is exclusive to Apple devices. It was introduced in 2012 as a replacement for the older 30-pin connector and has become the standard charging and data port for iPhones and some iPads and accessories. Lightning supports both data transfer and device charging, making it a compact and versatile connection. It's a sleek, slim connector that can be used for everyday tasks like syncing music, backing up photos, or transferring files from an iPhone to a computer. One of the most convenient features of Lightning is that it's reversible. That means you can plug it in with either side facing up, no fumbling or flipping the cable around. And while Lightning is physically similar in size to USB-C, it remains Apple's proprietary standard, meaning only Apple and approved manufacturers can produce compatible accessories. So while many newer Apple devices, like iPads and MacBooks, are switching to USB-C, Lightning is still widely used on iPhones and various Apple accessories. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. VGA. VGA is short for Video Graphics Array and is a graphic device interface standard that was released in 1986 and was very popular with older computing devices. This standard is not the oldest graphic interface standard, but is the oldest one we will cover for this CompTIA Tech Plus exam. Some useful facts about this standard are that it uses a 15-pin connector that is often signified by the color blue. The standard is designed to transmit video only. So if you want audio too, you are going to need another interface and cable for that. VGA also uses analog signals to transmit data. Now, we discussed in the electrical signals video that analog signals do not transmit as fast as digital signals. As a byproduct, the use of analog signals with the VGA graphic interface standard causes it to be incapable of supporting higher resolutions, or the amazing graphics that we have become accustomed to. No HD or high-definition images with this standard. The VGA standard also separated and individually transmitted the colors of red, green, and blue, or the RGB color values. This has led to some strange troubleshooting issues over the years. For example, damaged cables would cause screens to render colors incorrectly. In the case of this screen image behind me, it is very possible that the wire responsible for transmitting the green color values has been damaged within the VGA cable, leaving only the red and blue values. The same issue can also occur if the pins in the connector have become bent or broken. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. DVI. Digital Video Interface, or DVI for short, is a graphic device interface standard that was released in 1999. That was over a decade after the release of the VGA standard. DVI had the main job of bridging the gap between old and new. Older display devices were using analog signals, while manufacturers were pushing to release newer display devices that utilized digital signals, in order to provide higher resolutions, or output better quality graphics. Improving upon VGA, the DVI connector came with a possible 29 pins. With more pins came more possibilities, including the ability to solve the problem manufacturers were faced with. With these additional pins, DVI was able to transmit and receive both analog and digital signals. Still no audio though. With up to 29 pins at its disposal, the DVI standard comes with 5 different variants. As I stated previously, DVI supports both analog and digital signals. So here is how we keep things organized. DVI-A is the analog variant. DVI-A transmits only analog signals. It is designed to transmit video signals in a manner similar to a VGA connection. DVI-D is the digital variant. DVI-D transmits digital signals only, and its connectors can come in different configurations, such as single-link or dual-link. In single-link DVI, there is only one channel or pathway available for transmitting data, and dual-link has 2 channels. With a second channel, higher quality graphics can be achieved. It sure seems like we are always on a quest for bigger and better graphics. Okay, now for the last variant. DVI-I. With DVI-I, the second I stands for integrated. This variant is a hybrid interface that combines both analog and digital signals in a single connector. DVI-I also offers single-link and dual-link configuration options, but these options are only supported by the digital half of this variant. That was a lot of information and worthy of a quick summary. So remember, DVI-A transmits analog signals. DVI-D transmits digital signals. And DVI-I transmits both analog and digital signals. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. HDMI. In 2004, the HDMI graphic device interface standard was released. HDMI stands for High Definition Multimedia Interface, and it comes with a 19-pin connector. Now the name, High Definition Multimedia, really says it all. HDMI supports multimedia, or audio and video in one interface. No longer do we need a second cable to transmit audio data. This standard was immediately adopted by television manufacturers and then quickly spread to all display devices. Today, it is the most widely used graphic device interface. Also, as the name implies, it supports high-definition resolutions or high-quality graphics. The HDMI standard also dropped analog signaling altogether and is fully digital. The HDMI graphic device interface standard's connectors come in 3 different sizes to accommodate various devices and their space limitations. The standard HDMI connector, shown on the left, is the most common and is found on most consumer electronics such as TVs, Blu-ray players, and gaming consoles. On the other hand, smaller devices like tablets, smartphones, and some cameras often use the smaller mini HDMI connector, shown in the middle, or the micro HDMI connector, shown on the right. Exam Objective 2.5, Compare and contrast common types of input and output device interfaces. Display port. A few years after the release of HDMI, in 2008, we were given the DisplayPort graphic device interface standard. Since 2008, DisplayPort and HDMI have been battling it out for top spot. In fact, the battle is so heated, many manufacturers are providing both HDMI and DisplayPort interfaces on their computing devices to allow users to choose for themselves. So let's cover the basics of DisplayPort. It comes with a 20-pin connector, provides audio and video data streaming, and uses digital signaling. Sounds a lot like HDMI, doesn't it? So how are these two standards different? Well, the DisplayPort standard is free to use, or open source. While the HDMI standard charges the manufacturers a small fee per device for its use. One last note, DisplayPort has a mini cousin. The Mini DisplayPort. This connector was developed by Apple and provides a smaller physical interface that is great for smaller computing devices that have very little space for ports. A few examples of devices that use the Mini DisplayPort interface are MacBook Pro, MacBook Air, and MacBook Mini. Also worth noting, Mini DisplayPort is gradually being replaced in favor of the USB-C and Thunderbolt standards, which offer more versatility and compatibility with a wider range of devices. However, adapters and cables do exist, allowing Mini DisplayPort devices to connect with newer systems using USB-C or Thunderbolt. Exam Objective 2.5 – Compare and contrast common types of input and output device interfaces. Mirroring and casting. This is the final video segment for Exam Objective 2.5. In this segment, we'll look at two common display features found on many modern devices. These features are called mirroring and casting. These features are both used to send content from one device to another, like from a smartphone to a smart TV, but they work in different ways, and it's important to know the difference. Let's start with mirroring. Mirroring is the process of showing the exact contents of your device's screen on another screen in real time. When you mirror a device, the second screen becomes an exact duplicate. Every tap, swipe, and open app appears instantly on both screens. It's like turning your phone, tablet, or laptop into a live projector. This is great for presentations, walkthroughs, or when you want to share your screen exactly as it is. Now let's look at casting. Casting is the process of sending specific content, like a video, photo, or music, from one device to another, without duplicating the entire screen. Instead of showing everything happening on your device, casting sends just the media you choose. Once it's playing, you can often keep using your original device for other things. For example, casting a YouTube video from your phone to a smart TV lets the video play on the big screen, while you continue browsing on your phone. Exam Objective 2.6 – Compare and contrast virtualization and cloud technologies. Virtualization. Virtualization is the process of running one or more virtual machines, or VMs, on a single physical device. A virtual machine behaves like a completely separate computer, with its own operating system, software, and files, even though it runs inside another system. To make this possible, a special type of software called a hypervisor is installed. The hypervisor allows you to create, manage, and run multiple virtual machines on the same device, each in its own isolated environment. Inside each virtual machine, you install something called a guest operating system. The guest operating system is the OS installed inside a virtual machine. It can be different from the main system running on your computer. For example, you could be running Windows on your physical device and have a virtual machine running Linux, macOS, or even another copy of Windows. The guest OS runs independently of the main system, even though it shares the same physical hardware. The operating system running directly on the computer is called the host operating system, and the virtual machines are each running their own guest OS. Virtualization is useful in many situations. It's commonly used to create safe testing environments, where you can try out new software, test code, or even explore another operating system without affecting your main system. Developers also use virtualization to test their applications across different platforms, like Windows, Linux, or older operating systems, all on one computer. Businesses may use virtualization to run legacy software that only works on older versions of an OS, without keeping outdated hardware around. And for everyday users, virtualization can be a simple way to learn about different systems or experiment with settings without the risk of breaking anything on the host device. So let's take a closer look at the hypervisor. A hypervisor is the software that manages and runs virtual machines. It controls system resources, like memory, CPU processing, and storage, and assigns them to each VM. There are two main types of hypervisors. Type 1 hypervisors, also called bare metal hypervisors, run directly on the computer's hardware. They don't require a host operating system and are commonly used in data centers or enterprise environments for high-performance virtualization. Type 2 hypervisors, also called hosted hypervisors, run on top of a traditional operating system. They're more common for everyday users and small-scale setups. Once a hypervisor is installed, you can create virtual machines, assign them resources, and install a guest OS in each one. You can also control how much RAM, how much CPU processing power, and how much storage each VM gets. Heck, you can even set up networking between them. Exam Objective 2.6, Compare and Contrast Virtualization and Cloud Technologies. Deployment Models. When it comes to how technology is delivered and managed, there are three main deployment models you should be familiar with. These models are on-premises, cloud, and hybrid. Each one works differently and offers its own benefits and challenges. Understanding how they operate will help you decide which option is best in different situations. We'll begin with the most traditional option, which is on-premises deployment. On-premises refers to a setup where all technology is physically located and managed at a facility owned or operated by the organization. Everything from servers and storage to networking hardware and software is kept in-house. The company is responsible for installation, maintenance, updates, and security. This approach provides full control over your systems, but it also comes with higher costs and more responsibility. On-premises solutions are commonly found in organizations that deal with strict regulatory requirements or need to maintain full control over sensitive data and internal systems. Now let's move on to the opposite approach, which is cloud deployment. Cloud deployment means the technology and services you use are hosted by a third-party provider and delivered over the internet. You do not own the physical hardware. Instead, you subscribe to the services you need and access them remotely. The provider handles the technical side, including updates, system maintenance, and security. Cloud deployment is a popular choice because it offers greater flexibility and scalability. It allows you to quickly adjust your resources based on demand and avoid the upfront cost of purchasing expensive hardware. If you want a balance between full control and the convenience of the cloud, then hybrid deployment may be the right choice. Hybrid deployment combines both on-premises infrastructure and cloud services to create a blended deployment solution. Some services or data are kept in-house, while others are hosted in the cloud. For example, a company might run critical databases on local servers while using cloud-based collaboration tools for daily work. Or they might keep legacy software on-premises while testing newer apps in the cloud. With hybrid deployment, you get control where you need it and flexibility where it counts. It's a smart option for organizations that want to modernize their systems without giving up everything they already have in place. Exam Objective 2.6, Compare and Contrast Virtualization and Cloud Technologies. Cloud Service Types. Building upon our previous discussion of deployment models, it's now time to learn about the various service types that comprise the cloud computing landscape. Cloud services fall into three primary categories: infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS. These service types represent distinct levels of abstraction and functionality, each offering unique benefits and use cases. Let's explore each of these service types in detail to gain a comprehensive understanding of their functionalities and advantages. IaaS serves as the foundational layer. It grants organizations access to fundamental computing resources like servers, storage, and networking infrastructure. Here, users have the autonomy to build and manage their virtual machines and networks remotely, allowing for seamless scalability according to demand. IaaS liberates businesses from the burden of investing in costly hardware and alleviates the complexities of maintenance, providing a flexible environment for building and hosting their data and applications. Building upon the infrastructure layer, PaaS elevates cloud computing by offering a comprehensive software development and deployment environment. Imagine PaaS as a streamlined construction site where software developers are empowered to build and deploy applications without worrying about the underlying infrastructure. PaaS platforms abstract away the intricacies of configuring servers and managing networking resources, enabling software developers to focus solely on coding. This model accelerates the development lifecycle, fostering rapid application delivery and facilitating collaboration among development teams. At the pinnacle of cloud services lies SaaS. SaaS can be likened to a fully furnished home, where users simply consume ready-made applications over the internet. With SaaS, organizations can access a plethora of software applications, from productivity suites to customer relationship management systems, via web browsers or dedicated clients. This consumption-based model eliminates the need for installation, maintenance, or updates, providing unparalleled convenience and accessibility for users. In essence, cloud services empower organizations to leverage modern computing technologies while minimizing operational overhead and capital expenditures. Whether it's the flexibility of IaaS, the agility of PaaS, or the convenience of SaaS, cloud computing serves as a catalyst for innovation, collaboration, and business growth in today's digital landscape. Moving forward with this topic, you should also understand how responsibility is shared between users and cloud service providers across different service types. In managing a cloud environment, this shared responsibility encompasses various components, including the data center, networking, storage, servers, virtualization, operating system, data, and applications. For infrastructure as a service, users bear more responsibility for managing the operating system, applications, and data. The cloud provider handles infrastructure-related tasks such as data center management, networking, storage, server maintenance, and virtualization management. In platform as a service, the cloud provider takes on more responsibility for managing the underlying infrastructure by including the operating system. Users are primarily responsible for developing, deploying, and managing their applications and data. With software as a service, the cloud provider assumes the majority of responsibility, including managing the entire stack from infrastructure to applications. Users are typically responsible for configuring the application settings and managing user access. This division of responsibility allows users to focus on their core business functions while leveraging the expertise and resources of the cloud service provider. By understanding the shared responsibilities across different service types, organizations can effectively manage their cloud environments and maximize the benefits of cloud computing. Exam Objective 2.7 Compare and contrast common Internet service types. An Internet Service Provider, or ISP, is a company or organization that provides individuals, businesses, and other entities with access to the Internet using a variety of connection types. Depending on where you are, you might use a wired connection like fiber optic, cable, or DSL, or a wireless connection like satellite or cellular. Each method has its strengths, trade-offs, and ideal situations. Technologies vary in throughput speed, price, and availability, so the best choice often depends on your location, your budget, and how you plan to use the Internet. Let's begin with the fastest and most reliable wired option, fiber optic. This type of Internet uses strands of glass or plastic, called optical fibers, to transmit data as pulses of light. Because of this, fiber delivers extremely fast speeds, perfect for streaming, gaming, video calls, and transferring large files. However, it's also one of the more expensive options, both for providers to install and for users to subscribe to. As a result, fiber is mostly found in cities and other densely populated areas where the investment makes financial sense. If fiber isn't available, the next best option is often cable internet. This type of connection uses the same coaxial cables that deliver cable television to provide internet access. Cable offers high speeds that are usually fast enough for most households and small businesses. It's also more widely available than fiber and tends to be more affordable. However, one thing to note is that cable bandwidth is shared with nearby users, so your speeds may slow down during peak usage hours. Another wired option is DSL, short for Digital Subscriber Line. DSL uses regular telephone lines, which makes it widely available, even in areas where fiber and cable haven't been installed. While it's slower than both fiber and cable, DSL is typically the most affordable of the three wired options. It's a budget-friendly choice for basic browsing, email, and light streaming. To get online, you'll need a DSL modem, which connects to your phone line and converts data signals for internet use. When wired connections aren't an option, especially in remote or rural areas, satellite internet is often the go-to alternative. This type uses a satellite dish to connect to communication satellites orbiting the Earth. The biggest advantage is coverage. As long as you have a clear view of the sky, you can get online, making it a great solution for areas with limited infrastructure. However, there are limitations. Satellite internet tends to have higher latency, meaning there's a noticeable delay between sending and receiving data. It's also usually slower, more expensive, and prone to interruptions from bad weather like heavy rain or snow. Finally, there's cellular internet, which uses the same mobile networks that power your smartphone to provide internet access. It works through a built-in antenna in your phone, tablet, or a dedicated hotspot device, allowing you to connect from almost anywhere with a cellular signal. This makes it a great option for staying online while traveling, commuting, or living in areas without reliable wired connections. However, there are a few trade-offs to consider. Cellular internet is often more expensive than other connection types, especially if your data plan has limits or overage fees. Speeds can also vary depending on how close you are to a cell tower, how many users are on the network at the same time, and overall signal quality. Still, for portability and convenience, cellular internet is hard to beat. Exam Objective 2.8 Identify basic networking concepts. Basics of network communication. It is now time to welcome you to the world of network communication. In this video segment, we will embark on a journey to demystify the basics of computer networking and explain their significance in modern computing. So let's dive in by defining the word network. A network is two or more computing devices linked together by some form of transmission medium that enables them to share information. You can also imagine a network as a digital web or virtual highway connecting computers, smartphones, servers, and more. So why are networks so important in modern computing? Well, they form the backbone of our interconnected world. Networks enable us to stay connected with friends and family across the globe, access information on the internet, stream movies, play online games, and collaborate with colleagues remotely. They facilitate the exchange of data, providing a platform for businesses, education, entertainment, and so much more. Now, let's talk about protocols. In the world of computer networking, a protocol refers to a set of rules and standards that govern the exchange of information between devices or systems. It defines how data is transmitted, received, interpreted, and acted upon during communication. Just as we follow social norms to interact with others effectively, devices on a network adhere to specific protocols to ensure seamless communication. Think of protocols as a common language that devices use to understand and interpret each other's messages. Protocols also define how devices identify one another and how errors are handled. They provide a structured framework that allows devices to communicate in a reliable and standardized manner. Without protocols, communication across networks would be chaotic and prone to errors. Exam Objective 2.8 Identify basic networking concepts. LAN and WAN. Networks of different sizes can be categorized in different ways based on their coverage and scale. In this video segment, we will cover the most common network types, starting with LAN. LAN is short for Local Area Network and refers to a wired network that covers a small geographical area, typically within a building, small office, or home. In a LAN, devices such as computers, laptops, printers, and servers interconnect, allowing for the sharing of resources, data, and services within the network. In addition to LAN networks, we have WLAN networks. WLAN stands for Wireless Local Area Network. A WLAN is similar to a LAN, but the key difference is the use of wireless technology for connectivity. Instead of relying on physical cables, WLANs use wireless signals, such as Wi-Fi, to connect devices within a localized area. WLANs may also be connected to a LAN, creating a blended network environment. In this setup, the WLAN acts as an extension of the existing wired LAN, allowing wireless devices, like laptops, smartphones, and tablets, to access the same network resources as wired devices. This includes shared printers, file servers, internet access, and internal applications. By connecting a WLAN to the LAN, the network becomes more flexible and accessible, giving users the freedom to move around while staying connected to the same secure, centralized infrastructure. Now we can move on to WANs, or Wide Area Networks. WANs cover a much larger area than LANs or WLANs. A WAN is a network that spans a large geographical area, typically connecting multiple LANs or remote locations. WANs are used to connect networks across cities, countries, or even continents. They enable long-distance communications and data exchanges between geographically dispersed sites. The Internet itself can be considered a massive WAN, connecting networks worldwide. And just like LAN has a wireless equivalent, so does WAN. The WAN wireless equivalent is a WWAN. WWAN stands for Wireless Wide Area Network. It refers to a wireless network that provides coverage over a large geographical area, typically larger than what a WLAN can cover. WWANs most commonly use cellular networks, such as 3G, 4G, or 5G, to provide wireless connectivity to devices across wide-ranging areas. WWANs may also extend a WAN by providing a method for wireless devices to connect to a WAN network. This is accomplished when a WWAN cell tower has a wired connection to a WAN. Now that we understand what a LAN and WAN are, how do they work together? LANs and WANs are interconnected and complementary components of an overall network infrastructure. LANs serve as the foundation for local communication and resource sharing within a limited area, providing fast and efficient connectivity between devices in close proximity. They enable seamless collaboration, file sharing, and access to shared resources within a building, small office or home. While a WAN extends the reach of LANs by connecting geographically dispersed networks. Together, LANs and WANs create a comprehensive network architecture that enables seamless and scalable communication across both local and global distances. And there you have it. An introduction to LANs, WLANs, WANs, and WWANs, the fundamental network types in computer networking. Exam Objective 2.8 Identify basic networking concepts. Basics of packet transmission. Network data packets are like small envelopes that carry chunks of data across a computer network. When you send or receive information over a LAN or WAN network, it's divided into smaller pieces called packets. These packets contain both the data you're sending and additional information needed to ensure proper delivery. This is the same concept as a company that wants to send a large shipment of goods to another location. Instead of sending the entire shipment in one massive box, they will divide it into smaller boxes, each containing a portion of the goods. Similarly, data is divided into packets, with each packet containing a portion of the total information to be sent. Just as shipping smaller boxes is easier to handle and transport, breaking information into small packets allows for more efficient data transmissions. Now with our theoretical shipment broken down into many smaller boxes, each box will require a label. The label should include additional information to help with successful delivery. Our data packets will do the same. In addition to the data being sent, each data packet will include information such as addressing, sequencing, error checking, and much more. What can I say? Computers like to be precise. Exam Objective 2.8 Identify basic networking concepts. Networking devices. In networking, we have many network devices that help us to connect our different computing devices together. Before learning about the different networking devices, you will need to learn a couple definitions to expand your IT vocabulary. In Exam Objective 2.1, you learned about all the common computing devices, to include mobile phones or smartphones, tablets, laptops, workstations, servers, gaming consoles, and IoT devices. Also allow me to add in printers and voice over IP or digital phones as they do come up a lot too. Now all of these computing devices have a specific classification with regard to networking. They are called end devices. A definition of end device would then be any device that directly connects to a network and is used by individuals or organizations to access or provide information, services, or resources. So if a device is not classified as an end device, it is probably a network device. A network device is any component that facilitates the communication and transfer of data within a computer network. These devices play a crucial role in establishing and maintaining network connectivity, enabling the transmission of information between different end devices, networks, or systems. The network devices we will cover for the CompTIA Tech Plus exam are modem, switch, access point, router, and firewall. Exam Objective 2.8 Identify basic networking concepts. Modem. Hold on 1 second while I try to connect. Just kidding. Okay, time to get back to work. There are many different types of modems, each designed to work with specific transmission media and connection types. To keep things simple, I'll focus on the general function of a modem. And later in this video segment, I will use a common example involving telephone lines and the public switch telephone network to illustrate how a modem works in practice. Okay, so what is a modem? A modem is a network device that connects a computer or LAN using digital signals to an analog-based WAN network. It serves as a bridge between the digital signals used by computers and the analog signals used by communication lines, such as telephone lines or cable lines. Consider a modem to be the gateway between your computer and the vast world of the internet. It's the first point of contact that enables your computer to access online resources and services. Using the image behind me, I will walk you through the process of sending data from one computing device to another computing device across an internet service provider's network. In this case, a telephone network, such as dial-up or DSL. On the far left, we have a workstation that will be sending a data packet. The network interface card on the workstation will send out a digital signal comprised of binary digits. Here the digital signal will be received by the modem on the left, and the modem will perform a process called signal modulation. Modulation is the process of taking an incoming signal, in this case a digital signal, and modifying the signal into another form to be transmitted, in this case an analog signal. The analog signal will then travel across an internet service provider's network until the destination network is reached. Here, another modem will perform a process called demodulation. Demodulation is the reversal of the modulation process. Here, the incoming signal, which is currently an analog signal, will be converted back to a digital signal. Now the network interface of the workstation on the far right can receive the digital signal as an input and process the newly received data packet. Exam Objective 2.8 Identify basic networking concepts. Switch. At the heart of any modern local area network you are likely to find a network switch, or maybe multiple switches if the network is large and complex. A switch is a network device that connects multiple devices within a local area network. It acts as a central connection point, allowing devices like computers, printers, servers, or other end devices to communicate with each other by forwarding data packets on the same LAN. Think of a network switch as a traffic controller in a network. It receives data packets from one device and intelligently forwards them to the intended recipient, ensuring efficient and direct communication between devices within the network. Network switches commonly use Ethernet cables or CAT cables to connect end devices to the ports on the network switch and communicate using the Ethernet protocol. When a device wants to send data to another device within the LAN network, it encapsulates the data into a data packet. This data packet will contain the destination address, the sender's source address, and the actual data or payload being transmitted. This encapsulated data packet is then given the name Ethernet frame. The switch then receives the data packet and examines the destination address. It then uses this information to determine the best path or port to forward the packet to the intended device. This direct forwarding allows for fast and efficient communication between devices. Exam Objective 2.8 Identify basic networking concepts. Access point. In a traditional wired LAN, devices are physically connected using cables and network switches, but in a wireless LAN, we eliminate the need for these cables. This is where wireless access points come into play. A wireless access point, also known as a WAP, is a network device that allows wireless communication between devices in a wireless local area network. Think of an access point as a central connection point that brings wireless connectivity to life. It acts as a bridge between your wireless devices and the network, allowing them to communicate with each other and with the rest of the system. But that's only part of the story. A better question is, how does a wireless access point actually connect to wireless devices and work alongside a wired network? Here's how it works. A wireless access point receives data packets from devices like smartphones, tablets, and laptops. It then transmits that data over the network. At the same time, it takes data from the wired network and sends it wirelessly to connected devices. This two-way communication allows for seamless access to network resources and services without any cables. Connecting to a wireless access point is just like joining a Wi-Fi network. When you turn on your device's Wi-Fi, it scans for available networks. Once it detects the access point, it gives you the option to connect. After you're connected, you can browse the internet, access shared files, or print documents, just like you would on a wired network. So if this all sounds familiar, like something a network switch would do, you're not wrong. A wireless access point is essentially a wireless version of a switch. It provides local connectivity, but without the tangle of Ethernet cables. Exam Objective 2.8 Identify basic networking concepts. Router. Before we dive into what a router does, let's take a quick moment to revisit the concept of computer networking. You can think of a network as a digital highway system, connecting computers, printers, and other devices so they can share information and resources. And just like highways need intersections and traffic signs to keep vehicles moving in the right direction, networks rely on devices like switches and routers to manage the flow of data. A network router is a device that directs data packets between different computer networks. While a switch handles traffic within a single network, routers are responsible for moving data between networks. In most cases, that means controlling what comes into your local area network from the internet and what goes out. It's the router that decides where data should go next, ensuring everything reaches the right destination, even if that destination is halfway across the world. But how does a network router actually work? Well, when a device wants to send data to another device in a different network, it compiles a data packet. These data packets will contain a source address and a destination address. The data packet will then seek out the router. The router examines the packet's destination address, much like reading a street sign, and determines the most efficient path for the data to reach its intended destination. To sum up a router is a gateway, sitting at the edge of a network, controlling inbound and outbound connectivity to other networks. These could be other directly attached LANs, or maybe a WAN connection to the internet. And these routers make decisions based on addressing information found within each and every data packet. Exam Objective 2.8 Identify basic networking concepts. SOHO network. In this video segment, I have some more bonus material to cover. Specifically, the topic of a SOHO network. Having just covered the topics of network switch, access point, and router, I figured now would be a great time to discuss how these devices fit into a smaller setting of a home or small business environment. The type of networking equipment used in a home or small business environment can be described as SOHO, where SOHO stands for small office, home office. This particular type of network will commonly utilize a multifunction network device referred to as a SOHO router. But don't let the name fool you. Though similar in some aspects, this is not like the enterprise-grade router we studied earlier in this exam objective. A SOHO router can perform routing functions, but that is not all it can do. So let's break down the main components that make up a SOHO router. First up, we have the network switch. You may recall that a network switch is a network device that connects multiple devices within a local area network. And yes, the SOHO router has a built-in network switch. It may not have as many ports as an enterprise switch, but it will still function the same. The SOHO router displayed here can only connect 4 computing devices together in an Ethernet LAN. The switch ports are the yellow RJ45 ports inside box number 1. Next, we have the access point. As a refresher, the access point is a network device that allows wireless communications between devices in a network. And yes, the SOHO router has a built-in access point too. It may not support as many wireless clients as an enterprise access point, but it will still function the same. The SOHO router displayed here has an antenna inside box number 2 that can transmit and receive Wi-Fi signals. Lastly, let's talk about the router itself. The router is the gateway between your SOHO network and the internet or ISP. That is where box number 3 comes in. This is your WAN connection. Pretty cool how a SOHO router seamlessly integrates all these components into one compact device. If you are dealing with a limited number of computing devices in your network, a SOHO router would be the perfect choice to provide network connectivity. Exam Objective 2.8 Identify basic networking concepts. Network firewall. Let's imagine our computer network as a fortress. Just like a fortress has protective barriers and guards, a computer network needs a way to safeguard against unwanted intrusions and threats. This is where network firewalls come into play. A network firewall is a network security device that acts as a barrier between a computer network and outside network traffic. It monitors and controls incoming and outgoing network traffic. So, how does a network firewall work? Well, it examines each data packet that tries to pass through it, inspecting its source address, destination address, and content. It compares this information against a set of predefined security rules and policies. If a data packet matches the allowed criteria, it's permitted to pass through and continue towards its destination. However, if a data packet violates any of the security rules, the firewall blocks it from entering or leaving the network. Predefined security rules and policies, in the context of network firewalls, are often implemented using a mechanism called access control lists, or ACLs. An ACL defines the specific criteria that determines whether network traffic will be allowed or denied by the firewall. Access control lists are essentially a set of rules that dictate what types of network traffic are permitted and what types should be blocked. As a data packet is received by a network firewall, the network firewall will compare the data packet against the security rules listed in its access control list. If the data packet does not match any of the allow rules in the access control list, the data packet will be denied. Then the next packet can be processed. The network firewall will again compare the data packet against the security rules listed in its access control list. If the data packet matches an allow rule in the access control list, the data packet will be permitted and forwarded on. Exam Objective 2.8 Identify basic networking concepts. MAC address. I will begin this video segment with the definition of a MAC address, where MAC stands for Media Access Control. Simply put, a MAC address is a unique hardware identification address issued to a networking device at the time of manufacturing. It's like a digital fingerprint for that device within a network. Every device that can connect to a network, including both end devices and networking devices, has its own MAC address. This is also very similar to how automobiles have VIN numbers, or vehicle identification numbers, that are unique to every vehicle manufactured. Now, you may be wondering, how are MAC addresses represented? Well, MAC addresses use the hexadecimal numbering system. Unlike our familiar decimal system with numbers from 0 to 9, hexadecimal uses a base of 16 and includes numbers from 0 to 9 and letters from A to F. If you need a refresher on hexadecimal, this topic was covered in the videos for Exam Objective 1.2. Now let's take a closer look at the structure of a MAC address. A MAC address consists of 12 hexadecimal digits, which is equivalent to 48 binary bits. The first part of a MAC address is the OUI, which stands for Organizationally Unique Identifier. This section comprises the first 6 hexadecimal digits of the MAC address. The OUI helps identify the manufacturer or vendor of the network interface card. The second part of a MAC address is the NIC or Network Interface Controller. It follows the OUI and consists of the remaining 6 hexadecimal digits of the MAC address. The NIC part provides a unique identifier for the device itself within the manufacturer's range of MAC addresses. This portion of the MAC address distinguishes individual devices produced by the same manufacturer. It's important to note that MAC addresses are globally unique. This means that no two devices in the world should have the same MAC address. Manufacturers issue these addresses during the production process. This ensures that each device has its own unique identifier, even if they are made by the same company. This uniqueness is crucial for proper communication and data transmission within a network. Could you imagine if a mailman had to deliver a letter to a specific address, but there were 2 houses with the exact same address? Which one would get the letter? The same holds true for a data packet. If 2 devices were using the same MAC address, which network interface would receive the data packet from the network switch? The switch and I surely don't know. Now, you might be wondering, how are MAC addresses used? Well, MAC addresses play a vital role in the communication between devices on a local area network or LAN. When you send data from your device to another device within the same local area network, the MAC address is used to identify the intended recipient. It helps ensure that your message reaches the correct destination. So why don't we look at this in action? First, we need a data packet to be sent. Luckily, the workstation in the top left of our diagram has a data packet to send to another device in our local area network. Now the workstation needs to encapsulate the data to be sent into an Ethernet frame. The Ethernet frame will include the destination MAC address or the MAC address of the device the workstation will be sending the data packet to. The Ethernet frame will also include the workstation's own MAC address, known as the source MAC address, and finally the data or payload that will be sent with this packet. Next, the data packet will then be sent out of the workstation's network interface card to the network switch. The switch will determine which network path is to be used to reach the device matching our destination MAC address in the Ethernet frame. And if everything goes right, our data packet will finally be delivered. All thanks to the help of MAC addresses. Exam Objective 2.8 Identify Basic Networking Concepts. IP address. By the end of this video segment, you will have a basic understanding of what an IP address is and how it functions in the world of networking. So let's get to it. First up is to define what an IP address is. IP stands for Internet Protocol, and an IP address is a unique numerical identifier assigned to every device connected to a network. Within this definition, the keyword is assigned. An IP address differs from a MAC address in this regard. Where a MAC address is hard-coded into a network interface card, an IP address is logically assigned, can be changed, and even reassigned as needed. Currently, there are two versions of IP addresses in use: IPv4 and IPv6. IPv4, which stands for Internet Protocol version 4, is the older and more widely adopted version. An IPv4 address identifies a device in an Internet Protocol version 4 or IPv4 network. It is worth noting that IPv4 addresses use a specific type of notation called dot decimal notation. Dot decimal notation is a way of displaying a big number in manageable chunks. In the case of an IPv4 address, each address is 32 binary digits long. This is a bit difficult to understand, so let's group this 32 binary digit address into different containers that are separated by dots. This will create 4 sets of 8 binary digits, also known as octets. Next, we will convert each octet from binary to their decimal value equivalents, resulting in a dot decimal notation that is much easier to read. With this dot decimal notation, each octet can range from 0 to 255, providing us with over 4.2 billion numerical combinations. IPv6 addresses are considerably longer than an IPv4 address, at 128 binary digits long. IPv6 addresses also use a different addressing scheme. IPv6 addresses include 8 groups of 4 hexadecimal digits, separated by colons. Each group of 4 hexadecimal digits can also be called a hextet. Next, let's explore how IP addresses are assigned to devices. There are two main methods, static and dynamic. A static IP address is manually assigned to a device and remains constant over time. This is often used for servers, printers, or other devices that need a persistent, unchanging IP address in order to be consistently located by other devices. On the other hand, dynamic IP addresses are automatically assigned by a service called DHCP, which stands for Dynamic Host Configuration Protocol. With dynamic addressing using DHCP, a device receives an IP address from a DHCP server when it connects to the network. This dynamic addressing using DHCP allows for efficient assignment and use of IP addresses. Additionally, dynamic IP addressing using DHCP simplifies the process of getting connected to a network for non-technical users. Instead of manually configuring IP addresses, DHCP automatically assigns an IP address to a device when it connects to the network. This eliminates the need for users to have prior knowledge of networking or IP addressing, making it more user-friendly and convenient. Non-technical users can simply connect their devices to the network and DHCP takes care of the rest. Now let's talk about private and public IPv4 addresses. Private IPv4 addresses are used within local networks, such as your home or office. They are not routable on the internet and are meant for internal communications such as between a workstation and a printer or for an internal corporate web server, known as an intranet. These addresses fall within specific reserved ranges. These private IP address ranges are displayed just above me. Any IPv4 addresses falling within these ranges will be considered a private IPv4 address and will be restricted to use within a LAN or private network. It will be a good idea to remember these ranges as they will show up again and again throughout your IT journey. Public IPv4 addresses behave a bit differently. They are assigned to devices that connect directly to the internet. These addresses are unique globally and allow devices to communicate with each other across the internet. Internet service providers, also known as ISPs, assign public IP addresses to devices connected to their network. Now this is a video that might be worth watching a couple times. We covered the definition of an IP address, the different IP protocols version 4 and version 6, static and dynamic IP address assignment, and the difference between private and public IP addresses. Great job! Oh, and one last piece of knowledge, don't get an IP address and a MAC address confused. An IP address is a unique identifier for a device's network location, while a MAC address is a unique hardware identifier belonging to a network interface card. While an IP address facilitates communication between networks, a MAC address will enable communication within a local area network. Exam Objective 2.8 Identify basic networking concepts. HTTP and HTTPS. Up to now, we have discussed a few basic networking protocols. Networking protocols support the addressing and forwarding of data packets to their intended destinations. With that behind us, we will now switch gears and cover some common application protocols. Application protocols deal with the data or payloads themselves. And I am going to start with a protocol most of us are already familiar with: HTTP. HTTP stands for Hypertext Transfer Protocol and is the foundation of data communication on the World Wide Web. HTTP enables web browsers and servers to exchange information, allowing you to access and view web pages and other resources on the internet. In simpler terms, think of it as a set of rules that allow web browsers and web servers to understand and exchange information with each other. For a moment, imagine you're using a web browser, like Chrome or Firefox, to access a website. When you type the website's address into the URL bar and hit enter, your browser sends an HTTP request to the web server hosting that site, asking for the web page's content. The server then processes the request and sends back an HTTP response containing the requested web page's data. This entire process happens seamlessly in the background, enabling you to see the web page on your screen. This all happens because of the HTTP protocol. Now you should know that HTTP is not a secure protocol. And if you need to access your bank account information or any other sensitive information, you will not want to use HTTP. So what should you use? The answer is HTTPS. HTTPS stands for Hypertext Transfer Protocol Secure and is a secure version of the standard HTTP protocol used for data communication on the World Wide Web. HTTPS incorporates an additional layer of security using encryption to protect the data being transmitted between a user's web browser and a web server. Exam Objective 2.8 Identify basic networking concepts. POP3, IMAP, and SMTP. In this video segment, I will be discussing three essential email protocols: POP3, IMAP, and SMTP. If these acronyms sound like a foreign language to you, don't worry, I will break them down in simple terms. By the end of this video segment, you'll understand how these protocols work together to manage your emails effectively. So let's get started. In the world of computer networking, email protocols are like sets of rules that govern how emails are sent, received, and managed between email clients, like your email app, and email servers, where your emails are stored. So let's imagine your email client is like your mailbox, and the email server is the central post office. The protocols we'll discuss help manage the flow of emails between these 2 points, ensuring a smooth email experience. Our first email protocol is POP3, which stands for Post Office Protocol version 3. POP3 is like the traditional way of receiving mail. When you use POP3, your email client connects to the email server and downloads new messages. The POP3 protocol then removes the messages from the server. It's like fetching your mail from the mailbox and taking it inside your home. Once downloaded, the emails reside on your device, and they're no longer stored on the server. While POP3 is useful for offline access to your emails, one limitation is that your emails are tied to a single device. If you access your emails from another device, you won't see the same messages. Now let's talk about IMAP. IMAP stands for Internet Message Access Protocol. IMAP is a modern, synchronized way of handling emails. When you use IMAP, your email client remains connected to the email server. Instead of downloading and removing the emails, IMAP keeps your emails stored on the server while syncing them with your email client or clients. If you haven't deduced this already, the main advantage of IMAP is that you can access your emails from multiple devices, like your workstation, laptop, or smartphone, and they'll always be in sync. Any changes you make on one device, like reading, replying, or deleting emails, are reflected on all your devices. Now you know 2 different protocols for receiving emails. Do we have a protocol to send emails to? We sure do. Last but not least, let's discuss SMTP, which stands for Simple Mail Transfer Protocol. SMTP is the protocol that handles the sending of emails. When you compose an email and click send, your email client uses SMTP to transfer that email to the email server for delivery. SMTP also ensures that your email is sent to the recipient's email server, which then stores it until the recipient checks their inbox. And there you have it, POP3, IMAP, and SMTP, the protocol trio that manages all your email communications. Exam Objective 2.8 Identify basic networking concepts. FTP, FTPS, and SFTP. I hope you don't mind, but we have a few more protocols that we still need to cover. They are FTP, FTPS, and SFTP. These protocols are considered file transfer protocols, and these protocols are essential for sharing documents, images, videos, and other files between users and servers. To kick things off, I will start with the FTP protocol. FTP stands for File Transfer Protocol. FTP is a standard application protocol used to transfer files from one computer to another over a network, such as the Internet. FTP allows users to upload and download files between their local computer and a remote server. FTP is widely used, but it lacks security measures. So luckily, we have some secure file transfer protocols too. These secure file transfer options are FTPS, which stands for File Transfer Protocol Secure, and SFTP, which stands for SSH File Transfer Protocol. Each of these protocols provides data encryption during transmission, ensuring your data remains private. So if you need to send files from one device to another, look to any of the FTP protocol variants. But if you want to move sensitive data electronically from one location to another, make sure that protocol acronym has an S in it to ensure security. Exam Objective 2.8 Identify basic networking concepts. Logical ports. Earlier in the course, we talked about physical ports. These are the actual connectors you find on a computer, like USB ports for peripheral devices, HDMI ports for video output, and Ethernet ports for wired network connections. You plug things into them. You can see them and touch them. But now, we're shifting gears to talk about something completely different. For the rest of this video segment, we will focus on logical ports. And as you may remember, logical equals software. So as you might have already guessed, these ports only exist in software. A logical port is like a virtual doorway your computer uses to handle specific types of network traffic. It helps your system decide where data packets should go as they enter and leave a network interface. Each logical port is assigned a number, and that number is tied to a specific kind of service or application. So while you won't see these ports physically on your machine, your computer uses them all the time in the background. Imagine your computer is a large office building. The IP address is like the building's street address. It tells the data packets where the building is located on the network, just like a postal address tells the mail carrier where to deliver a letter. But getting to the right building is only the first step. Once the data arrives, it still needs to know which room or department to go to. That's where port numbers come in. Each port number is like a room number or an office extension. It directs the data to the correct service or application inside the computer. For example, port 80 is the room used for regular web browsing with the HTTP protocol. If you're visiting a secure website, that data is sent through port 443, which uses HTTPS. And when you send an email, your message travels out through port 25, which handles outgoing email using the SMTP protocol. By using both the IP address and the port number, your computer can make sure the right data reaches the right place, just like a well-organized office making sure each piece of mail gets to the correct desk. Now here's the interesting part. There are over 65,000 possible port numbers, but you only need to be familiar with a few of the most common ones. Here are some examples. Port 80 is used for websites that use HTTP. Port 443 is used for secure websites that use HTTPS. Port 25 is used by email programs to send messages using the SMTP protocol. More examples include port 110, which is used by the POP3 email protocol to download messages. Port 143 is used by IMAP, which keeps email synced across multiple devices. And finally, ports 20 and 21 are used for file transfers with FTP. So here's the big takeaway. The IP address tells the data where to go, just like a street address. The port number tells it which service to interact with, just like a room number in a building. Therefore, logical ports keep everything neat and organized, working alongside protocols like HTTP, SMTP, IMAP, and FTP to make sure your data ends up in the right place. Exam Objective 2.8 Identify basic networking concepts. Networking models. When devices talk to each other on a network, they don't just send data randomly. They follow a specific structure called a networking model. This model acts like a set of rules governing data exchanges. It helps decide how computers share resources and how information moves between them. In simple terms, it answers the question, who provides what, and who gets what. In this video segment, we're going to focus on the two most common types of networking models you are likely to come across. These two models are peer-to-peer and client-server. Each of these models are designed to work in very different ways, but they both help devices connect, share files, access printers, and communicate across a network. To begin, let's start with peer-to-peer, often written as P2P. In a peer-to-peer network, every device is equal. Each computer can act as both a client and a server. That means any device can share its files, printers, or other resources directly with another device, without needing a central server to manage everything. Think of it like a group of friends sitting at a table, each bringing snacks to share. One person brings chips, another brings cookies, and everyone shares with each other directly. No one is in charge. That's how a peer-to-peer network works. It's great for small setups, like a home network or a very small office. For example, one laptop might store a collection of photos. Another device on the same network can connect directly and view or copy those photos. It's simple and easy to set up. But there's a catch. Because there's no central control, it's harder to manage security and updates. That's why peer-to-peer networks are usually best for personal use or environments where trust isn't a big issue. Now let's talk about the client-server model. This setup is a bit more structured. In this model, one or more devices act as clients, and they request services or resources from another device called a server. The server is built to manage and provide those resources, whether it's files, websites, printers, or email. If we go back to our earlier analogy, this is more like a restaurant. The client is the customer placing an order, and the server is the kitchen preparing and delivering the food. The server handles many requests and makes sure everything is organized and secure. This model is very common in larger networks. For example, in a company setting, your computer might be the client that logs into a central server to access shared documents, get software updates, or connect to a shared printer. The server stays on and ready at all times so it can respond to requests from multiple users. The client-server model is more secure and easier to manage, especially when you have lots of users. Updates, backups, and access permissions can all be controlled from one place. The trade-off is that it requires more planning and equipment to set up. Exam Objective 2.9 Explain the basic capabilities of a small wireless network. Wireless networks 802.11n, AC, and AX. In Exam Objective 2.5, we covered the idea that Wi-Fi is based on a family of standards known as 802.11x. Therefore, with that prerequisite knowledge in mind, we will now take a closer look at three key versions of these standards: 802.11n, 802.11ac, and 802.11ax. These are the versions most commonly found in homes and businesses today, and they represent some of the biggest improvements in wireless networking over the years. Let's begin with 802.11n. This standard was introduced in 2009 and was the first to support multiple antennas. This helped increase both the range and speed of wireless connections. While this standard is now a bit outdated, 802.11n is still in use today in many routers and devices. Next up is 802.11ac, also known as Wi-Fi 5. It came out a few years after 802.11n and brought a noticeable jump in performance. This version introduced wider channels for data transmission and more efficient ways for devices to communicate with each other. One of the standout features was something called beamforming. Beamforming allows wireless signals to be directed more precisely toward the connected device, which helps improve both performance and reliability. This made 802.11ac especially useful for streaming, gaming, and handling multiple devices at once. Finally, we have 802.11ax, better known as Wi-Fi 6. This is the latest major version of the 802.11 standard. Instead of focusing only on faster speeds, Wi-Fi 6 is built for efficiency. It can handle more devices at the same time without slowing down performance. It uses smarter communication techniques that make it ideal for modern environments like offices, schools, and smart homes filled with connected devices. Now, before we move on, let's talk briefly about older versus newer standards and how they work together. One of the best things about the 802.11 family is backward compatibility. That means if you have a newer 802.11ax router, it can still support older devices that only understand 802.11ac or 802.11n. And the reverse is also true. Older routers will allow newer devices to connect, though they will only run at the speeds supported by that older standard. So as technology improves, newer standards are designed to build on what came before, not replace it entirely. Exam Objective 2.9 Explain the basic capabilities of a small wireless network. Wireless speed limitations. Now that you've seen how the 802.11n, 802.11ac, and 802.11ax standards have evolved over time, let's take a closer look at one of the most important differences between them. And that difference is speed. When we talk about Wi-Fi speed, we're usually referring to something called maximum theoretical speed. This is the highest speed a wireless standard can reach under ideal conditions. That means no interference, full signal strength, and the best possible hardware on both ends. In the real world, we almost never hit those maximum numbers, but they give us a useful way to compare how fast each standard is. Let's start with 802.11n. When it was introduced back in 2009, it was a major leap forward. It introduced new technology that allowed multiple antennas to work together, and as a result, its maximum speed reached up to 600 megabits per second. That may not seem like much today, but at the time, it was a huge improvement over earlier Wi-Fi versions. Next, we have 802.11ac, also called Wi-Fi 5. This version pushed performance even further. On paper, Wi-Fi 5 can support over 1 gigabit per second, with maximum theoretical speeds reaching up to 6.9 gigabits per second on the highest-end devices. In real-world settings, it's much faster than 802.11n, especially when streaming high-definition video or handling multiple users at once. And finally, we have 802.11ax, also known as Wi-Fi 6. This is the most advanced and most efficient version of Wi-Fi currently in use. Its theoretical maximum speed goes beyond 9.6 gigabits per second. But Wi-Fi 6 isn't just about raw speed, it's also designed to handle more devices more efficiently, which makes a big difference in busy homes, offices, or classrooms. So here's the big idea. Each new version of Wi-Fi brings faster speeds, smarter technology, and a better experience for users. Whether you're watching videos, playing games, or just browsing the internet, faster and more efficient Wi-Fi means fewer delays, smoother performance, and a more reliable connection. Exam Objective 2.9 Explain the basic capabilities of a small wireless network. Wireless frequency bands. Imagine Wi-Fi signals as invisible waves moving through the air, carrying data from your router to your device. These waves have something called frequency, and that frequency affects how the signal behaves. It determines how fast data moves, how far the signal can travel, and how well it can pass through walls or obstacles. Now, let's break down what frequency really means. To picture this, imagine a ball bouncing on the ground. If the ball bounces up and down very quickly, that's similar to a high-frequency signal. If it bounces slowly, that's comparable to a low-frequency signal. In technical terms, frequency measures how many times a wave completes one full cycle, meaning one full rise and fall, in a single second. These cycles are measured in units called hertz. The higher the number of cycles per second, the higher the frequency. Behind me, you'll see the electromagnetic spectrum, which shows the full range of electromagnetic frequencies. This chart gives you a sense of just how wide that range really is, from very low frequencies like AM and FM radio waves, all the way up to high-energy waves like X-rays and gamma rays. For our current studies, we're going to focus on just a small part of that spectrum, the part used for Wi-Fi. Specifically, we're going to look at the two main frequency bands used by most wireless networks today. These are the 2.4 GHz band and the 5 GHz band. The first frequency band we will discuss is the 2.4 GHz band. It's like a slow but steady marathon runner. The 2.4 GHz band offers better range, meaning it can travel further. This characteristic makes it ideal for providing Wi-Fi coverage in larger spaces. However, since it's quite popular, the 2.4 GHz band can get crowded, leading to potential interference from other devices that also use this frequency. Now, let's meet our speedy sprinter, the 5 GHz band. It may not travel as far as the 2.4 GHz band, but it offers faster and more reliable connections over shorter distances. Due to its higher frequency, the 5 GHz band can handle more data, making it ideal for bandwidth-intensive tasks like HD video streaming, online gaming, and file transfers. Additionally, since the 5 GHz band is less crowded, it experiences less interference, providing a smoother and more consistent Wi-Fi experience. Now that we've seen how these two frequency bands behave, let's take a look at how they're used in different Wi-Fi standards. We'll start with 802.11n. This was the first Wi-Fi standard to support both the 2.4 and 5 GHz bands, making it a dual-band technology. This gave devices more flexibility. A laptop or smartphone could connect over the 2.4 GHz band for better coverage, or switch to the 5 GHz band for better speed when close to the router. At the time of its release, this dual-band capability made 802.11n a major leap forward in wireless networking. Then came 802.11ac, also known as Wi-Fi 5. This version focused purely on performance and was designed to operate only on the 5 GHz band. By using the higher frequency band exclusively, Wi-Fi 5 was able to provide faster speeds and more reliable performance for demanding tasks like streaming, gaming, and large file transfers. The trade-off, of course, is reduced range and weaker performance through walls, but for speed, it was a major upgrade. It's also worth noting that most 802.11ac routers still support 802.11n devices. That means they can provide a 2.4 GHz connection using an 802.11n connection for older hardware, while offering high-speed 5 GHz access for newer devices running on Wi-Fi 5. Next, we have 802.11ax, better known as Wi-Fi 6. This standard brought back dual-band support, using both the 2.4 and 5 GHz bands. But it didn't stop there, it also introduced smarter ways to manage traffic and connect multiple devices at once. With Wi-Fi 6, devices can intelligently switch between bands, based on network conditions. That means faster speeds when you're close to the router, and better coverage when you're farther away. It's flexible, efficient, and built to handle the demands of modern networks. And finally, to close out this video segment, we will discuss Wi-Fi 6E, a new and exciting extension of Wi-Fi 6. What makes it special is the addition of an entirely new frequency band, the 6 GHz band. This band provides a fresh, wide-open space for wireless communication. Since it's brand new, there's far less interference. Wi-Fi 6E is ideal for high-performance applications and environments with lots of competing signals. Now, not all routers and devices support Wi-Fi 6E just yet, but it is making its way into newer equipment as time progresses. As it becomes more widely adopted, the 6 GHz band will help future-proof networks for years to come. Exam Objective 2.9 – Explain the basic capabilities of a small wireless network. Interference and attenuation. We will start off this video segment with the topic of interference and save attenuation for the end. With that said, there are multiple types of interference, but we will limit our studies to electromagnetic interference. Electromagnetic interference, or EMI, is a disturbance or noise caused by electromagnetic signals that interfere with the proper functioning of electronic devices. Electromagnetic interference happens when electromagnetic waves from one electronic device interferes with the signals or operations of another nearby electronic device. These waves can be produced by various sources, such as Wi-Fi signals, cell phones, power lines, and even microwave ovens. So how does this topic connect to our current exam objective on wireless networks? It matters because electromagnetic interference, or EMI, can seriously disrupt wireless communication. When there's too much interference, your signal can become weak or unreliable, even if everything else is set up correctly. So what can you do if you run into this problem? The best approach is to identify and remove sources of EMI whenever possible. If you can't remove them entirely, try to keep them at a distance from your wireless equipment. Reducing interference is key to maintaining strong, stable wireless connections. Next up, we have another related topic. Signal-to-noise ratio, or SNR for short. Signal-to-noise ratio is a measure used to describe the quality of a signal by comparing a desired signal against any background noise or interference that is present. Imagine you're having a conversation with someone in a noisy room. The desired signal is your voice, and the noise is the background chatter and other sounds in the room. The clarity of your conversation depends on how loudly you speak compared to the noise level. If your voice is much louder than the noise, the other person can hear you clearly, and the conversation is successful. This is a high signal-to-noise ratio. Speak too softly and your voice will not be distinguishable from the crowd. This is a low signal-to-noise ratio. In the context of technology, a signal-to-noise ratio works similarly. It compares the strength of the desired signal, like a Wi-Fi signal, to the background noise, such as electromagnetic interference. A high signal-to-noise ratio means the desired signal is strong compared to the noise, resulting in clear and reliable communication or data transmission. On the other hand, a low signal-to-noise ratio means the signal is weaker, making it more challenging to distinguish the signal from the noise, leading to slow or unstable communications. Now that you understand the impact of EMI and the importance of maintaining a high signal-to-noise ratio, let's now explore the second type of interference, physical obstructions. Yes, a physical obstruction can also introduce signal interference. For instance, any solid structure, such as a brick wall, can cause interference and weaken a wireless communication signal that has to pass through it. And just like EMI, this form of physical interference can also lead to slow or unstable communications. The frequency of a wireless signal will also have an effect on how much interference is experienced as a result of a physical obstruction. To keep this brief and on topic, the 2.4 GHz band will experience less physical interference than the 5 GHz band in most cases. You're almost there. We just have one more important concept to cover when it comes to weakened wireless signals, and that's something called attenuation. Attenuation is the loss of signal strength as the transmission distance increases. Or alternatively, you can say, a signal decreases in strength the further it travels from its origination point or source. To grasp this concept, imagine the light coming from a flashlight getting dimmer as you move further away from its source. Similarly, as a signal travels over distance, it becomes weaker. The farther the signal travels, the more it attenuates. Exam Objective 3.1 – Identify components of an operating system. As we begin exploring Domain 3 of this CompTIA Tech Plus training course, we're entering an exciting and essential area of knowledge. That area is applications and software. And at the core of this domain is something that every computing device relies on, even if you don't always see it working behind the scenes. And that something is the operating system. In this video segment, we'll start with a simple and clear definition of what an operating system is and why it's such a critical part of any device. This video segment is designed to set the foundation for everything that follows in Domain 3. Over the next few exam objectives, we'll be breaking down operating system components, exploring different types of software, and learning how users interact with applications through interfaces. But before we get there, let's make sure we understand the role the operating system plays at the center of it all. So let's kick things off with a question. What exactly is an operating system? An operating system, or OS for short, is the fundamental software program that serves as the backbone of a computer or any other computing device. It has the primary job of being the intermediary between the hardware components of the computer and the applications or software running on it. More simply put, an operating system is like the boss of a computer, coordinating all its tasks and making sure everything runs smoothly. Or it is like a conductor, who leads an orchestra, ensuring all the musicians play together in harmony to create beautiful music. As we continue to explore the different functions of operating systems in upcoming video segments, you'll notice that all of the images and demonstrations I will use are based specifically on the Windows 11 operating system. That's because CompTIA tends to focus more heavily on Windows than any other operating system. Well, with the exception of the Linux Plus exam, of course. Exam Objective 3.1 – Identify components of an operating system. File system characteristics. In this video, we're going to take a closer look at something that plays a critical role every time you save, open, move, or organize a file, and that's the file system. Let's begin with a basic definition. A file system is the method of organizing and storing data on a computer or storage device. It acts as the framework that determines how files are named, how they are stored, and how they're accessed by both users and the operating system. To help visualize this, think of a file system as a digital filing cabinet. Just like you might organize paper documents into folders inside a physical cabinet, a file system keeps your digital data organized in a way that makes sense to both you and the system. It keeps everything neat, searchable, and accessible, so you can find what you need quickly and keep your data from becoming a jumbled mess. But a file system isn't just about structure, it also comes with built-in features that enhance how your data is stored and protected. Let's take a look at a couple of the most common file system features you may encounter. The first feature is file compression. File compression reduces the size of a file by using specialized software algorithms. This helps you save storage space and allows files to be transferred more quickly over a network. It's especially helpful when you're trying to fit more data onto a device or need to send large files through email or cloud services. Next, we have file encryption. File encryption is a method of securing data by transforming it into a format that can't be read without a special decryption key. Think of it like locking your digital files in a safe. Even if someone were to steal the file, they wouldn't be able to open or understand its contents without the correct password or access key. This is a vital security feature for protecting sensitive data, especially in situations where a device might be lost or stolen, such as a smartphone or laptop. These are just two examples of how different file systems offer more than just storage. They provide important functionality that impacts everything from system performance to data security. Exam Objective 3.1 – Identify components of an operating system. File management. In the world of information technology, understanding file structure is essential for organizing and managing data efficiently. Think of it as the blueprint that guides how information is stored and accessed on our computers. Imagine having a huge pile of papers without any order. It would be impossible to find what you need quickly. Similarly, without a file structure, our computers would become chaotic, making it challenging to locate and manage data effectively. To provide some sense of order, our computers organize data into files and folders. So let's define files and folders and see how they work to bring order to our data. A file, in the context of information technology, is a digital container that holds data such as documents, images, videos, or any other type of information. It could be your essay for school, a picture from your last vacation, or even a program that runs your favorite game. Imagine files as individual pieces of a jigsaw puzzle. When they are organized and put together correctly, they create a complete picture, enabling your computer to perform its various tasks. Without files, there would be no data to work with, and your computer would be nothing more than a lifeless box. Now, let's talk about folders, also known as directories. A folder is like a virtual container that helps you organize your files in a logical manner. Think of folders as your file cabinet, with each drawer containing related documents. You can have separate folders for work-related files, personal documents, pictures, or any other category that makes sense to you. Organizing files into folders not only keeps your data tidy, but also makes it easier to find and access specific information when needed. Moreover, folders can be nested inside other folders, creating a hierarchical structure, just like subfolders within a larger main folder. Now let's talk about file permissions. File permissions are access rights that determine what actions users can perform within a file system. These permissions are set by the file's owner or system administrator to control who can read, write, execute, or have full control over the file. This enhances data security and prevents accidental data loss. The read permission allows users to view the contents of a file. The write permission allows users to modify the contents of a file, in addition to allowing users to add, delete, or rename files. And the execute permission allows users to run a file if it is an executable program or script. Last, full control is exactly what it sounds like. This permission provides a user full control over the file. And before we wrap up, there's one more important detail to keep in mind. File systems follow specific naming rules that define how files can be named and organized. These rules determine which characters are allowed or not allowed in a file name. For example, the // is usually restricted, since it's used by many operating systems to separate folders in a path. Including it in a file name could confuse the system. File systems also set limits on how long a file name can be. Some systems allow lengthy names with spaces and special characters, while others keep things short and simple. Even though naming rules might seem minor, they play a big part in keeping files organized, searchable, and accessible. When all files follow the same set of rules, your system runs more smoothly, and your data stays easier to manage. Exam Objective 3.1 Identify components of an operating system. File types and extensions. When dealing with files, it is important to know that files come in different types, such as documents, images, videos, and more. Each file type is identified by a unique extension, which is a few characters at the end of the file name. Understanding file types and extensions is crucial because they tell your computer how to interpret and handle the data within the file. So let's dive in and unravel the secrets behind file extensions. File extensions are little tags that convey specific information about a file. For instance, a document might have the doc extension, while an image could have a JPEG or PNG extension. When you double-click on a file, your computer uses the extension to determine which program should be used to open and read the file's contents. It's like telling your computer, hey, this file is a document, so use the word processing software to open it. Extensions make file handling easier for both users and computers, ensuring that the correct software is used to access each file's data. Exam Objective 3.1 Identify components of an operating system. Services. A service is a software program or function that runs in the background of a computer or device, providing specific tasks, functionalities, or capabilities to support the operating system or applications. You can think of services as dedicated helpers that work behind the scenes to manage and coordinate various tasks on our devices. They provide fundamental functionalities that allow us to interact with our computers and perform everyday activities effortlessly. From managing hardware resources like memory and processing power to handling software applications and user interfaces, services are the unsung heroes that make our digital experiences possible. Another essential feature of services is that they can be configured to start automatically when the computer is booted up. This, in turn, allows certain applications to run without requiring manual intervention from the user each time the computer boots up. As a user, services are indispensable because they simplify our computing experiences and shield us from the complexities of hardware and software interactions. They ensure that our devices run smoothly and provide a user-friendly environment where we can work, play, and communicate effortlessly. Imagine trying to print a document without the device management and print spooler services, or accessing your photos without the file management service. Now that would be a challenging and frustrating experience. Thanks to these services, we can focus on what we want to achieve without worrying about the technical intricacies happening beneath the surface. Exam Objective 3.1 Identify components of an operating system. Processes. In the context of a computer program, a process refers to an instance of an executing program or application. It represents the computing resources, such as memory, CPU, files, etc., allocated to that specific program while it's running. Each process operates independently and follows its sequence of instructions, enabling the computer to execute multiple programs simultaneously, a capability known as multitasking. The operating system manages these processes, ensuring that they don't interfere with each other and that the system resources are allocated efficiently to provide smooth and responsive computing experiences to the user. And just so you don't confuse the definitions of an application and a process, I will clarify the difference between the two now. An application represents the software itself and its intended purpose. A process refers to the running instance of that application on a computer. So while they are closely related, an application and a process are not the same. When you start an application, it becomes a process, and it runs independently with its allocated system resources, memory, CPU, etc. One application can have multiple processes if you run it multiple times, each process operating separately. The operating system manages these processes to ensure efficient use of resources and to prevent interference between them. In summary, an application is the software, while a process is the running instance of that software on the computer. Exam Objective 3.1 Identify components of an operating system. Drivers. A device driver is a software program that facilitates communication between a computing device's operating system and a specific hardware device. The device driver acts as a translator, allowing the operating system to directly communicate with, understand, and utilize the features and functions of the attached hardware device. While having a driver installed allows your operating system to communicate with hardware, that's only the first step. Once a driver is in place, it's important to keep it up to date. Updating drivers is crucial to ensure optimal performance, security, and compatibility with evolving hardware and software. As technology advances, manufacturers release driver updates that address potential bugs, improve device functionality, and enhance overall system stability. These updates can unlock new features, boost performance, and resolve vulnerabilities that could be exploited by malicious actors. By regularly updating drivers, users can harness the full potential of their hardware, experience fewer compatibility issues, and safeguard their systems against potential security threats. It also ensures that the hardware can seamlessly integrate with the latest operating systems and applications, providing a smoother and more enjoyable computing experience. But performing these updates does not always go to plan. In the event that something goes wrong after updating a driver, the option to perform a rollback is a valuable safety mechanism. Sometimes, an updated driver may inadvertently introduce problems or conflicts with specific hardware configurations or software setups. If these issues cause performance degradation or malfunctions, users can revert to the previous driver version through a rollback process. By doing so, the system can return to a stable state where the hardware was functioning correctly before the update. This ability to roll back a driver provides an important undo function, giving users confidence to experiment with new updates while maintaining a safety net to recover quickly in case of any adverse effects. Exam Objective 3.1 Identify components of an operating system. Utilities. Operating system utilities are a set of essential tools and programs built into an operating system to help users manage, maintain, and optimize their computers. These utilities perform various tasks, such as file management, system maintenance, security, and more. Operating system utilities are like a toolbox for your computer. Just like a toolbox contains a range of tools that help you fix, build, and organize things, operating system utilities provide the necessary tools to manage and maintain your computer efficiently. To give you an example of one such utility, I will bring up Task Scheduler. Task Scheduler is a built-in utility in Windows 11 that allows users to automate and schedule tasks to run at specified times or in response to certain events. It provides a way to execute programs, scripts, or commands automatically without user intervention. Task Scheduler enables users to set up tasks to run at specific intervals or on specific dates and times. This automation is useful for repetitive tasks, such as system maintenance, backups, and software updates. Tasks can also be triggered based on specific events, such as when the computer starts up, when a user logs in, or when a certain event occurs in the system. But the real beauty lies in the fact that tasks created in Task Scheduler are centrally managed by the Windows operating system. Users can review the history of task executions, monitor task status, and make adjustments to task settings as needed. If you think the Task Scheduler utility is cool, just wait. The CompTIA A+ Core 2 exam is chock full of Windows utilities to learn about. Exam Objective 3.1 Identify components of an operating system. Interfaces. In this video segment, we will explore the two primary interfaces used to interact with computers, the Command Line Interface, or CLI, and the Graphical User Interface, or GUI. Let's begin with the Command Line Interface. The Command Line Interface, or CLI, is a text-based interface used to interact with a computer or operating system. You can imagine it as a direct, text-based way to communicate with your computer, just like having a conversation with someone using written language. By typing commands into the CLI, users can execute various tasks, such as navigating the file system, launching applications, managing files, and configuring system settings, by entering specific commands and receiving text-based responses. CLI provides a powerful and efficient way to control a computer, especially for advanced users and system administrators. Now, our second interface type is a graphical user interface. A graphical user interface, or GUI, is a visual interface that allows users to interact with a computer or software application through graphical elements such as icons, buttons, and windows. In a GUI, users can perform tasks by clicking on these graphical elements using a mouse or touchpad, making it more intuitive and user-friendly, especially for those who are not familiar with entering text-based commands into the command line interface. GUIs are commonly used in modern operating systems and applications to provide a visually appealing and interactive way for users to navigate, manage files, and perform various tasks with ease. One last note. In some situations, the GUI might not be accessible, may not have the necessary tools you need, or may not be available at all, but the CLI will always be there to help control your computer efficiently. Exam Objective 3.2. Explain the purpose of operating systems. Operating system functions. For Exam Objective 3.2, we're going to continue our discussion of operating systems. But this time, instead of just asking what an operating system is, we're going to dig into what it actually does, its key functions and responsibilities. So let's start with a quick refresher. An operating system, or OS for short, is the fundamental software program that serves as the backbone of a computer or any other computing device. It has the primary job of being the intermediary between the hardware components of the computer and the applications or software running on it. Now that we've covered that core definition again, it's time to take things a step further and look at the specific functions the operating system performs behind the scenes. The operating system does much more than just connect hardware and applications. It plays a vital role in almost everything your computer does. From managing files to maintaining security, the OS is constantly working to ensure your system runs smoothly and efficiently. The key functions we will be exploring throughout this exam objective are disk management, task and process management, application management, device management, and access control. Each one is essential for keeping your system stable, secure, and responsive. Now that you know what's coming, I'll see you in the next video segment as we begin our deep dive into these important OS functions. Exam Objective 3.2. Explain the purpose of operating systems. Disk management. In the context of an operating system, disk management refers to the way the operating system organizes and provides structure for file and data management. Imagine your computer's storage as a big cabinet with drawers. Disk management is like arranging files neatly into different drawers, labeling them for easy retrieval, and ensuring there's enough space for new files without causing clutter. Or you can think of your computer's storage as a massive bookshelf, and the operating system is the librarian that organizes all the books on each separate shelf. Similarly, by using disk management tools, we can also create separate logical compartments on our storage devices, called partitions. A partition is a separate and distinct section or compartment of a storage device. It acts as a virtual division, allowing you to organize and manage data separately from other partitions. In Windows, for example, we can access the disk management utility and create a new partition for any portion of a drive that is unallocated or is not currently in use. The thick red line represents where I have added a partition. In addition to creating a partition, we can shrink a partition or decrease the allocated space. We can also extend a partition or increase the allocated space. And finally, we can delete a partition altogether. However, when deleting a partition, please be aware that any data inside of it will be lost. Now, let's talk about hidden partitions. These are partitions that are not readily visible to the user. Hidden partitions are often used for system recovery or specific system functions. They are typically hidden from the user to prevent accidental tampering or deletion, but they will still be visible with disk management tools. Exam Objective 3.2. Explain the purpose of operating systems. Task and process management. Before we jump into process management, let's do a refresher on what a process is. In the context of a computer program, a process refers to an instance of an executing program or application. It represents the computing resources, such as memory, CPU, files, etc., allocated to that specific program while it's running. Each process operates independently and follows its sequence of instructions, enabling the computer to execute multiple programs simultaneously, a capability known as multitasking. The operating system manages these processes, ensuring that they don't interfere with each other and that the system resources are allocated efficiently to provide smooth and responsive computing experiences to the user. While the operating system handles processes rather seamlessly, we do have tools that can help us when processes don't behave the way we expect or would like. In Windows, we have the Task Manager. Task Manager is a system utility that provides real-time monitoring and control over processes and system performance on a Windows computer. It offers several features that allow users to manage tasks effectively. In viewing tasks, the Task Manager displays a list of running processes, applications, and services, along with their current resource utilizations. This information helps users identify which programs are consuming the most resources and potentially causing performance issues. The Task Manager also allows users to close non-responding applications by selecting the application and clicking End Task. This sends a close request to the program, terminating the application, freeing up system resources, and resolving any potential unresponsiveness. Exam Objective 3.2. Explain the purpose of operating systems. Application management. In the context of IT, an application refers to a software program or set of programs designed to perform specific tasks or functions to meet the user's needs. Applications can include everything from simple utilities like text editors and web browsers to complex software like office suites, photo editors, and video games. And just so you don't confuse the definitions of an application and a process, an application represents the software itself and its intended purpose. A process refers to the running instance of that application on a computer. When you start an application, it becomes a process, and it runs independently with its allocated system resources. One application can have multiple processes if you run it multiple times, each process operating separately. The operating system manages these processes to ensure efficient use of resources and to prevent interference between them. In summary, an application is the software, while a process is the running instance of that software on the computer. Now that we have defined what an application is, managing these applications is another function of the operating system. Within Windows, we have the Programs and Features applet to assist users in performing the basic functions of application management. Once an application is installed on a Windows system, you can use the Programs and Features applet to view, manage, or uninstall it. This applet gives you a centralized place to keep track of all the applications currently installed on the system. From here, you can check the size of an application, see when it was last used, or sort the list by name or publisher. And if you ever need to remove a program that's no longer needed or causing problems, you can easily select it and choose to uninstall it directly from this interface. Exam Objective 3.2. Explain the purpose of operating systems. Device management. Device management is the process of controlling and coordinating the various hardware devices connected to a computer system. It is a vital function of the operating system that enables it to recognize, configure, monitor, and interact with hardware components, such as printers, graphics cards, network adapters, and storage devices. Device Manager in Windows is a built-in utility that allows users to manage hardware devices connected to their computer. It provides an intuitive graphical interface to perform various device-related tasks, to include viewing device information, updating device drivers, enabling and disabling devices, troubleshooting device issues, and facilitating device removal. To provide an example, if you were having trouble with a printer's driver, this would fall under the device management function of the operating system, and the Device Manager tool in Windows would be a great place to start your troubleshooting efforts. Exam Objective 3.2. Explain the purpose of operating systems. Access control. Access control, in the context of an operating system, refers to the process of managing and regulating the permissions and privileges granted to users or processes attempting to interact with system resources. It ensures that only authorized entities can access specific resources, preventing unauthorized access and maintaining the security and integrity of the system. In an operating system, access controls extend their authority over various aspects, including file permissions, application installations, and administrative tasks. File permissions dictate who can read, write, or execute files and directories, ensuring that sensitive data remains secure and only authorized users can access it. Application installations are controlled to prevent unauthorized software from being installed, reducing the risk of malicious or unapproved programs compromising system stability or security. Administrative tasks, such as user account management, system configurations, and software updates, are restricted to authorized personnel to maintain the overall integrity and stability of the operating system. Exam Objective 3.2. Explain the purpose of operating systems. OS types. We just learned in the last few video segments what an operating system is and what an operating system does, but does every computing device use the same OS? Absolutely not. There are many, and each is designed for a specific use case. Now, I have laid out a few icons behind me. How many do you recognize? Most of us are familiar with Apple, represented by the Apple icon, and no doubt you have spotted the Microsoft Windows icon behind me too. The penguin on the left, whose name is Tux, is the universal symbol for the Linux OS, and on the right we have the icons for Google's Chrome OS and Android. Next I will present some use cases, and list appropriate operating systems for each. I will start with workstation OSs. A workstation OS is designed to provide a user-friendly and feature-rich environment for individual users, often emphasizing multimedia capabilities, productivity tools, and personal customization options. So which operating systems apply to this scenario? First we have Linux. Linux has many different distributions, some of which are great for workstations. Next we have Apple. Apple also offers an OS for workstations. Their workstation OS is macOS. Microsoft offers Windows 11. And a little less known, but also considered a workstation OS, is Google's Chrome OS. Servers have operating systems that are very similar to a workstation OS, but they are likely to be optimized for robustness, security, and stability to efficiently manage and serve resources and services to multiple clients in networked environments. This is an area where Linux excels. Many of the Linux distributions have been purpose-built for server environments. Windows also has server-specific operating systems. Additionally, we have Unix. Unix is very similar to Linux as they share a lot of history, but are different enough to be mentioned separately. Moving on, we have mobile device OSs. Mobile device operating systems are fairly different than workstations and servers, as these OSs must be tailored for the constraints of smartphones and tablets, prioritizing items such as touch-based interfaces, virtual keyboards, power efficiency, and ARM processor compatibility. Currently, the mobile device market is dominated by two main OS options. They are Apple iOS and Android. And last on our list, we have embedded operating systems. These are specialized operating systems designed to run on devices with limited hardware resources and very specific tasks. Unlike a general-purpose OS, an embedded operating system is streamlined to be fast, efficient, and reliable, often with real-time capabilities and minimal power consumption. You'll find embedded operating systems in all kinds of devices that you use every day, even if you don't think of them as computers. This includes things like smart thermostats, fitness trackers, and even household appliances, like a modern smart refrigerator that can track food inventory or display your calendar. They're also used in gaming consoles, medical devices, and industrial equipment. Because these systems usually run one dedicated function in a static environment, they don't need frequent updates, and they're built for long-term stability. That makes them perfect for the growing world of IoT, or Internet of Things, where everything from your doorbell to your fridge can be connected and intelligent. Exam Objective 3.3. Explain the purpose and proper use of software. Productivity software. Productivity software refers to software applications that assist users in performing various work-related activities and tasks. It empowers users to create, manage, and manipulate digital content, saving time and effort while improving productivity. Some types of productivity software include word processing software, spreadsheet software, presentation software, and visual diagramming software. Now let's examine each one of these software types, one at a time. First, we have word processing software. This type of application allows users to create, edit, format, and print text-based documents. Think of it as a digital typewriter, but with far more power. Features like spell check, formatting tools, collaboration options, and template support make it ideal for writing anything from basic memos to formal reports. Popular examples of word processing software include Microsoft Word, LibreOffice Writer, and Google Docs. Next is spreadsheet software, which is used to organize, manipulate, and analyze numerical data in a tabular format. Spreadsheets are powerful tools for handling everything from budgeting to data analysis. They support formulas, graphs, sorting, filtering, and even automation features, making them indispensable in business, finance, and research. Popular examples of spreadsheet software include Microsoft Excel, LibreOffice Calc, and Google Sheets. Now let's take a look at presentation software. This type of application helps users create visual slideshows that combine text, images, videos, and other multimedia elements to create visual slideshows. Whether you're pitching an idea in a meeting or giving a lesson in a classroom, presentation software helps you communicate ideas clearly and persuasively. Popular examples of presentation software include Microsoft PowerPoint, LibreOffice Impress, and Google Slides. Finally, we have visual diagramming software. These tools allow users to create visual representations of workflows, systems, relationships, and concepts. They use shapes, lines, and symbols to form flowcharts, network diagrams, mind maps, and other structured visuals. This type of software is especially useful for brainstorming, technical documentation, graphically depicting the steps of a process, or planning projects. Popular examples of visual diagramming software include Microsoft Visio, Lucid Chart, and Draw.io, also known as Diagrams.net. Exam Objective 3.3 Explain the purpose and proper use of software. Collaboration software. Collaboration software is a category of software applications designed to enhance communication among individuals working on shared files or projects, regardless of their physical locations. It enables users to collaborate in real time, share resources, and streamline workflows. Some types of collaboration software include email clients, conferencing software, online workspaces, and document sharing software. Now let's examine each one of these collaboration software types, one at a time. First, we will look into email clients, which allows users to access, send, receive, and manage email messages from their email accounts. Additionally, it may feature built-in calendar functions that enable users to create, manage, and schedule events, appointments, and meetings. 3 popular examples of email client software would include Microsoft Outlook, Google Gmail, and Apple Mail. Next, we will examine conferencing software, which enables real-time communication between multiple participants through video and audio calls over a network connection. It allows users to conduct virtual meetings, video conferences, webinars, and screen sharing sessions, fostering effective communication and teamwork among remote individuals or teams. Conferencing software plays a crucial role in modern work environments, facilitating seamless interactions, idea sharing, and decision-making without the need for everyone to be physically present in the same location. Some popular examples of conferencing software would include Zoom and Google Meet. Moving on, we have online workspaces. Online workspace software provides a virtual environment where team members can collaborate on projects and organize resources. Online workspaces are designed to enhance remote collaboration, making it easier for team members to access and work on shared materials from anywhere. Some popular examples of online workspace software would include Microsoft SharePoint and Google Workspace. And the last collaboration software type we will cover is document sharing software. Document sharing software allows users to share, access, and collaborate on digital documents with others over the internet. It enables individuals to upload, store, and distribute various types of files, such as text documents, spreadsheets, presentations, and multimedia files. Document sharing software promotes efficient collaboration by providing secure and easy access to shared documents, allowing multiple users to view, edit, and comment on the same files simultaneously. 3 popular examples of document sharing software would include Microsoft OneDrive, Google Drive, and Dropbox. Before closing out this video, it is important to note that not all collaboration software will fit into a single category. Let me give an example to explain what I mean. Zoom may function primarily as conferencing software, but also has built-in instant messaging capabilities to improve the user's experience. Another example is how online workspace software will typically offer a range of features designed to enhance collaboration, including document sharing. Just keep this in mind come exam time. Exam Objective 3.3 – Explain the purpose and proper use of software. Instant messaging software. Instant messaging software has become a key part of how we communicate, not just with friends and family, but also in workplaces, classrooms, and professional settings around the world. In this video segment, we're going to focus on what instant messaging software is, how it works, and where you're most likely to see it used. So what exactly is instant messaging software? Instant messaging, or IM for short, refers to software that enables real-time text-based communication between individuals or groups. It lets users send and receive messages instantly, often with the ability to include file attachments, emojis, and even voice and video features. And it doesn't matter where you are in the world, as long as you're connected to the internet, IM software keeps you in the conversation. So where is instant messaging software used? You'll find it just about everywhere. In business, teams use instant messaging tools to coordinate projects, stay aligned on tasks, and avoid long email chains. In education, students and teachers use it to ask questions and work together remotely. And of course, in our personal lives, we rely on IM software to stay connected to friends and family. Now that we understand what instant messaging software does, let's take a closer look at 3 popular platforms that demonstrate how it works in different settings. First up is Slack. This platform is widely used in professional environments. It's organized into channels, supports integrations with project management tools, and helps teams stay coordinated throughout the workday. Next, we have WhatsApp. This mobile-first app is popular around the world for personal and group messaging. It allows users to send messages, photos, documents, and even voice recordings, all protected by end-to-end encryption. And finally, there's Discord. Originally built for gamers, Discord now supports a wide range of communities and organizations. It offers instant messaging as well as many other features, such as voice chat, video calls, and screen sharing. While each of these platforms offers a unique experience, they all have one common feature, enabling real-time text-based communication between individuals or groups. Exam Objective 3.3 – Explain the purpose and proper use of software. Web browsing software. In this video segment, we'll be focusing on a software category that most users interact with every single day. It's called web browsing software. A web browser is a software application that allows users to access and view content on the World Wide Web. It acts as a gateway to the internet, making it possible to visit websites, search for information, stream videos, check email, shop online, and use cloud-based applications and services. Without a web browser, you wouldn't be able to open Gmail, read the news, or access your school's online learning portal. It is one of the most important tools used in modern computing across desktops, laptops, tablets, and mobile devices. So how does it work? A browser takes the code behind a web page, like HTML, CSS, and JavaScript, and turns it into a page you can see and interact with. It displays text, images, buttons, and video content, all within an easy-to-use interface. Most browsers also support features like bookmarks, tabbed browsing, autofill, and saved passwords to make your online experience faster and more convenient. Now let's take a look at 3 of the most popular web browsers used today. First up is Google Chrome. Chrome is known for its speed, clean design, and strong connection to Google services. Many users rely on it for everyday tasks like checking Gmail, editing Google Docs, and browsing with the help of Chrome extensions. Next, we have Apple Safari. Safari is the default browser on Apple devices such as iPhones, iPads, and Macs. It's optimized for speed and efficiency on Apple hardware, and it offers features like iCloud syncing, built-in privacy protections, and smooth integration across the Apple ecosystem. And finally, there is Microsoft Edge. Edge comes pre-installed with Windows and offers strong performance, excellent website compatibility, and built-in tools that work well with Microsoft 365. Each of these browsers helps users explore and interact with the internet. While they each bring unique features and strengths to the table, they all provide a secure and efficient way to browse the web. Exam Objective 3.3. Explain the purpose and proper use of software. Remote support software. Have you ever needed tech help, but the person who could fix the problem wasn't anywhere nearby? Maybe you were working from home or helping a family member in another city. That's where remote support software comes to the rescue. Remote support software is a tool that allows a technician to access and control a computer from a remote location. Over a secure connection, they can troubleshoot problems, change settings, or walk you through a solution, without ever being in the same room. This type of software is perfect for today's flexible work environments, where employees, students, and support teams often aren't in the same place. It saves time, reduces frustration, and makes tech support more efficient than ever before. Now, let's look a little closer at how remote support software is actually used. Imagine an employee is working from home and suddenly can't access their company's internal tools. Instead of traveling to the office or waiting for someone to visit their location, a support technician can connect remotely. They can diagnose the issue, make configuration changes, and even install necessary updates, all without the user having to lift a finger. This kind of remote access can also be helpful for performing routine maintenance, helping users recover lost passwords, or guiding them step by step through a new process. The key takeaway here is that remote support software creates a secure bridge between two devices. It allows one person to provide technical assistance, even if they're in a different building, city, or country. Exam Objective 3.4. Given a scenario, configure and use web browser features. Private browsing. Private browsing, also known as incognito mode or private mode, is a feature found in most web browsers that allows users to browse the internet without leaving any traces of their online activity on the device they are using. It is designed to provide a higher level of privacy and prevent the browser from storing data related to the user's browsing session. When you use private browsing, the browser does not store any records of the websites you visit, the searches you make, or the pages you view. This means that after closing the private browsing window, there will be no history of your online activities on that session. Additionally, in private browsing mode, cookies and temporary data are not saved, preventing websites from remembering your preferences or tracking your online activities. And if that wasn't already enough anonymity, private browsing also disables autofill and saved passwords, so your login credentials and personal information won't be automatically filled in on websites either. In short, if you use private browsing, it is as if you had cleared all your browsing data before closing the session. Exam Objective 3.4. Given a scenario, configure and use web browser features. Browser extensions. Browser extensions, also known as add-ons or plugins, are small software programs that integrate with your web browser. They are designed to extend the functionality of the browser and provide extra features for tasks like ad and script blocking, language translation, and much more. In order to add browser extensions to tailor your browsing experience, you will need to open your web browser and navigate to the browser's extension store or marketplace. From here, you can search for the desired extension using the search bar. Once you find the extension you want, click Add, and the extension will download and install automatically. Should you wish to remove an extension, the process is just as simple. Now that you know how to add and remove extensions, let's explore how to enable and disable them based on your preferences. Just because you have an extension installed, does not mean you have to have it enabled all the time. You can choose when and where to use the extension. To enable and disable the extension, open your browser and navigate to the extension settings. Here you can toggle the extension between enabled and disabled. When enabled, the extension will run and function as intended. When disabled, the extension will be deactivated and its functionality will be suspended until you re-enable it again. Also, don't assume the extension is enabled just because you installed it. Sometimes, the default state for a newly installed extension will be the disabled state, and not the enabled state. Exam Objective 3.4. Given a scenario, configure and use web browser features. Web browser caching. Caching is a technique used in information technology to store copies of frequently accessed data or resources temporarily. By doing so, it allows for faster access to the data, reducing the need to fetch it from the original source every time it is requested. Caching is widely used in various systems, including web browsers, to improve performance and efficiency. Caching is like having a handy storage area on your browser. It saves copies of web pages, images, and other resources you've visited recently so that if you revisit those sites, your browser doesn't need to fetch everything from the internet again. Instead, it retrieves the stored resources from its cache, making the process much faster and more efficient. When you access a website for the first time, your browser downloads all the necessary files from the internet and stores them in its cache. The next time you visit the same website, your browser checks its cache first. If it finds the required files there, it loads them directly from the cache, reducing loading times and saving bandwidth. Caching significantly improves your web browsing experience, especially when you revisit frequently accessed sites or navigate back and forth between different pages of the same website. While caching provides numerous benefits, it's essential to understand why cache clearing is necessary from time to time. First, cached resources may become outdated. Websites are continually updating content, and if your browser continues to use outdated resources from the cache, you might not see the latest changes on the website. Second, caching can sometimes lead to privacy and security concerns. Cached data can include sensitive information, such as login credentials or personal details. If someone gains access to your computer or device, they could potentially access this cached data. Third, cache accumulation over time can consume significant storage space on your device, potentially slowing down your computer or smartphone. Clearing your cache is a simple process that varies slightly depending on the web browser you use. Generally, you can find the cache clearing option in your browser's settings or preferences menu. It is a good practice to clear your cache regularly, especially if you notice any of the problems we just discussed. Exam Objective 3.4, given a scenario, configure and use web browser features. Pop-up blocker. Most of you may already know what a pop-up is, but you must also have figured out that I like to be thorough too. So here is a quick definition of a pop-up. In the context of a web browser, a pop-up refers to a small, separate window that appears on top of the main browser window. Pop-ups typically display additional content, such as advertisements, notifications, forms, or other interactive elements. They are often used to provide supplementary information or actions without navigating away from the current web page. However, pop-ups can sometimes be intrusive or disruptive to the user experience, and modern web browsers often utilize pop-up blockers to help control their appearance. So what exactly is a pop-up blocker? A pop-up blocker is a software feature integrated into web browsers that helps prevent unwanted or intrusive pop-up windows from appearing while a user is browsing the internet. It works by detecting and blocking the code or scripts that websites use to generate pop-ups. When a user visits a web page that contains such pop-up triggering code, the pop-up blocker identifies it and prevents the pop-up window from opening. This technology enhances user experience by reducing distractions, preventing malicious pop-ups, and ensuring that users can focus on the main content of the web page. Users can often customize pop-up blocker settings to allow specific websites or types of pop-ups if desired, striking a balance between usability and security. Exam Objective 3.4, given a scenario, configure and use web browser features. Browser compatibility. Browser compatibility refers to how well a website or web application functions across different web browsers. With numerous browsers available like Safari, Firefox, Chrome, Edge, and Opera, ensuring your digital creations work seamlessly on all of them is essential. Poor browser compatibility can lead to frustrating user experiences, broken functionality, and even security vulnerabilities. Various factors can impact browser compatibility, but one major factor is the HTML, CSS, and JavaScript code used by websites. Browsers tend to interpret these languages differently, which can cause some website pages to have visual or functional discrepancies. Behind me, I have a graphic of the same web page being rendered by two different web browsers, Firefox and Safari. Can you spot any differences? And lastly, when it comes to web applications, compatibility issues can arise from older applications not being able to function on newer browsers or the opposite, newer applications not functioning on an older browser. Exam Objective 3.4, given a scenario, configure and use web browser features. Browser profile synchronization. Have you ever switched from your laptop to your phone and wanted your bookmarks, saved passwords, or open tabs to follow you? With modern web browsers, they can, thanks to a feature called profile synchronization. Profile synchronization allows your browsing data to stay consistent across multiple devices. Whether you're checking something at home, at work, or on the go, your web experience stays familiar and personalized. Let's break it down. When you sign into a browser using your Google, Apple, or Microsoft account, the browser creates a user profile that can be synchronized to other devices. This profile stores your preferences, browsing history, extensions, saved passwords, bookmarks, autofill info, and even your open tabs. Once synchronization is turned on, anything you do on one device can show up on another. For example, you could bookmark an article on your desktop and finish reading it later on your phone. Or start filling out a form on your tablet and pick up where you left off on your laptop. This makes working across multiple devices smooth and seamless. Synchronization is especially useful in environments where users switch between devices often, like students using school laptops and home computers, or remote workers using both personal and company devices. To manage synchronization settings, simply go into your browser's profile or settings menu. There, you can choose what to synchronize, like only bookmarks and history, or turn off synchronization entirely if you prefer more privacy. Just remember, synchronization makes things easier, but only do it on devices you trust. If you're on a public or shared computer, make sure to sign out when you're done to protect your data. Exam Objective 3.4, given a scenario, configure and use web browser features. Browser organization. Keeping your web browser organized isn't just about aesthetics, it's about saving time, staying focused, and making your online experience more efficient. Modern browsers offer several tools that help you keep things tidy, so you can quickly find what you need without getting lost in a mess of open tabs and forgotten sites. Some browsers let you group tabs by topic or color code them to keep related content together. Others offer reading lists or a homepage dashboard that displays your most visited sites. You can even customize your browser's layout by rearranging toolbars or pinning frequently used extensions. Whether you're managing school research, work projects, or your favorite hobby sites, using these built-in organization features can help you stay on track and reduce digital clutter. Now let's focus on one of the most useful and popular browser organization tools, bookmarks. A bookmark is a saved link to a specific web page, allowing you to return to it quickly without typing in the website address again. Think of it like placing a sticky note on a page you want to come back to later, except now it's built right into your browser. Bookmarks are a simple but powerful way to stay organized online, and they're just one of the many browser tools designed to make your digital life easier. Exam Objective 3.4, given a scenario, configure and use web browser features. Default search engine. When you're using the internet, it's important to understand the difference between a web browser and a search engine, because they are not the same thing. A web browser is the software application you use to access the internet. Examples include Google Chrome, Microsoft Edge, Apple Safari, and Mozilla Firefox. These browsers let you visit websites, open tabs, watch videos, and use cloud-based tools. A search engine, on the other hand, is the service that helps you find websites and online content. Examples include Google Search, Bing, Yahoo, and DuckDuckGo. You interact with search engines through your browser, but the two are separate tools that work together. Now that we've cleared up the difference between a browser and a search engine, let's take a closer look at the default search engine setting. This is the search engine your browser automatically uses when you type a word or phrase directly into the address bar, instead of entering a full website URL. Each browser has its own default. For example, Google Chrome typically uses Google Search. Microsoft Edge defaults to Bing. Apple Safari often uses Google as well, depending on your region. The good news is, you're not locked in, you can change this setting anytime based on your personal preferences. It may seem like a small detail, but your default search engine has a big impact on your browsing experience. When performing a search, it determines the results you see first, how your data is handled, and even what ads you might encounter. Just keep in mind, the browser is your tool for getting online, and the search engine is the service it uses to help you find what you're looking for. Exam Objective 3.4, given a scenario, configure and use web browser features. Browser password management. Let's face it, keeping track of all your online passwords can be a real headache. With so many accounts spread across different websites and services, it's easy to lose track or start reusing the same password again and again. Fortunately, modern web browsers offer a built-in solution that makes things easier. It's called password management. A password manager is a feature built into most modern web browsers that securely stores your login information, including usernames and passwords. Once your credentials are saved, the browser can automatically fill them in when you revisit a website. This saves time, reduces typing errors, and helps you avoid the hassle of remembering multiple passwords. These saved passwords are encrypted and linked to your browser profile. That means if you're signed into the same browser account on multiple devices, and profile synchronization is enabled, your saved passwords can follow you, whether you're on a laptop, phone, or tablet. Browser password managers also help you create stronger passwords. When signing up for a new site, your browser can suggest a secure, complex password and save it on the spot. And don't worry, these features are designed with safety in mind. If you want to view or edit your saved passwords, most browsers will ask you to confirm your identity first, like entering your device password. You can also go into your browser settings to manage your saved credentials whenever you need to. While some users still prefer third-party password managers for extra features, the built-in tools in modern browsers are more than enough for most people. They make it easier to stay secure and organized without the hassle of remembering every login. So if you're tired of forgotten passwords and constant resets, let your browser do the remembering for you. It's simple, secure, and saves you a lot of time. Exam Objective 3.4, given a scenario, configure and use web browser features. Browser accessibility. When we talk about accessibility in the context of web browsers, we're talking about features designed to make the internet easier to use for everyone, including people with visual, auditory, motor, or cognitive impairments. Accessibility settings are built into modern browsers to ensure that as many users as possible can comfortably browse the web. These features help remove barriers and create a more inclusive online experience. For example, some users may need larger text, different color contrasts, or text-to-speech support to understand what's on a web page. Others might need keyboard shortcuts or navigation options that don't require using a mouse. But accessibility features aren't just helpful for people with disabilities. They can improve the experience for anyone who wants more control over how content is displayed and interacted with. Whether you're adjusting font size, using voice tools, or simplifying a page to stay focused, these tools can make a big difference in how smoothly you navigate the web. Exam Objective 3.4, given a scenario, configure and use web browser features. Browser appearance. When you open a web browser, the way it looks and feels can have a big impact on how comfortable and productive your experience is. That's why modern browsers give you plenty of options to customize their appearance to fit your needs and preferences. Browser appearance refers to the overall layout, design, and visual style of the browser interface. This includes the theme colors, the position of buttons and toolbars, and even the way your tabs are displayed. With just a few clicks, you can make your browser feel cleaner, brighter, more focused, or more personalized. Some users prefer a simple, minimal layout that only shows what's necessary, like the address bar and a few open tabs. Others may choose to display bookmarks, install helpful extensions, or pin frequently used tools right to the toolbar. Most browsers also offer built-in dark mode and light mode settings, and some let you apply colorful themes or background images to make your browsing experience feel more unique. Whether you're someone who likes everything sleek and distraction-free, or someone who wants to add a personal touch with vibrant colors and quick access tools, browser appearance settings let you take control of your environment and make it work for you. Exam Objective 3.5, identify common uses of artificial intelligence. Artificial intelligence, or AI for short, is the ability of machines to perform tasks that would normally require human intelligence. This includes things like recognizing speech, answering questions, making decisions, and even creating original content. In simple terms, AI helps computers think a little more like people, though hopefully with fewer coffee breaks and no need to complain about Mondays. AI systems learn from data, identify patterns, and use that information to perform tasks or make predictions. And they're becoming more common in our everyday lives, sometimes in ways you might not even notice. So let's take a look at some of the most common ways AI shows up in the real world. First up, we have AI chatbots. You've probably already talked to one, maybe even without realizing it. AI chatbots are programs that simulate human conversation. They pop up on websites to help with customer support, answer questions, or walk you through troubleshooting steps. They're used by businesses, schools, healthcare providers, and just about any service that wants to offer support without keeping someone on the phone all day. The great thing about AI chatbots is that they don't sleep, don't call in sick, and they don't get cranky. They're available 24/7 and can often handle routine questions faster than a human. But if they can't help you, they'll usually escalate the issue to a real person. Next, let's talk about AI assistants. These are like your digital sidekicks. Think Siri, Alexa, Google Assistant, or Cortana. You can ask them to set reminders, send messages, play music, or even turn off your lights if your home is set up with smart devices. It's like having a personal assistant, except you don't have to pay them. AI assistants are designed to help make everyday tasks easier and more hands-free. They use natural language processing to understand your voice commands and machine learning to improve over time. The more you use them, the better they get at knowing what you want. Now let's get a little more futuristic with generative AI. Generative AI refers to systems that can create something new, like writing text, generating images, making music, or even writing computer code. If you've ever seen an AI-generated portrait, read an AI-written article, or used an AI tool to help code a program, you've seen generative AI in action. And while generative AI can't replace human creativity, it sure can give it a helpful boost. And finally, let's talk about AI predictions and suggestions. Ever notice how your phone seems to know what you're about to type? Or how Netflix somehow always recommends that one show you secretly love? That's AI prediction at work. AI systems analyze your behavior and make predictions or suggestions based on what they learn. This could be recommending products on shopping websites, suggesting the fastest route on your map app, or flagging suspicious activity on your bank account. It's like having a super observant friend who pays attention to everything you do. These predictive features are all about convenience. They're designed to save you time, reduce friction, and make sure you get the most relevant options without having to search for them. So whether you're chatting with a bot, getting help from a voice assistant, using a tool that writes content for you, or getting tailored recommendations on what to watch next, AI is already a big part of your digital life. Exam Objective 4.1 – Compare and contrast programming language categories. Programming levels. With this video, we will be starting our study of Domain 4.0 of the CompTIA Tech Plus certification exam, which is all about software development concepts. We will start from the very basics and work our way up, so don't worry if you're completely new to information technology or programming. At the most fundamental level, computers receive, transmit, process, and store information in binary form. Computers work in this manner because they utilize billions of tiny electronic switches called transistors. These transistors can be in either an off or on state. The digits 0 and 1 used in binary reflect the off and on states of a transistor, where 0 is off and 1 is on. If this sounds familiar, that is because we covered this in Exam Objective 1.1 and 1.2. Moving up a level, we have machine language or machine code. Machine code consists of hexadecimal representations of binary instructions that are used by the computer's processor to directly control the computer's hardware. This is like the computer's native language, but it's not something humans find easy to work with and is not quite readable. Moving up yet another level, we have assembly language. This language represents machine code instructions using mnemonics that are easier for humans to understand. It is the closest language we have to machine code and is great for designing and programming low-level device drivers, but it is still not quite user-friendly. Finally, as computers evolved, so did programming languages. High-level languages, like Python, Java, C++, C#, and many others were created. These languages are much more human-friendly. In high-level languages, you write code using words and syntax that closely resembles everyday human language. In the next few videos, I will be focusing on the high-level languages, but at a minimum, don't forget the basics about each level we just discussed. Exam Objective 4.1 – Compare and contrast programming language categories. Compiled languages. This video segment will focus on a subset of high-level programming languages called compiled languages. But to begin understanding what a compiled language is, you first need a definition for a compiler. A compiler is a translator for computer programs. It takes the human-written instructions you give in a high-level programming language and turns them into machine code. It is important to note that a compiler translates the entire program into machine code prior to running or executing the program. Just as we use different languages to communicate with each other, computers require specific languages to understand the instructions we give them. A compiler takes the human-readable source code you write in a compiled programming language and translates it into machine code, the low-level instructions that the computer's processor can execute. Once the entire program has been translated by the compiler, the program is ready to run. Now, here's an important aspect of compiled languages: they are single-platform. What does that mean? Well, a compiled program is tailored to run on a specific type of computer or platform. This means that if you've written a program using a compiled language, it will work best on the platform it was compiled for. If you want the program to run on a different platform, you'll need to recompile it for that specific platform. As an upside, since the program has already been translated to machine code, when you do run the program, it will execute or run faster. To wrap things up, let's take a quick look at some popular compiled programming languages. We have Go, C++, Java, C#, and COBOL, just to name a few. Exam Objective 4.1 – Compare and contrast programming language categories. Interpreted languages. This video segment will focus on another subset of high-level programming languages called interpreted languages. But to begin understanding what an interpreted language is, you first need a definition for an interpreter. An interpreter is a real-time translator for computer programs. It takes the human-written instructions you give in a high-level programming language and turns them into machine code. This is very similar to the compiler we discussed in the previous video segment, with one clear difference. The interpreter translates and executes the program, line by line, in real time. Just as you might use a translator to understand a language you're not familiar with, computers use interpreters to understand and execute the instructions you give it in a programming language. Unlike compilers, which translate the entire program up front, interpreters work line by line, converting your human-readable code into machine instructions as it goes. Now, here's an important aspect of interpreted languages: they are cross-platform. But what does that mean? Well, an interpreted program is more flexible in terms of platform. This means that the same program can run on different types of computers without needing to be rewritten or recompiled. Interpreters adapt the code on the fly to match the computer's specific architecture, making it easier to create software that works on various platforms. As a downside, since the program has to be translated to machine code line by line at runtime, it will execute or run a bit slower. To wrap things up, let's take a quick look at some popular interpreted programming languages. We have PHP, Perl, Python, Ruby, and JavaScript, which should never be confused with Java. Exam Objective 4.1 – Compare and contrast programming language categories. Scripting languages. In this video segment, we're going to explore scripting languages. Now, scripting languages are actually a subset of a broader group called interpreted languages. But before we dive into the world of scripting, with the ing, we need to clear up a different but related term: scripted languages, spelled with an ed at the end. So, what's the difference? Let's start with scripted languages. These are programming languages used to create full applications or software programs that can run independently. You can think of them like the lead actors in a movie. They carry the show. Once they're written, they don't need any other program to help them run, they're self-sufficient. When a scripted language is used to build a software application, that application can run all by itself, just like a movie star taking center stage without needing anyone to hold their hand. Now let's shift to scripting languages. These are a bit different. Instead of running the show, scripting languages play a supporting role. They don't create full, standalone programs. Instead, they are used to write scripts, which are short sets of instructions that help guide or control other software. Think of them as the stage directions or cue cards. They tell the main actors what to do and when to do it. Great, now you know the subtle difference between scripted languages and scripting languages. With that out of the way, let's look a bit closer at scripting languages. Scripting languages focus mostly on creating scripts that automate tasks or control other software. These scripts often work behind the scenes and are comprised of a series of command line instructions or commands grouped together. These instructions are written in a specific order to automate tasks or perform actions on a computer or system. Think of it as a quick and efficient way to make the computer carry out multiple tasks without manually typing each and every command. Some examples of scripting languages include Bash, which is common in Linux distributions, and PowerShell, which is specific to Windows. While scripted languages offer better performance and optimization for standalone applications, scripting languages excel in automation and quick task completion. Scripting languages are easy to learn and highly versatile at performing ad hoc or as needed tasks quickly. Exam Objective 4.1 Compare and contrast programming language categories. Markup languages. Now it is time to cover markup languages. In this lesson, we'll decode the mystery behind what makes websites and digital content look and feel the way they do. Let's start with the basics. Imagine you're reading a book. The words on the pages are written in a language we understand, right? Well, web pages and digital content also have their own special language that computers and browsers use to understand how to display things. This language is known as a markup language. Just like you wouldn't read a book without paragraphs, headings, or punctuation, digital content wouldn't make sense without its own set of instructions. Markup languages provide these instructions to computing devices so they know how to arrange and present the content you see on your screen. One of the most common and foundational markup languages is HTML, which stands for Hypertext Markup Language. HTML uses a series of tags, think of them as digital labels, to define elements on a web page, like headings, bodies, paragraphs, images, and links. So think of HTML like the blueprint for a web page. It tells the browser where to place each piece of content, how to format text, and how to embed images or videos. This structure and formatting ensure that the web page looks consistent and readable on different devices and screen sizes. And HTML is just the beginning. There are other markup languages too, like XML, or Extensible Markup Language, which is used for storing and transporting data. So, whether you're building a personal blog, a company website, or even a complex web application, understanding how a markup language works will give you the power to shape and share your digital ideas with the world. Exam Objective 4.1 Compare and contrast programming language categories. Query languages. Ready to learn about query languages? Alright, let's go. A query language is a specialized computer programming language used to communicate with and manipulate databases. It provides a way for users and applications to interact with databases by sending requests for specific data or actions to be performed. Query languages are essential for extracting meaningful insights from large volumes of data stored in databases. They allow users to formulate complex queries to filter, sort, aggregate, and transform data based on specific criteria. Query languages are particularly valuable for data analysis, reporting, and decision-making processes. One well-known example of a query language is SQL, or Structured Query Language. SQL is widely used for relational databases and is used to manage and manipulate data in a tabular format, where tabular is just a fancy word for table. SQL queries can retrieve specific records, perform calculations, join data from multiple tables, and much more. If this topic excites you, that is great, because I will be covering this topic in much more detail when we get to Domain 5.0 of the CompTIA Tech Plus exam objectives. Exam Objective 4.2 Identify fundamental data types and their characteristics. In the context of computer programming and databases, a data type is a classification or category of data that determines the type of operations that can be performed on the data and the storage format to be used for that data. Though many different data types exist, there are 5 fundamental data types that are a part of the CompTIA Tech Plus certification exam. These data types include char, strings, integers, floats, and Boolean. Additionally, each one of these data types will be covered in their own separate videos. Next we will cover some of the more common operations that can be performed on the different data types. First up are the mathematical or arithmetic operations. From left to right, we have addition, subtraction, multiplication, division, exponentiation, floor division, and modulus. In case you have not seen the last two operations before, here are two examples. Floor division returns only the integer value of a division equation without any fractional values should they exist. And modulus only returns the remainder value of a division equation. Next we have relational or comparative operations. From left to right, there is equal, not equal, greater than, less than, greater than or equal to, and less than or equal to. These operations are used to compare two values. We will close out this video segment with logical operations. Logical operations use keywords like and, or, and not, to combine multiple conditional statements. These conditional statements will result in a true or false output. For our example, if x was set equal to 6, 6 would be less than 10 and 6 would be greater than 4. So this statement would evaluate to true. Exam Objective 4.2, Identify fundamental data types and their characteristics. Char. Char, which is short for character, is a single textual character that can be a letter of the alphabet, a symbol, or a numerical digit. For the char data type, if a numerical digit is used, it will be treated as text only and you will be unable to perform mathematical operations with it. Surprisingly, the char data type will support relational operations. For a comparison to take place, all char values will first be converted to their binary character code values before comparisons take place. Here we will compare capital A and the lowercase a of the Latin alphabet. Once the letters are converted to their binary values, you can then see that the binary value for capital A is less than the binary value for lowercase a. For this example, we used the ASCII encoding standard. A use case for the char data type would be to store a middle initial of a name within a database or as variable in a computer program. Please note, this information is based on the knowledge needed for the CompTIA Tech Plus certification exam. There are alternative definitions for the char data type, especially when applied to certain databases. Exam Objective 4.2, Identify fundamental data types and their characteristics. String. A string is a collection of textual characters that can be composed of letters of the alphabet, symbols, numerical digits, and spaces. In most programming languages, strings will be easy to spot as they are often wrapped in quotation marks. For the string data type, if a numerical digit is used, it will be treated as text only and you will be unable to perform mathematical operations with it. However, many programming languages do use the addition symbol with multiple string values to perform an operation called concatenation. Concatenation is the operation of joining character strings end to end. By doing so, this operation converts multiple strings into a single string. To demonstrate, we will take the string cyber and concatenate it with the string security. This will result in a single string value of cybersecurity. The string data type also supports relational operations. Strings are compared one character at a time. When different characters are found, then their binary code point values are compared. The character with the lower code point value is considered to be smaller. Here we will compare the string hello and the string hi. We start at the beginning of the strings. Both have a capital H, so we move on to the next letter in each string. We see lowercase e and lowercase I are different, so we will compare their binary code point values. The binary value for e is less than binary value for I, so the string hello will be evaluated as less than the string hi. For this example, we used the ASCII encoding standard. There are many use cases for the string data type. Pretty much any information that uses a series of textual characters. In this example, first and last name fields would certainly be great candidates for the string data type. Exam Objective 4.2, Identify fundamental data types and their characteristics. Integers. Integer is a data type used to represent real numbers that do not have fractional values. This includes whole numbers and their negative equivalents. It probably goes without saying, but you can absolutely use mathematical operations with the integer data type. The integer data type also supports relational operations. There are many use cases for the integer data type. A great example would be an age field. With something like phone numbers, data type selection can be tricky. Technically, you could use the integer data type, but using a string data type will help preserve phone number formatting. Postal codes are also tricky. In the United States, postal codes are 5 numerical digits, but internationally, codes can be alphanumeric. So in certain situations an integer data type could be used, but like phone numbers, the string data type might be the better choice. Exam Objective 4.2, Identify fundamental data types and their characteristics. Floats. Float is a data type composed of a number that is not an integer, because it includes a fractional value represented in decimal format. If you see a decimal point in the value and no quotation marks, there is a good chance it is a float. Now, one thing to be on the lookout for is a whole number represented with a 0 to the right of the decimal point. Do you see the last float example 22.0? The 0 in 22.0 adds no additional value to the number and could easily have been represented as just 22, but as long as there is a decimal point, this will belong to the float data type and not the integer data type. With the float data type, you can absolutely use mathematical operations. You can even mix float data types with integer data types. Just be careful of integer data types turning into float data types as a result of a mathematical operation. Let's use 5/2 as an example. The 5 is an integer and the 2 is an integer. Once the division operation takes place, the quotient becomes 2.5. Now you have a float. Depending on the programming language, this could cause an error. So be mindful of this in the future. The float data type also supports relational operations. A very common use for the float data type is currency or monetary values. The example here is using the float data type to keep track of an account balance. Can you think of any other uses for the float data type? Exam Objective 4.2, Identify fundamental data types and their characteristics. Boolean. Boolean is a special numeric data type that indicates if a condition is true or false. The Boolean value is stored using a single binary digit of either a 0 or 1. So keep on the lookout for the words true and false or any scenario where only two options exist. These are great signifiers that you are working with the Boolean data type. With the Boolean data type, we will be focused primarily on logical operations. Using the AND, OR, and NOT operations, we are able to combine and manipulate conditional statements to derive a true or false output. Let's take a look at each of these logic operations now. First up, we have the logical AND operator. The AND operator returns true if both inputs are true, and returns false otherwise. Let's try an example and compare the inputs to the AND operator table to find the appropriate output. The first conditional statement will be, my shirt is pink. Well, that is a true statement, so we will use true for input A. The second conditional statement will be, my eyes are brown. Well, that is also a true statement, so we will use true for input B. Using the AND operator table, we can now see our resulting Boolean value for this example would be true. Now for the logical OR operator. The OR operator returns true if any input is true, and returns false only when both inputs are false. Let's try an example and compare the inputs to the OR operator table to find the appropriate output. The first conditional statement will be, my shirt is pink. Well, that is a true statement, so we will use true for input A. The second conditional statement will be, my hair is blue. Well, that is a false statement, so we will use false for input B. Using the OR operator table, we can now see our resulting Boolean value for this example would be true, as at least one of our inputs evaluated to true. Finally, the logical NOT operator. The NOT operator returns true if the input is false, and false if the input is true. There are other logical operators, but these will serve as a great foundation for now. Now that we have discussed some of the more common logical operators, where might we find these in use? I got the perfect example. Every day we find ourselves using a search engine to locate a resource on the internet. Well, why not use these logical operators to improve our searches and link search conditions together? For my example, I will use the Google search engine. By using logical operators in your search, you will effectively be performing an advanced Google search. I am going to start with the AND operator. My example search will have us searching for a resource that contains the word CompTIA and the word Tech Plus. By using the AND operator between these two words, Google will return results containing both words. My next search will utilize the OR operator. This example will search for the word CompTIA or the word Tech Plus. By using the OR operator between these two words, Google will return results containing at least one search word or the other, but will not require both words to be present in the resource. Additionally, to exclude a specific word from a search result, just place a subtraction symbol or minus sign in front of the word. Then any resource containing that word will be omitted from your results. Exam Objective 4.4 Identify Programming Organizational Techniques and Logic Concepts. Flowchart Concepts. You might have noticed that this video segment is labeled as Exam Objective 4.4 and wondered, what happened to 4.3? Don't worry, you're not going crazy. At least not yet. I'm covering Exam Objectives 4.3 and 4.4 a bit out of order. That's intentional. It should help the material make more sense as you move through the course. With that cleared up, let's get back to programming. Now, a program is no more than a sequence of step-by-step instructions, also known as an algorithm. For very simple programs, keeping track of these steps during the design process can be easy, but what happens when a program gets significantly more complex? Do you think it would help to have a visual representation of the program? Luckily, we have such a tool. Imagine you're embarking on an adventurous quest through a maze. As you navigate, you encounter pathways, decisions, and obstacles. In the realm of computers, we use programming flowcharts as our guide, helping us visualize and map out the logical journey our programs will take. Think of a programming flowchart as your trusty map. It's a visual representation of the steps and decisions your program will make. Just as a real map helps you find your way, a flowchart guides your program's actions, ensuring it follows the correct sequence. Within a flowchart, you will find a variety of different shapes and arrows with each element having their own meaning. For example, a rectangle might represent a process or task, while a diamond shape signifies a decision point where your program must choose between different paths. The beauty of flowcharts is their universality. They transcend programming languages, making them a powerful tool for both beginners and seasoned programmers. Programming flowcharts are your compass in the realm of coding. Whether you're building games, apps, or solving real-world problems, they guide you through the logical twists and turns, ensuring your programs run smoothly and efficiently. Exam Objective 4.4 Identify Programming Organizational Techniques and Logic Concepts. Pseudocode Concepts. In this video, we will be covering the topic of pseudocode. Pseudocode is a simplified and human-readable representation of a computer program's logic and algorithm, expressed in natural language or basic code-like syntax. Using pseudocode helps programmers outline and plan the steps a program should take without focusing on specific programming language details. Here is an example of some pseudocode, and I have placed it side by side with its equivalent Python code. The pseudocode on the left is just a plain language description of the steps in an algorithm. It uses structural conventions of a normal programming language, but is intended for human reading rather than machine reading. With pseudocode, being precise is not as important as getting your code organized. This is very similar to the pre-writing phase of the writing process. The pseudocode is just your rough draft of the program logic. After completing your pseudocode, you should be ready to clean it up and write the actual code in accordance with the specific syntax and format of your desired programming language. Or in the case of my example here, Python. Exam Objective 4.3 Explain the purpose and use of programming concepts. Let's get coding. Over the course of the next few video segments, I'll be diving into a range of fundamental programming concepts that have universal relevance across different languages. Each of the topics outlined in CompTIA's Tech Plus exam objectives was selected in order to provide you with a solid foundation upon which to construct your understanding of coding. These programming concepts include identifiers, containers, logic components, functions, and objects. As I explain each programming concept in detail, I plan to harness the power of flowcharts. They will help as a dynamic tool to demystify intricate coding concepts. These flowcharts will serve as your compass, guiding you through the intricate pathways of logic and decision-making within programming. By employing these illustrative diagrams, my hope is to convert complex ideas into intuitive visual narratives, making even the most intricate coding concepts feel like a walk in the park. Also, where appropriate, I will incorporate pseudocode and Python code to further assist with topic comprehension. Now that you know what to expect, join me as we take a step-by-step exploration through these essential programming concepts. Exam Objective 4.3 – Explain the purpose and use of programming concepts. Identifiers. In this video segment, we will learn about two specific types of program identifiers, a variable and a constant. But first off, let's talk about identifiers as a whole. You can think of an identifier as a symbolic name that points to a specific location in the computer's memory. Just like your name helps people identify you, identifiers help the computer keep track of different pieces of information, referred to as values. Looking at the graphic behind me, you can imagine the computer's memory or RAM as a bunch of boxes. Each box holds some data. It could be a number, a word, or anything else. Identifiers are like labels on these boxes. They tell the computer which box to look in when it needs that particular piece of information. Great, now we can break this topic down a bit more and focus on a specific type of identifier called a variable. In keeping with our box analogy, a variable is like an open box that can hold different things at different times. For example, you might have a variable called num2 that holds an integer value. You can put different values into this box, and the computer will remember them. Maybe you start with the value 20. But then change it to 47. The variable num2 can be reassigned to the new value just like that. And though the value has changed, the identifier's symbolic name and the location where it is stored in memory will not. Our next type of identifier is called a constant. This will behave very similar to a variable at first. With a constant, our box will start open, but once we assign a value to a constant, the box will be closed for the remainder of the program's runtime. In short, a constant holds a single value that doesn't change. Imagine you have a box labeled pi. You then assign the value 3.14 to the constant pi. From that moment forward, our box will be sealed and you will be unable to change this value. Now that we know what a variable and a constant are, there is one last thing I want to cover before we jump into our first coding example. Once again, look at this flowchart. Where does our program start? I hope you shouted out, at the top. And if you did, you are right. Coding works the same way. Reading code line by line, from top to bottom, is fundamental to programming. When looking at a program, you will need to get comfortable sequentially following the execution path of the program from the first line at the top to the last line at the bottom. Doing so enables you to track variable changes, understand the flow of logic, and observe control structures. Just as you read a book or follow a set of instructions step by step, reading code linearly allows you to progressively build a comprehensive understanding of how the program operates. Now we can work with some very simple code. 5 lines of code to be exact. I have even numbered the lines of code to help keep things organized. So where should I start? At the top, with line 1 of course. Here we see x equals 5. This is called an assignment statement, as it assigns a variable with a value, in this case the integer 5. You can read this quite literally as x is assigned with the value 5. For this assignment statement, the identifier is x. This is the symbolic name that will be used by the computer to reference the value's stored location in memory. The equal sign here is referred to as an assignment operator as it performs the function of assigning a value, and 5 is the value being stored. The order is also very important. The identifier will always be on the left and the value on the right of the assignment operator. If you look at the top right of the screen, I have intentionally positioned a box that will help us keep track of our variable values as we progress through the lines of code. Okay, on to line 2. Here the value of x is replaced with the integer 6. Because it is a variable, we can reach in and remove the 5 and replace it with the 6. Now, on line 3, we see something a bit different. Here the current value of x is 6, but we are going to replace it with its current value plus 2, causing our new value to be 8. On line 4, we will be declaring a new variable y. This y variable will be assigned the current value of x, which happens to be 8. And for our last line of code, we will declare yet another variable z, and assign it the value of x plus y. Since the value of x is currently 8 and the value of y is currently 8, z will become 16. This should give you some insight into how variables work. As for constants, the process is the same with the exception that you cannot change the value after the initial assignment. So where do you use these variables and constants? Well, just about any time a program needs to store a value in a place that can be accessed quickly and where you need the value to remain in memory only while the program is running. And there you have it, the basics of variables and constants with regards to computer programming. Exam Objective 4.3, explain the purpose and use of programming concepts. Containers. In this video segment, we will build upon the concept of identifiers and learn about containers. Containers are just a special type of identifier and will therefore have many of the same properties as a variable or a constant. Containers will still have a symbolic name that points to a specific location in the computer's memory. And these symbolic names will still help the computer keep track of different pieces of information, referred to as values. So how are these containers different from a standard identifier? Well, they are capable of holding more than one data element at a time. While a standard variable or a constant can only hold one data element at a time, a container can hold 1, 2, 3, or more data elements simultaneously. Great, now we can break this topic down a bit more and focus on two specific container types, the array and the vector. But before I do, a quick disclaimer. For this topic I will be following the terminology and definitions provided in CompTIA's official study guide. Outside of this course, you will find some ambiguity with regards to this topic as each programming language is likely to use slightly different terminology and definitions for arrays and vectors. Okay, so how does CompTIA define an array? An array is a special type of identifier that can reference multiple values. These values can be arranged in a single or multi-dimensional manner, which you can visualize like a table with multiple columns and rows. Additionally, an array will be of a fixed size, meaning you cannot resize it after it is declared. Now how does CompTIA define a vector? A vector is another special type of identifier that can reference multiple values. These values can also be arranged in a single or multi-dimensional manner. But a vector differs from an array in one major way. A vector has the ability to grow or shrink in size. Now let's work with some very simple code starting with the review of a standard variable. In line 1, we declare a variable x by using the code x equals 5. If you recall from the previous video on identifiers, this is called an assignment statement, as it assigns an identifier with a value. For this assignment statement, the identifier is x. This is the symbolic name that will be used by the computer to reference the value's stored location in memory. The equal sign here is referred to as an assignment operator as it performs the function of assigning a value, and 5 is the value being stored. Now, in line 2, we have a container. Here the identifier is numList. This is still considered an assignment statement, as it assigns a container with a set of values, in this case the integers 5, 6, and 8. And for one more example, we have a container that is given the identifier animals. This container is assigned multiple string values, specifically cat and dog. So where do you use arrays and vectors outside of my example code? Well, just about any time a program needs to store a set of values. This could include storing a list of items, like the months of the year, or collection of data, like a list of strings containing customer names. And there you have it, the basics of containers with regards to computer programming. Exam Objective 4.4, identify programming organizational techniques and logic concepts. Branching. Up till now, we have only looked at code running line by line, from top to bottom. This is like driving down a straight road with no exits, twists, or turns. This works for the most basic of programs, but this will not allow our programs to make decisions. So how can we add decisions and variants into our programs? Well, we have a control structure for that, referred to as branching. A branching statement provides a program with a decision. While driving from one city to another, we could take a straight route down the highway, but in reality we could very likely choose from many different paths that all lead to the same destination. This is the exact idea to keep in mind as we explain this topic of branching statements. Using the power of flowcharts, I will illustrate a branching statement. As usual, we will start at the top of our code. Next in the code, we encounter a branching statement. Here we are presented with a decision in the program as denoted by the diamond-shaped symbol. This flowchart displays a decision having two possible options. Option 1 would result in output 1, while option 2 would result in output 2. And regardless of which decision is made, both branches will eventually merge back together and continue with any remaining code statements, or in our case, reach the end of the program. Now I am going to zoom in on the decision portion of this branching statement. When we reach a branching statement, our program will of course have a decision to make. But how does a computer program make a decision? Well, that is the next piece in this puzzle. A branching statement will use a condition statement to aid in the decision-making process. A condition statement will present a true or false scenario. For our example, I am using the condition statement if num is greater than 2. With this statement, we will be looking at the num variable and checking whether it is greater than 2. Now, should the variable num have a current value of 10, the conditional statement would evaluate to true, as 10 is greater than 2. This would result in our code displaying output 1. But, if the current value of num was 1, the conditional statement would evaluate to false, as 1 is not greater than 2. This would result in our code displaying output 2. Hopefully you now understand the concept of branching statements and the conditional statements that drive them. Now it is time for some more terminology. Next we will take these concepts and apply them to coding directly. In most programming languages, a decision with two branches is often called an if-else statement. With this code arrangement, if the conditional statement evaluates to true, then the first branch, which would be the if branch, will execute. Otherwise, if the conditional statement evaluates to false, the second branch, which would be the else branch, will execute. Or to put it another way, the else branch acts as a catch-all for any scenario where the if statement is not found to be true. To wrap up this video segment, let's take a look at an if-else branch using some pseudocode and walk you through the code line by line. For our example, we will have some fun and pretend we are working with some military security clearance levels. First up, let's take an input for the user variable. Our input will be general. In receiving this input, our user variable becomes equal to general and is stored in memory. Next we see on line 2, if, and on line 4, else. These are our two possible branches. You will start with the if statement and see whether or not the condition evaluates to true. Since user does indeed equal general, our condition is true and we will execute the indented line of code. This line of code declares a variable with the identifier of clearance and assigns it the value of top secret. Now this next piece is very important. Because our if branch was selected, we will now skip over lines 4 and 5, which includes the else branch and the code indented underneath it. Just as you can only take one path on the highway each time you go from one place to another, you only execute one path in a branching statement each time it is encountered in the code. Once we have concluded with the branching statement, we pick up on the very next line of code and continue on. As for this last line of code, the program is directed to print, or output the value currently stored within the variable clearance, which happens to be top secret. Great job for making it this far. In the next video, we will build upon this concept and see how we can add additional branches. Exam Objective 4.4, Identify Programming Organizational Techniques and Logic Concepts. Branching continued. In the previous video segment on branching, we covered if-else statements. This was a perfect coding technique to use when presented with a choice that has only two possible outcomes. But what if we have 3 or more possible outcomes? Time to bring in the else-if branch. The else-if branch is a branch statement that will contain an additional condition statement. It behaves exactly as the original if branch, with one exception: the if branch condition is checked prior to any else-if condition. Using flowcharts, I will illustrate this new concept. As usual, we will start at the top of our code. Next in the code, we encounter a branching statement. Our first conditional statement will be our if statement. The if statement will present a condition that needs to be checked. When the if statement's condition evaluates to true, the code will display output 1. But when the if statement's condition evaluates to false, the code moves on to the next branch. For this scenario, that would be the else-if statement. And just as it sounds, else-if is much like a backup plan for when plan A fails. Here your code will repeat the condition check process, but this time the check will be performed using the else-if conditional statement. When the else-if statement's condition evaluates to true, the code will display output 2. Now, should the if statement and the else-if statements all evaluate to false, the code moves on to the else branch. This is our catch-all branch as there is no conditional statement that has to be satisfied. For this scenario, the else branch leads to output 3 being displayed. And once again, regardless of which decision is made, all branches will eventually merge back together and continue with any remaining code statements, or in our case, reach the end of the program. To wrap up this video segment, let's take a look at another branching statement. Again, I will utilize some pseudocode and walk you through the code line by line. For this example, we will be going to the circus and we will need to determine our ticket price based on age. First up, let's take an input for the age variable. Our pretend person will be 20 years old. In receiving this input, our age variable becomes equal to 20 and is stored in memory. Next, we need to evaluate whether or not the conditional statement for the if branch is true or false. In this case, our current age of 20 is not less than 4, so the statement is false. This causes us to skip line 3 and pushes us down to the else-if branch. Now we need to evaluate whether or not the conditional statement for the else-if branch is true or false. In this case, our current age of 20 is not less than 18, so the statement is false. This leads us to skip line 5 and go straight to the else branch, our catch-all. Here there is no conditional statement. With no check to perform, we jump right into this branch and execute the indented statement on line 7. This is an assignment statement that declares the variable price and assigns it the value shown. Once we have concluded with the branching statement, we pick up on the very next line of code and continue on. As for this last line of code, the program is directed to print, or output the value currently stored within the variable price. This can be seen on the right-hand side under output. Wow, you are crushing this topic. In the next video, we will take everything we have learned about coding thus far and try to solve a few practice questions. Exam Objective 4.4, Identify Programming Organizational Techniques and Logic Concepts. Branching Practice. Time to practice your new coding skills with some practice questions. These questions are specially designed to prepare you for the CompTIA Tech Plus exam. Each question will contain pseudocode represented in different ways. Remember, there are no hard rules on how to write pseudocode, and CompTIA likes to be a bit tricky, so it is best to be prepared for anything. Ready? Here is question 1. Examine the following pseudocode. If the variable num is set to 4, what will be the output? If you want to try and solve this question on your own, pause this video now. Otherwise, I will go through the code line by line. In line 1, we have an if statement, so we know this is the first part of a larger branching statement. Your first task is to evaluate if num is greater than 7, which is a false statement, as num is equal to 4 and 4 is not greater than 7. So we head on down to the next branch statement on line 3. Here we evaluate if num is less than 11. This is true, as num is equal to 4 and 4 is less than 11. So this is the branch we will execute. The only statement in this branch is to print, which means to output the string b. So, the answer to this question is B. Now many of you may be looking at line 5. The condition num equals 4 is pretty tempting. Am I right? But don't fall for this. Remember that we start with the first branch and work our way down the code sequentially until we find a branch that evaluates to true. Once we do, that is the path we take. You can only choose one path. In this question, the computer never even considers the third branch containing the num equals 4 conditional statement, as it had already selected the previous branch. Here is question 2. Examine the following pseudocode. What will be the output of this code? If you want to try and solve this question on your own, pause this video now. Otherwise, I will go through the code line by line. First off, remember this is pseudocode. Here we just need to follow the logic and consider the pseudocode as a truncated form of spoken language. Okay, for this question, the case on line 2 and end case on line 8 is pseudocode representing the beginning and end of this branching statement. And lines 3 through 7 are our different branches. Knowing this probably makes this question seem a lot easier, doesn't it? Now, in line 1, we have an assignment statement. This statement declares a variable with the identifier score and assigns it the value of 70.00. Line 2, case, opens our list of possible branches. From here we go branch by branch or line by line until we find a conditional statement that evaluates to true. The branch on line 3 evaluates to false, as our score of 70.00 is not greater than 90. The branch on line 4 also evaluates to false, as our score of 70.00 is not greater than 80. The branch on line 5 is where most would make a mistake. In coding we have to be precise. This branch evaluates to false as the score variable may be equal to 70, but it is not greater than 70. In computer programming, that is a huge difference. Now, the branch on line 6 evaluates to true, as our score of 70.00 is greater than 60. So we read on and are instructed to declare and set a variable identified as grade to the string value of D. Now that we have chosen a branch, we move on to the next line of code following the branch statement. This is line 9. Here the code outputs the value of the grade variable, which is currently D. D is our final answer. If you found these example questions helpful, please share your thoughts in the comments. Also, I look forward to seeing you in the next video segment where we will begin our study of loops. Exam Objective 4.4 Identify Programming Organizational Techniques and Logic Concepts. Looping. At first, we looked at code running line by line, from top to bottom. Then we moved on to branching, which provided our programs with the power of choice. But now we are going to add one more logical component to our coding repertoire: looping. Programming loops are structures in coding that enable the repetition of a specific set of instructions until a certain condition is no longer met. They allow for automating repetitive tasks, making your code more efficient and concise. Using the power of flowcharts once again, I will illustrate the concept of a programming loop. As usual, we will start at the top of our code. Next in the code, we encounter a loop statement. Here we are presented with a decision in the program as denoted by the diamond-shaped symbol. This flowchart displays a decision of whether to enter the loop or continue on with the remainder of the code. If we enter the loop, we will execute the code included inside the loop. In this case, we have a process to be performed, and then an output of some sort. After the code inside the loop is executed, we return back to the decision point. Here we are once again presented with the option to enter the loop or continue on with the remainder of the code. This looping process can be repeated as many times as necessary by the program. Once the program has finished with the loop, it will continue on with any remaining code statements or, in our case, reach the end of the program. Now that we have discussed the basic concept of looping, in the next few video segments, we will progress deeper into this topic by exploring two common loop types: the while loop and the for loop. The while loop and the for loop. The while loop and the for loop. Uh-oh. Looks like I got caught in a loop myself. Exam Objective 4.4 Identify Programming Organizational Techniques and Logic Concepts. While loops. For this video segment, we will discuss while loops. A while loop is a programming construct that repeatedly executes a block of code as long as a specified condition remains true. The loop continues to run until the condition evaluates to false, at which point the program moves on to the next section of code outside the loop. A while loop is best used in situations where you don't know beforehand how many times the code needs to be executed, and you want the loop to continue until a certain condition is no longer met. We will now take a closer look at the decision portion of this while loop. A while loop starts with a condition check. Before entering the loop, the condition specified in the while statement is evaluated. If the condition is true, the code inside the loop is executed. If the condition is false from the start, the loop will not be executed at all. For our example, we will be checking if the variable num is a positive integer or greater than 0. To start things off, our variable num is equal to 4, so the condition check is num greater than 0 will evaluate to true. This will cause us to execute the code within the while loop. Next, we will receive an integer from a user that will be assigned to the num variable and replace our current value. Here we will assume the value 2 was provided as an input. Here our program will perform some type of process, and then we will return back to the condition check of the while loop. At this point, we have completed the while loop once. Now it is time to reevaluate and see if the condition statement of the while loop is still true. Here we can see that the variable num, which is now equal to 2, is indeed still greater than 0, so we will execute the code within the while loop a second time. So again, we will receive an integer from a user that will be assigned to the num variable and replace our current value. This time we will assume the value -1 was provided as an input. Here our program will perform some type of process and then we will return back to the condition check of the while loop. At this point we have completed the while loop twice. Now it is time to once again reevaluate and see if the condition statement of the while loop is still true. Here we can see that the variable num, which is now equal to -1, is no longer greater than 0, so we will not execute the code within the while loop anymore, since the condition check has now evaluated to false. We will continue with any remaining code statements or in our case, reach the end of the program. Now that we got the flow of things, let's take a look at a while loop using some pseudocode and walk through the code line by line. For our pseudocode example, we will keep things very simple. First up, we will declare a variable with the identifier x and initialize it with the value of 0. On line 2, we see a condition statement for a while loop. Our condition statement calls for our program to check if x is less than 2. Since the value of the variable x, which is currently 0, is less than 2, we will execute the code statements within the loop. The word begin on line 3 is only used here to mark the beginning of the looped code statements. So let's continue on. On line 4, we will reassign the variable x with the current value of x plus 1. This is a very important part of the while loop, since the condition check of the while loop is based on the value of x. If our loop does not provide a way for x to be modified in some way that will eventually cause the condition to evaluate to false, we could find our code stuck in an endless cycle, or what is referred to as an infinite loop. On line 5, our program prints out the value of variable x, which is now 1. On line 6, we have the word end to mark the end of the looped code statements. Now we head back up to line 2 and start the while loop all over again. This time we perform a reevaluation and check if x is still less than 2. Since the value of the variable x, which is currently 1, is less than 2, we will execute the code statements within the loop again. Next, we see the word begin. This opens our looped code. We reassign x with the current value of x plus 1, making 2 the new value. We print out the value of x, which is currently 2, and append it to the previous output of 1. Next, we see the word end. This closes our looped code. And finally, we pop back up to the top of the loop to perform our condition check a third time. This time we see that x is equal to 2 but no longer less than 2, so our condition evaluates to false. This causes our program to move to the next line after the while loop. In this example, since there is no more code, our program is done. Great job! In the next video, we will try to solve a few practice questions using what we have learned about while loops. Exam Objective 4.4, Identify Programming Organizational Techniques and Logic Concepts. While loop practice. Time to practice your new coding skills with some practice questions. These questions are specially designed to prepare you for the CompTIA Tech Plus exam. Each question will contain pseudocode represented in different ways. Remember, there are no hard rules on how to write pseudocode, and CompTIA likes to be a bit tricky, so it is best to be prepared for anything. Ready? Here is question 1. Examine the following pseudocode. What will be the output? If you want to try and solve this question on your own, pause this video now. Otherwise, I will go through the code line by line. In line 1, we declare a variable at num. In line 2, we set the variable at num to the value of 8. On line 3, we see a condition statement for a while loop. Our condition statement calls for our program to check if at num is less than 10. Since the value of the variable at num, which is currently 8, is less than 10, we will execute the code statements within the loop. The word begin on line 4 is only used here to mark the beginning of the looped code statements. So let's continue on. On line 5, we will reassign the variable at num with the current value of at num plus 1, resulting in a value of 9. Remember, this is a very important part of the while loop, since the condition check of the while loop is based on the value of at num. If our loop does not provide a way for at num to be modified in some way that will eventually cause the condition to evaluate to false, we could find our code stuck in an infinite loop. On line 6, we have the word end to mark the end of the looped code statements. Now we head back up to line 3 and start the while loop all over again. This time we perform a reevaluation and check if at num is still less than 10. Since the value of the variable at num, which is currently 9, is less than 10, we will execute the code statements within the loop again. Next, we see the word begin. This opens our looped code. Then line 5 will increment our variable at num by 1 again, setting its value to 10. This is followed by the word end, which closes our looped code. And finally, we pop back up to the top of the loop to perform our condition check a third time. This time we see that our variable at num is equal to 10, but no longer less than 10, so our condition evaluates to false. This causes our program to move to the next line of code after the while loop, which happens to be line 7. On line 7, our program prints out the current value of at num, which is now 10. So our answer to this question is 10. Here is question 2. Examine the following pseudocode. What will be the output? If you want to try and solve this question on your own, pause this video now. Otherwise, I will go through the code line by line. In line 1, we declare a variable mynum and assign it the value of 1. On line 2, we see a condition statement for a while loop. Our condition statement calls for our program to check if mynum is less than 2. Since the value of the variable mynum, which is currently 1, is less than 2, we will execute the code statements within the loop. The word begin on line 3 is only used here to mark the beginning of the looped code statements. So let's continue on. On line 4, we will print out the value of mynum plus 4. This will cause the program to output the value of 5. On line 5, we have the word end to mark the end of the looped code statements. Now we head back up to line 2 and start the while loop all over again. This time we perform a reevaluation and check if mynum is still less than 2. Since the value of the variable mynum, which has never changed, is less than 2, we will execute the code statements within the loop again. But let me pause here for a moment. See anything wrong with this scenario? If you notice that we have an infinite loop, you are absolutely right. In this loop there is only one statement, and that statement has the program output the value of mynum plus 4. This is not a reassignment statement. So mynum will forever remain at 1 and our while loop condition statement will forever evaluate to true. Now, when running a program that encounters an infinite loop, you are likely to see nothing printed as our program will fail. So just disregard the output of 5 we had a moment ago, as the correct answer to this question would be nothing. Here is question 3. Examine the following pseudocode. What will be the output? If you want to try and solve this question on your own, pause this video now. Otherwise, I will go through the code line by line. In line 1, we declare a variable counter and assign it the value of 1. On line 2, we see a condition statement for a while loop. Our condition statement calls for our program to check if the variable counter is greater than 4. Since the value of the variable counter, which is currently 1, is not greater than 4, we will not execute the code statements within the loop. This causes our program to move to the next line of code after the while loop, which happens to be line 6. On line 6, our program prints out the current value of counter, which is 1. So our answer to this question is 1. Now that was an easy one. But in all honesty, I hope you find all while loops easy, now that you have had a little practice. Exam Objective 4.4, Identify Programming Organizational Techniques and Logic Concepts. For loops. For this video segment, we will discuss for loops. A for loop is a programming construct that is very similar to a while loop, but they differ slightly in their structure and application. Both loops repeat a block of code, allowing for efficient automation of repetitive tasks. The key difference lies in their decision mechanisms. A for loop, as pictured on the left, typically specifies the number of iterations prior to execution, making it ideal for situations where the number of iterations is known in advance. On the other hand, a while loop, as pictured on the right, relies on a condition to control its execution, making it more suitable for scenarios where the number of iterations is uncertain. Now that we got the flow of things, let's take a look at a for loop using some pseudocode and walk through the code line by line. Our example will demonstrate a for loop which specifies a counter variable, I, along with its start and end values. By specifying the start and end values for I, we are designating in advance how many times we want to iterate through this for loop using integer values. This example will also include the keyword, next. A next statement is used in certain languages to increase the counter variable by the value of 1 each time the loop completes an iteration. Ready to walk through this example line by line? Alright, let's go. First up, we will declare a variable with the identifier y and initialize it with the value of 4. On line 2, we see a for loop statement. The for loop statement starts with the word for. This is followed by the declaration of a counter variable. For this example, our counter variable will be I. This variable is appropriately named as it will help us keep count of which iteration of the loop we are on. Next we have our start and end values. With this statement, we know that we will continue this for loop from the time our counter variable I starts at 0 and continue until our counter variable I reaches 2. Being that this is our first iteration, our I variable will be set to the value of 0 for now. The indented code statement on line 3 is part of our looped code. It will reassign the variable y with the current value of y plus 1. Y will now be set to the value of 5. On line 4, we see the word next. This next statement will increase the counter variable by the value of 1 and mark the end of our loop's first iteration. Now we head back up to line 2 and start the for loop all over again. Since the value of the variable I, which is currently 1, is still in the range of 0 to 2, we will iterate through the for loop again. On line 3 we will reassign y with the current value of y plus 1, making 6 the new value. On line 4, we see the word next. This next statement will increase the counter variable by the value of 1 and mark the end of our loop's second iteration. Next, we pop back up to the top of the for loop again. Since the value of the variable I, which is currently 2, is still in the range of 0 to 2, we will iterate through the for loop again. On line 3 we will reassign y with the current value of y plus 1, making 7 the new value. On line 4, we see the word next. This next statement will increase the counter variable by the value of 1 and mark the end of our loop's third iteration. Now, this time when we pop back up to the top of the for loop, since the value of the variable I, which is currently 3, is no longer in the range of 0 to 2, we will not iterate through the for loop again. Instead we will continue on in the code with the next line following the for loop, which is line 5. On line 5, we will reassign y with the current value of y plus 5, making 12 the new value. We also no longer retain the counter variable I in memory, as we have finished with our for loop. Next on line 6, we see the word echo. Echo is a word used by some programs to perform an output. In this case, our program is called to output the value of y, which is currently 12. And with no more lines of code, our program ends. Now, if you ever feel like you're stuck in an infinite loop of confusion, just press pause, grab a snack, and debug your frustrations before diving back into our video series. Exam Objective 4.3, Explain the purpose and use of programming concepts. Functions. Let's start with the basics. What exactly is a programming function? In simple terms, a function is a reusable block of code that performs a specific task or set of steps. This enables programs to be divided into reusable components. Think of it as a set of instructions that we can call upon whenever we need to perform that task, without having to write the same code over and over again. Now, let's explore the input and output aspect of a function. Think about a vending machine. You put coins in, that is your input, then you press a button, and out comes your snack, that is your output. Functions work in a similar fashion. You feed them some data or values as input, they process it, and then they give you back an output. And now, let's explore how to put our functions to work. In programming, this is referred to as calling the function. This involves using its name and passing the function any necessary inputs. The function can then carry out its tasks and hands you back an output. I have provided you with a definition for functions, and we have discussed inputs, outputs, and calls. While this would be enough information to answer any questions about functions on the Tech Plus exam, I think you would benefit from seeing this concept in action. So here we go. For my coding example, I will be using Python. Okay, time to go line by line. On line 1, we declare a variable named global number and assign it the value of 4. On line 2, I have left a space. This is common practice just before defining a function, as it makes your code easier to understand. On line 3, we define our function. Def is a keyword used to define a function in Python. This is followed by the function name. The function name is what we will use to call the function when needed. I have named this function double, as the purpose of this function will be to take a number as an input and output twice that number's value. Inside the parentheses, we have a parameter. In the context of a function, a parameter is a variable that is used to pass information into a function. Here I have named our parameter local number. On lines 4 and 5, we have 2 indented code statements. These are the lines of code that will execute when the function is called. Line 4 reassigns the variable local number with the current value of local number times 2. On line 5 we output the new value of the local number variable. On line 6, I have left another space to assist in the readability of the code. On line 7, we call the function double by using its name. Inside the parentheses is our variable global number. This is the input we will pass to the function. This input will then become our parameter or variable named local number. And that is what a function will look like in code. Now, one more concept to learn before I wrap up this video on functions. I would like to teach you about global and local variables. And I must admit, I was deliberate when choosing my variable names this time around. Global and local variables are fundamental concepts in programming that define the scope or accessibility of variables within a program. A global variable is one that is defined outside of any function or code block. It holds a scope that extends throughout the entire program, enabling it to be accessed and modified from any part of the code. These variables are often declared at the beginning of a program. On the other hand, local variables are confined within a specific function or code block. They have a localized scope, restricting their accessibility to only the function or code block in which they are defined. These variables are particularly useful for storing temporary data required for a specific operation or calculation. Since each function call establishes its own scope, local variables within that scope don't affect other parts of the program. In summary, global variables offer universal accessibility throughout the program, while local variables are confined within their respective functions or code blocks. Additionally, local variables will no longer exist in memory when the function that defines the variable finishes and passes control back to its calling program. Exam Objective 4.3, Explain the purpose and use of programming concepts. Objects. You can think of an object in programming as a digital version of something real. It could be a car, a customer, a game character, or even something abstract like a calendar event. An object is a self-contained unit that stores data and the actions it can perform. This makes it much easier to manage complex systems by grouping related information and behaviors together. So why do we use objects in programming? In the real world, systems are made up of many moving parts. If we had to manage every little detail on its own, it would be chaotic and difficult to maintain. Objects solve this by grouping related information and behaviors together, making code easier to understand and manage. Now let's bring this idea to life with an analogy. Picture a 2023 Toyota Corolla. The car itself is the object. It holds specific details, and it can perform certain actions. Just like a car is more than just a collection of parts, a programming object is more than just data. It includes the tools to interact with that data. Before we dive into the technical terms, take a moment to think about how we describe and interact with real-world objects. When you look at a car, you naturally notice things like its color, make, and model. You also know it can perform certain actions, like speeding up or coming to a stop. In programming, we use similar ideas to describe and control objects. So let's begin with what an object knows. These are called attributes. An attribute is a variable that holds data about the state or characteristics of an object. Attributes help define what the object is by storing its current information. For your 2023 Corolla, attributes might include the year, make, model, and color. These facts describe the car and give you a snapshot of its identity at any given moment. Next, let's talk about properties. A property is a tool that lets you safely view or update the attributes stored in an object. It helps protect the data by controlling how it is accessed or changed. Properties act as a bridge between the internal data and the external code that uses the object. They often allow data to be read or changed, but in a safe and structured way. Going back to our 2023 Toyota Corolla, let's say the color is one of its attributes. A property would allow you to safely check or update the color. For example, you might use a property to change the color to silver. This gives you a simple and safe way to interact with the object's data without accessing it directly. As an added layer of control, the property could also include a rule that limits your choices to approved paint options, like silver, blue, black, or red. That way, if someone tries to set the color to something invalid, like invisible, the property would block the change. This helps make sure the attributes of an object stays accurate and consistent with real-world logic. Now let's move on to methods. A method is a function that belongs to an object and defines an action the object can perform. Methods operate on the object's data and allow us to trigger specific behaviors. In our Corolla example, methods might include accelerate, brake, and refuel. Each method defines something the car can do in response to an input or situation. To tie it all together, imagine yourself behind the wheel of that 2023 Corolla. When you press the gas pedal, you're triggering the accelerate method. When you step on the brakes, you're calling the brake method. And when you pull into a gas station and fill up the tank, that's the refuel method in action. You don't need to understand all the internal mechanics. You just perform an action, and the object responds safely, consistently, and intelligently. And that's what makes programming with objects so powerful. They bring structure, simplicity, and real-world logic to the digital world. Exam Objective 5.1. Explain the value of data and information. Data, information, and insights. To begin our study of Domain 5.0, Data and Database Fundamentals, it's important to start with a clear understanding of three key terms: data, information, and insight. These terms are often used interchangeably, but in the world of technology and databases, they each represent a different stage in the journey from raw input to meaningful understanding. Let's start with data. Data refers to raw values collected by a computer system. These values have no meaning on their own. They're simply facts or figures, numbers, words, or symbols that have been gathered but not yet analyzed or explained. To make this more relatable, imagine the value 100. Without any context, the number 100 could mean almost anything. It could represent a temperature, a score on a test, a dollar amount, or the number of users visiting a website. In this state, it's just data, undefined and disconnected. Now that we've seen how data alone doesn't tell us much, let's talk about what happens when we give that data some structure and meaning. Information is the result of processing data into a form that is understandable and useful. It gives us context and allows us to start making sense of what the data represents. Continuing with our earlier example, let's take that raw data value of 100. On its own, it meant nothing. But if we now say it represents 100 miles, we've added context. Suddenly, we know we're talking about a measurement of distance. The number now has meaning, and that's what turns data into information. So far, we've seen how data becomes information when we add context. But what happens when we go a step further, when we combine multiple pieces of information and start to interpret what they mean? That brings us to our final definition: insight. Insight is a meaningful understanding that comes from analyzing information. It's the result of looking at patterns, relationships, and context to draw conclusions or make informed decisions. Let's revisit our example one last time. We've already turned the raw data of 100 into the information 100 miles. But now, think about what that distance means. 100 miles could seem like a very long distance if you're walking. On the other hand, it might feel like a short trip if you're flying in a plane. By combining the distance with details about how we're traveling, we gain different insights. Same data, same information, but very different conclusions depending on the situation. Exam Objective 5.1. Explain the value of data and information. To continue our journey through Domain 5.0, we're going to take a closer look at the value of data and information and how both are viewed as assets. Let's start with the term asset. An asset is something owned by a person or company that is considered to have value. When you hear the word asset, you probably think of physical things, like houses, cars, or expensive equipment. But in today's digital world, there's another type of asset that often goes overlooked, and that's data. Digital data might seem like nothing more than a stream of zeros and ones. But make no mistake, data can carry significant value. It can reveal customer trends, power decision-making, help optimize business operations, or even support entire industries. Whether it's personal information, proprietary research, or financial records, digital data is often just as valuable, if not more valuable, than many physical assets. And that's why data is now universally regarded as a digital asset. Now that we understand data can be valuable, it's important to recognize that not all data holds the same level of importance. This brings us to the difference between critical and non-critical data. Critical data is data that a business or individual relies on to function. If this data is lost, stolen, or corrupted, the consequences could be serious. Think of things like customer payment records, medical files, or intellectual property. Losing this kind of data could shut down business operations, cause legal trouble, or result in financial loss. On the other hand, non-critical data might still be useful, but it doesn't impact the core functioning of a system or business if it's lost. Examples might include draft documents, system logs, or outdated reports. While losing this data might be inconvenient, it won't grind operations to a halt. Being able to tell the difference helps organizations focus their resources, especially when it comes to data protection and backup planning. As mentioned earlier, one form of critical data includes intellectual property. Intellectual property refers to a category of property that includes creations of the human intellect. This could include inventions, designs, artistic works, brand names, and more. For the CompTIA Tech Plus certification, we'll focus on 3 specific types of intellectual property: trademarks, copyrights, and patents. Let's start with trademarks. A trademark is a type of intellectual property consisting of a recognizable sign, design, or expression that uniquely identifies one product or service from others. Think of company names like Nike, slogans like "Just Do It," or logos like the Golden Arches for McDonald's. These trademarks help create identity and build trust. Companies use them to stand out and protect their brand. Next, we have copyright. Copyright is a type of intellectual property that protects original works of authorship from publication, distribution, and sale without the author's permission. To be eligible for copyright protection, a work must exist in tangible form, meaning it's written down, recorded, published, or digitally stored. Most people associate copyright with books or articles, but it also applies to music, videos, artwork, websites, and even software code. If someone creates a unique digital logo or writes a program from scratch, copyright helps ensure that work isn't misused by others. The third type of intellectual property is the patent. A patent gives someone exclusive rights to an invention, whether it's a product, a new process, or a unique way of solving a problem. Unlike copyright, which protects specific expressions, a patent protects the idea itself, even if it hasn't been physically created yet. This is especially important in science, engineering, and technology fields where innovation is key. A valid patent means no one else can legally produce, use, or sell your invention without your permission. Now that we've covered the value of data, especially critical data and intellectual property, there's one final takeaway. Valuable data needs strong protection. Just like you might install a security system in your home or car, you should also take steps to protect your digital data. That includes everything from user passwords and personal records to company secrets and intellectual property. The more valuable the data, the more essential it is to invest in security. Think encryption, firewalls, access control, backups, and even physical security measures. Whether you're an individual or an organization, protecting your data is no longer optional, it's a necessity. Exam Objective 5.1 Explain the value of data and information. Data-driven business decisions. This whole exam topic will be about the process of using data to make business decisions. The first step to making any informed decision is to collect data. A computer can collect data from input devices, other computing devices, or software programs. In reality, this list is endless. This data is then stored in storage drives as raw data, in databases, or large-scale data warehouses and data centers. Once enough data is collected, correlations can be made. In the world of IT, correlations are simply relationships between data points. The advantage of using computing devices to scan for correlations is that a computer can perform the analysis of data points exponentially faster than a human can. To give a real-world example of correlation, we have found that asking viewers to subscribe at the end of each video has a positive correlation, resulting in an increase of viewers taking the time to actually click the subscribe button. This is a rather obvious correlation, but hopefully the example helps in your understanding of the topic and gets you to finally subscribe. Once data correlations have been identified and analysis is complete, the next step is to present that data in a way that is both human-readable and useful for decision-making. This is where meaningful reporting comes into play. Reports often include visual tools like charts, graphs, and dashboards, as well as search and query functions to help users dig deeper into the data. These tools turn complex data into clear, visual summaries. One of the most important applications of business data is to support leadership decision-making. Senior leaders rely on these reports to understand current trends, measure performance, and plan for the future. By presenting the right data in the right format, organizations empower decision-makers to take informed action. Whether it's tracking sales performance, identifying operational inefficiencies, or forecasting future growth, creating reports from data is one of the most valuable ways a business can turn raw information into strategic insight. Exam Objective 5.1. Explain the value of data and information. Data monetization. Data monetization is the process of turning data into financial value. In other words, it's how organizations use data to either generate revenue or reduce costs. Monetization can take many forms. In some cases, companies choose to directly sell data, such as customer contact lists or usage patterns. For example, a company might sell customer email addresses to product vendors who are looking to promote their services. While this practice can raise ethical and privacy concerns if not handled carefully, it is still a common method of extracting financial value from collected data. However, most companies monetize data indirectly. Instead of selling the data itself, they use it internally to improve operations, develop new products, enhance customer experiences, or make strategic business decisions. A streaming service might use viewer data to recommend shows and reduce cancellations. A retailer might use sales history to deliver personalized discounts that increase purchases. In these cases, the data is generating revenue, not through sale, but through smart application. Some organizations also license or share data with partners. For instance, a logistics company might share delivery and route data with third-party services to optimize route planning. The bottom line is this. Data has value, and when used strategically, whether through internal insights or external partnerships, it becomes a revenue-generating asset. Exam Objective 5.1. Explain the value of data and information. Data analytics. Data analytics is the process of examining raw data to discover useful patterns, trends, and insights. The goal is to extract meaning from the data, turning numbers and records into actionable knowledge. So, what kinds of questions can data analytics help us answer? It might tell us which products are performing the best. It might predict what a customer is likely to buy next. It might even show us where a company can cut costs without sacrificing quality. By spotting these patterns, organizations can make smarter decisions, improve performance, and stay ahead of future challenges. Now that we've seen how data analytics help answer important questions, let's take things a step further. There isn't just one kind of data analytics. In fact, there are several types, and each one serves a different purpose, depending on what the organization needs to figure out or predict. Descriptive analytics looks at historical data to explain what has already happened. Diagnostic analytics digs deeper to explain why it happened. Predictive analytics uses past trends to forecast future outcomes. And prescriptive analytics goes a step further, offering suggestions or strategies based on those predictions. Chances are, you've seen all of these in action, even if you didn't realize it. Ever had an online store recommend something you're probably going to buy? That's predictive analytics. Or seen a list of the top watched shows on your streaming service? That's descriptive analytics at work. And that's the real power of analytics. It turns raw data into smarter decisions. It helps businesses move faster and with more confidence, because they're making choices based on data, not just gut feelings. Coming up next, we'll talk about what happens when data becomes too big for traditional tools to handle. That's where big data comes in. Exam Objective 5.1. Explain the value of data and information. Big data. By now, you've seen how data analytics can reveal trends, answer questions, and support smarter decisions. But what happens when the data itself grows so large and complex that traditional tools can't manage it? That's when we enter the world of big data. Big data refers to data sets that are so large, fast-moving, or diverse that they require special tools and techniques to store, process, and analyze it. It's not just about having a lot of data, it's about handling data that grows quickly and comes in all shapes and sizes. To really understand big data, we often break it down into 5 key characteristics. These are known as the 5 V's. First up is volume. This refers to the massive amount of data being collected. We're talking terabytes, or even petabytes, from sources like social media, sensors, or online transactions. Next is velocity, the speed at which data is being generated and needs to be processed. Think about real-time updates like stock prices, live sports scores, or streaming activity. Then there's variety. Big data comes in many different forms. It's not just neatly organized tables. It also includes text, videos, audio files, images, weblogs, and data from smart devices or IoT sensors. Veracity is all about trust. If the data is messy, outdated, or inaccurate, it can lead to bad decisions. So, making sure your data is clean and reliable is essential. And finally, we have value, arguably the most important one. It's not enough to just collect tons of data. That data has to be used in a way that delivers real insights and drives better outcomes. Otherwise, it's just digital clutter. Now, because big data is so large and complex, it often requires networks of computers working together and powerful tools to process and analyze it effectively. Fortunately, with the right setup, even the biggest data challenges become manageable. Exam Objective 5.2. Explain database concepts and the purpose of a database. Using a database. Databases have become an integral part of our modern world, permeating virtually every aspect of our lives. From the moment we wake up to the time we go to sleep, databases are at work. In the realm of technology, they power the applications on our smartphones, storing contacts, messages, and app data. Online shopping relies on databases to manage product information, inventory, and customer accounts. Even social media platforms utilize databases to store user profiles, posts, and interactions. In essence, databases are the unsung heroes of the digital age, silently and seamlessly managing vast amounts of information, making our modern world more efficient and interconnected than ever before. So what is a database? A database is a structured collection of organized data that is stored and managed in a way that allows for efficient retrieval, modification, and analysis of information. If you are still a bit fuzzy with this idea, think of it as a digital filing cabinet, providing a centralized place to store and manage information. Creating a database is like setting up a brand new filing cabinet. You give it a name, define what information the database will store, where it will be stored, and how the information will be accessed. And just like that, voila, it's ready to store your data. Once you have created a new database, it will be empty. Now you will need to populate the new database with data records. Data records can be input manually or imported from another source. Whether you input records manually or import them from another source, this is just like placing documents into your filing cabinet. Now that we have all these records that have been placed into our database, what then? Well, we could query the database. A query is a question or request for specific information from a database and is the way in which we retrieve data stored in the database. Imagine a database that stores student records. Now think of a query as having a magical conversation with your database. You can ask it all sorts of questions, like who has the highest grade, or how many students scored above 90. The database, with its lightning-fast search and retrieval abilities, will provide you with the exact answers you're looking for, helping you make informed decisions and gain valuable insights from your data. Lastly, reporting is about creating organized, visual summaries of queried data. Reports play a crucial role in transforming raw data into meaningful, organized, and visually appealing information. Think of reports as the polished presentations of your data, much like the executive summary of a comprehensive document. They are designed to provide a clear, concise, and structured view of the data, making it easier for users to understand and analyze the information at a glance. And that concludes your introduction to databases. From creation to data inputs and imports, queries, and reports. Databases are critical to modern information sharing and storage, and understanding them is a fundamental skill that everyone in the IT field should have. Exam Objective 5.2. Explain database concepts and the purpose of a database. Flat file versus database. Working with data can be accomplished using multiple tools. Small data sets that are shared by one or two users can be managed in text files and/or spreadsheets. These text files and spreadsheets are usually referred to as flat file systems and provide a very simple method of storing data. In a flat file system, data is typically stored in individual tables or files with little to no structured relationships between the data elements. It's important to note that while flat file systems are easy to work with in many scenarios, they may not be suitable for large-scale, complex data management tasks that require advanced data relationships and querying capabilities. In such cases, a database management system would be more appropriate. By using a database in place of a flat file system, you gain several key benefits. The first of which is a database's ability to handle multiple concurrent users. When multiple users or processes attempt to read or write to the same flat file simultaneously without proper coordination, conflicts can occur. These conflicts can result in data corruption, loss, or inconsistencies due to the absence of built-in concurrency controls, locking mechanisms, and transaction management, which are essential features provided by modern databases. By using a database, you will be able to provide simultaneous read and write capabilities to tens, hundreds, or even thousands of users concurrently or at the same time. Using a database also provides scalability. Scalability, in this context, refers to the database's capability to accommodate a growing volume of data, increased user traffic, or additional workloads by efficiently expanding its storage capacity and compute resources. Another advantage of databases over flat file systems comes in the form of increased speed. Databases are optimized for data retrieval and manipulation. They employ indexing, caching, query optimization, and other performance-enhancing techniques to efficiently store, sort, and retrieve large quantities of data quickly. And as a final benefit, databases can handle a wide range of data types. Flat file systems are typically limited to text data, while databases can handle a wide variety of data types, including text, numbers, dates, images, audio, video, and more. In summary, databases are a superior choice over flat file systems in scenarios where you need to accommodate multiple concurrent users, achieve scalability for growing data needs, ensure fast and efficient data access, and work with a variety of data types. Exam Objective 5.2. Explain database concepts and the purpose of a database. Records and storage. Records are a fundamental component of databases because they serve as the building blocks for organizing, storing, and managing data efficiently. Databases are designed to store vast amounts of information in a structured and organized manner, and records are the means by which this data is logically grouped and categorized. So if I was to define what a database record is, I would have to say they are collections of related data fields that represent a single unit of information or entity within a database. It is often used to store and retrieve specific information about an object or item. In a human resources database, an employee record might include fields such as the employee ID, employee's name, job title, salary, or any other necessary information pertaining to each employee. Each record would therefore represent a unique employee within the organization. Now it should go without saying, but the storage of all these records needs to be persistent. The persistent storage of a database refers to the long-term retention of data within a database management system even when the system is not actively running or powered on. This is a crucial aspect of databases because it ensures that data remains available and durable, even in the face of system failures, power outages, or shutdowns. To accomplish this, databases are typically stored on various types of storage media, which can include hard disk drives, HDDs, solid-state drives, SSDs, network-attached storage, or cloud-based storage solutions. To summarize, database records are fundamental for efficiently organizing and categorizing data in databases. Persistent storage ensures data availability and durability and is achieved through various storage media options, some of which will be covered in the next video segment. Exam Objective 5.2. Explain database concepts and the purpose of a database. Data availability. In the world of information technology, data availability refers to how easily and reliably users can access the data they need when they need it. This is especially important in business settings where lost access could mean missed opportunities, unhappy customers, or even financial losses. Now, when we talk about where data is stored and accessed from, there are two big categories to consider. These are local storage and cloud storage. Local storage means the data is saved on a device you own or control, like a desktop computer, an on-site server, or a laptop. One benefit of local storage is that it doesn't depend on an internet connection. If the device is powered on and working, the data is there, ready to go. This is what we call offline availability. Even if the network goes down, a user may still be able to open a spreadsheet, look at a report, or access a database stored on the same machine. But local storage comes with limits. If a user is away from their office or the computer crashes, they may not be able to get to the data at all. That's where cloud storage comes in. Cloud storage means the data lives on remote servers, hosted by cloud providers like Microsoft, Amazon, or Google. The big advantage here is online access from anywhere. As long as the user has internet access and the proper permissions, they can reach the data from home, on the go, or from different offices across the globe. The trade-off is that cloud storage typically requires a reliable internet connection. If that connection goes down, access to the data might be interrupted. So while cloud storage gives us excellent availability across locations, it's tied to being online. Exam Objective 5.3. Compare and contrast various database structures. Database structure types. Database structures are fundamental to databases in that they help organize and store data efficiently. They play a crucial role in how data is stored, accessed, and manipulated within a database system. Let's explore three main types of data structures in the context of databases: structured, unstructured, and semi-structured data. Structured data refers to data that is highly organized. Each piece of data has a well-defined data type and is organized into tables, making it easy to query and analyze. Unstructured data lacks a predefined structure or format. It includes text, images, videos, audio, and other forms of content that do not fit neatly into a table format. Now, semi-structured data is data that doesn't adhere to organized tables, but is not completely unstructured either. This includes data such as text, images, videos, and audio that is accompanied with various meta tags. Meta tags categorize or label data elements. These tags can be used to indicate the data's purpose, source, or any other relevant information. These meta tags help in organizing and querying semi-structured data efficiently. Between these different database structure types, there is a distinct trade-off between data retrieval speeds, when performing a query, and the rigidity or flexibility in the types of data that can be stored. Structured data typically allows for faster data retrieval speeds because fixed tables enable a database system to know the exact structure of the data. Unstructured data often has the slowest data retrieval speeds. Since there is no predefined structure, searching for specific information requires more extensive processing. As for semi-structured data, this type falls in the middle and offers a more balanced solution. In the next video, we will take a closer look at relational databases, which are a perfect example of structured data. Exam Objective 5.3. Compare and contrast various database structures. Relational databases. A relational database is a structured data system that stores information in tables. A table is comprised of data values stored in a series of columns and rows, where columns align data values vertically and rows align data values horizontally. Using this table structure, each row represents a separate record and each column represents a single field or attribute within a record. Through this table-based structure, we can use fields to compare common traits between data elements in each record. Now that we have defined a table, let's talk about the relational part of this database. A relational database is aptly named because it organizes data into tables that relate to each other. These tables have relationships or links between pieces of information, thus allowing multiple tables to correlate data. So how are these table relationships formed? In the example behind me, we have a customer table, where we can store information about customers, like their first name, last name, and phone number. This table helps us keep all our customer information organized. Now, let's talk about the sales table. Here, we record details about each sale, like who made the purchase, the order number, date of purchase, and the amount. This table helps us track all our sales transactions. So here is our challenge. We want to connect these tables to understand which customer made each purchase. That is where keys will come into play. The customer table has something called a primary key. Think of it as a unique ID for each customer. It's like assigning a customer number to each person. This unique number ensures that every customer record in the customer table has their distinct identity and cannot be confused with any other record. In a relational database, you will find that every table has a primary key. Now, in the sales table, we have something called a foreign key. This is a special kind of key that connects or refers back to the unique identifier in the customer table. This customer table can also be called the parent table in this type of relationship. For our example, the foreign key helps us link each sale to a specific customer in the customer table. When we connect the primary key in the customer table to the foreign key in the sales table, we create a relationship between the two tables. Now, we can easily see which customer made each purchase. So, in a nutshell, a primary key is like a unique ID for each customer in our customer table, and the foreign key is used in the sales table to link each sale to a specific customer. Great, you now know how a relational database works at a fundamental level. Next, we will take a step back and look at the overall blueprint for a relational database, referred to as the schema. A database schema is an outline or a blueprint for a database that describes its components and how they work. And a database schema is a critical part of a relational database as it will include items such as table names, fields in each table, the required data type for each field, and the primary keys, foreign keys, and any other data constraints. Wait, why is constraints in red? Because I have not covered this topic yet. But don't worry, I will cover it right now. So, what exactly are constraints in the world of databases? Constraints are rules or conditions that we set for the data in our database. Think of them as the guardians of data integrity, ensuring only valid values are entered. There are several types of constraints, and each serves a specific purpose. For starters, you already know one type of constraint. The primary key we just learned about is a uniqueness constraint. A uniqueness constraint ensures that values in a column are unique across all records in the table. Then we have the not null constraint. It's a rule that says a column must always have a value, it can't be left empty. You have no doubt come across this constraint when filling out a web form. There is also the check constraint. This enforces specific conditions on column values. For instance, you can use it to make sure an entry meets a specific requirement before it is accepted into the database. Now these are just a few types of constraints, but hopefully you got the idea. And not just about constraints, but relational databases as a whole. And remember, when you need to store information in a structured manner, there is nothing better than a relational database. Exam Objective 5.3, Compare and contrast various database structures. Non-relational databases. A relational database is a structured data system that stores information using tables. So a non-relational database is definitely not that. Instead, non-relational databases use a storage model that is optimized for the specific requirements of the type of data being stored. You may also see these types of databases referred to as NoSQL or non-SQL databases, as they do not use the standard query language used in relational databases. To keep in step with the CompTIA exam objectives, I will present two different non-relational database types. The first of which is a key-value database. This works very much like how it sounds. You store objects based on a unique key and each key points to a specific item or value. Key-value databases are fantastic for scenarios where you need fast, direct access to data. In web applications, this type of database could be used for caching, session management, or user profiles. The second type of non-relational database that we will cover is the document database. A document database works just like the file system on your computer and is excellent for situations where your data doesn't fit neatly into tables or rows, like a blog entry or social media post. If your data is comprised of text files, audio, images, or videos, then a document database may be your best bet. I hope you enjoyed your brief introduction to non-relational databases, specifically key-value and document databases. Exam Objective 5.4, Explain basic data backup concepts. Let's start with a situation no one wants to experience. Imagine all your important files suddenly disappear. Your photos, your documents, your critical business records, your entire database, gone in an instant. That's why backups are so important. A backup is your digital safety net. It's a way to protect the data you care about and ensure that, even if something goes wrong, you have a way to get it all back. Think of it as a kind of insurance policy for your data. Now, what types of data should you back up? That depends on your needs, but there are some common categories. File backups are the most basic. These include specific documents, photos, or folders that you choose to protect. Critical data refers to files that are essential to your work or personal life, like financial records or business documents, where loss could cause real damage. If you're working with applications that store information about users or customers, you'll also want to back up the entire database. And then there's the system backup. This creates a full snapshot of your entire system, including the operating system, settings, applications, and files. It allows for a complete restore if your computer ever fails entirely. Backing up is only half the process. You also need to be able to restore your data. Restoring means taking a backup and using it to recover lost or damaged files, or even rebuild an entire system. In some cases, restoring data also involves importing it into an application or database. The import process allows you to bring data back into a system in a usable format. On the flip side, the export process is often used to create the backup in the first place. Exporting data means taking information from a program or database and saving it in a format that can be stored or moved elsewhere for safekeeping. Together, backing up, exporting, importing, and restoring form a complete data protection cycle. Now let's talk about where backups are stored. There are two main categories: local storage and cloud storage. Local storage means saving your backup to a physical device you own or control, such as a flash drive, an external hard drive, or an SD card. These backups are usually quick to access and don't require an internet connection. That's what we call offline availability. But if the device is damaged or lost, the backup goes with it. Cloud storage, on the other hand, keeps your backups on remote servers provided by companies like Microsoft, Amazon, or Google. The big advantage here is access. With an internet connection and the right permissions, you can get to your data from anywhere, whether you're at home, at work, or traveling. The downside is that if your internet goes down, you might temporarily lose access to your data. Many people use a combination of both local and cloud backups to cover all their bases. Local backups offer speed and offline access. Cloud backups provide convenience and protection against local device failure. Together, they form a strong, flexible backup strategy. Exam Objective 6.1 – Explain fundamental security concepts and frameworks. CIA. To begin our study of Domain 6.0 of the CompTIA Tech Plus exam objectives, we will discuss the CIA triad. And before your mind wanders, the CIA triad is not about secret agents, it's about the core principles of information security, which are confidentiality, integrity, and availability. These principles work together to protect and manage data in the world of IT. The first pillar of the CIA triad is confidentiality. It ensures that data is kept private and only accessible to authorized users. Confidentiality employs measures such as encryption and access controls. The second pillar is integrity. This ensures the accuracy and trustworthiness of data. Imagine you're writing a letter. Integrity ensures that the letter remains unchanged from when you wrote it to when the recipient reads it. Security techniques that prevent any unauthorized alterations or alert us to potential tampering would fall into this category. The third pillar is availability. Availability ensures that data is accessible when needed. Or you can think of it as the ability of an IT system to be up and running without interruption. By understanding the three parts of the CIA triad, confidentiality, integrity, and availability, you can begin to select security controls that will keep your data secret, make sure your data can be trusted, and is accessible when needed. Exam Objective 6.1 – Explain fundamental security concepts and frameworks. Expectation of privacy. Over time, as society immerses itself deeper into the world of technology for communication, work, and leisure, it has become imperative to discern how private our digital interactions truly are. Social networking sites have become an integral part of our daily lives. Most of these platforms offer settings that allow users to toggle between public and private profiles. However, a key point to remember is that even with the strictest privacy settings, the information you share might still be accessible to the platform's staff, advertisers, or third-party applications. Furthermore, these platforms are notorious for collecting vast amounts of user data, like a user's physical location or search history, which can be utilized for targeted advertising or analytics. A logical takeaway here is to always exercise caution with what you share and to familiarize yourself with the platform's privacy policies. Email, another primary mode of communication, varies in terms of privacy. While some email services champion end-to-end encryption, ensuring that only the sender and recipient can decode the content, not all providers offer this level of security. It's also worth noting that many email providers, or employers, might scan your emails. And in certain circumstances, if legally subpoenaed, they might even have to furnish your email content to authorities. The best practice here is to assume what you send could become public and to be circumspect about transmitting sensitive information via email. File sharing, whether through public platforms, cloud storage, or on-premises file servers, poses its own set of privacy challenges. On public sharing platforms, activities such as downloading or uploading a file might expose your IP address to other users. As for cloud storage services, while incredibly convenient, may provide third-party limited access to the files that their users upload. These files can then be analyzed for various purposes, including advertising, or handed over to legal entities if required. Not to mention, file sharing is meant for sharing between multiple users or devices by nature. So if you want the highest expectation of privacy, you might want to keep that secret document off the server and choose to store it locally instead. Instant messaging, another staple in our daily communication, has its nuances when it comes to privacy too. Many contemporary messaging apps boast end-to-end encryption, ensuring the sanctity of the conversation between the sender and recipient. However, some residual data, like timestamps or participant details, might still be stored. Additionally, even if a message is purged, it could linger in backups. Some platforms also facilitate message backups on third-party cloud services, which might lack encryption. The golden rule for users is to choose messaging platforms renowned for robust encryption and privacy features and to think twice before sharing sensitive details, even in seemingly private chats. All things considered, keep your eyes peeled and your wits about you. Remember, expecting privacy is a bit like expecting a cat to obey you. Hopeful, but not always realistic. Exam Objective 6.1 Explain fundamental security concepts and frameworks. Personal privacy considerations. In this video segment, we're focusing on personal privacy considerations, a critical part of working in any digital environment. In the world of IT, personal privacy means protecting information that can be linked to a specific individual. Whether it's stored on a device or transmitted over a network, this kind of information needs to be handled with care to prevent misuse, identity theft, or legal violations. One of the most common types of sensitive data is something called personally identifiable information, or PII. This includes any information that can be used to identify an individual. Examples include your full name, address, email, phone number, date of birth, and even things like your social security number. Because PII is often tied to a person's identity, it's usually protected by strict privacy laws. Mishandling this kind of data can lead to serious consequences for both individuals and organizations. Another type of sensitive information is protected health information, or PHI. This includes medical records, treatment histories, lab results, or anything related to a person's health that can be traced back to them. PHI is often stored by healthcare providers, insurance companies, and billing services, and it's governed by regulations that are even stricter than those for general PII. If you work with health-related data in IT, protecting PHI isn't just best practice, it's required by law. Now let's zoom out and talk about international privacy regulations, starting with the General Data Protection Regulation, or GDPR. This is a major privacy law passed by the European Union, and it affects any company, no matter where it's based, that collects or processes data from people in the EU. GDPR requires organizations to get clear consent before collecting personal data, and it gives users the right to access, correct, or delete their information. It also places strict rules around how data is stored and shared. Even if you're working in the US, if your company has EU customers or users, GDPR still applies. One of the most visible examples of GDPR compliance shows up in something we all see every day: cookie consent banners. Cookies are small pieces of data that websites store on your device. Some are essential. For example, they keep you logged in. Others are used for tracking behavior, advertising, or analytics. Under laws like GDPR, websites must let users know what cookies are being used and get their consent before storing any that are not essential. That is why you often see a pop-up asking if you accept all cookies when you visit a new site. To wrap things up, protecting personal information in IT means more than just following rules. It's about respecting users' privacy, securing sensitive data, and creating systems that are both safe and transparent. Whether you're storing a customer's name, handling patient records, or designing a website that uses cookies, every decision you make matters when it comes to personal privacy. Exam Objective 6.1 Explain fundamental security concepts and frameworks. AAA. In this video, I will break down the concept of AAA into its three core components: authentication, authorization, and accounting. But, before I define these three components, I want to talk about AAA as it relates to the previously discussed topic of CIA. In the realm of information technology, both AAA and CIA are foundational concepts, but they focus on different aspects of security. While CIA is all about the data, AAA is centered around the user. AAA, as a user-centric approach to security, ensures that the right individuals have the right access at the right times. On the other hand, CIA is data-centric. It ensures that data remains private, accurate, and is accessible when needed. In essence, while AAA focuses on verifying and managing user identities and their actions, CIA is dedicated to safeguarding the data itself. Hopefully this little explanation keeps you from getting these two concepts mixed up. Next, I will define each component of the AAA concept, starting with authentication. Imagine you're trying to log into your computer. The system asks for your username and password. Why? It wants to verify that you are who you claim to be. In IT terms, this process is called authentication. It's the act of confirming the truth of an attribute of a single piece of data or entity. In simpler words, it's like asking, "Who are you?" Next, we have authorization. Let's say you've entered a building using a key. However, this doesn't mean you can access every room inside. Some rooms might require a different key. Similarly, in IT, once you're authenticated, it doesn't mean you can access everything. Authorization determines what you can or cannot do. Lastly, there's accounting. In the IT world, this doesn't refer to crunching numbers or balancing the books. Instead, it's about tracking user activities and recording them. Think of it as a logbook or computer record that notes every action you take as a user, answering the question, "What did you do?" Together, the three pillars of authentication, authorization, and accounting make up the AAA security principle in the realm of information technology. Authentication verifies a user's identity, ensuring that individuals are genuinely who they claim to be. Once their identity is confirmed, authorization steps in to determine what actions or resources the user is permitted to access, ensuring that they only interact with what they're allowed to. Lastly, accounting meticulously tracks and records all user activities, providing a comprehensive log that can be reviewed for security, compliance, or audit purposes. Collectively, these components not only bolster security but also streamline user management and oversight in IT systems. Exam Objective 6.1 Explain fundamental security concepts and frameworks. Authentication. Imagine you're trying to log into your computer. The system asks for your username and password. Why? It wants to verify that you are who you claim to be. In IT terms, this process is called authentication. At its core, authentication answers the question, "Who are you?" ensuring that only authorized individuals can access certain information or systems. Now, how do systems authenticate you? They use something called an authentication factor. An authentication factor is a distinct method used to verify a user's identity before granting access to a system or resource. It represents a specific piece of evidence that the user must provide, falling into categories such as something you know, something you have, something you are, and somewhere you are. Now let's take a closer look at each of these categories. First, we will discuss something you know. This is the most common factor. Think of passwords, PINs, or answers to security questions. It's information that resides in your mind and is known, hopefully, only to you. As for a password, it is a secret combination of characters that a user sets to prove their identity and gain access to digital accounts or systems. A PIN, or personal identification number, is a numeric code used to authenticate a user, commonly associated with bank accounts or mobile devices. It is typically shorter than a password but serves a similar purpose in verifying identity. Security questions are preset queries that a user answers during account setup, providing an additional layer of identity verification. Falling under the something you know category, they act as a backup for authentication, especially in scenarios where a password or PIN is forgotten. Our next authentication factor is something you have. This category refers to tangible objects or devices in the possession of a user that serves as a means of authentication. This category emphasizes the physical possession of an item as proof of identity. Examples include a hardware token, which is a physical device, often small enough to be carried on a keychain, and can generate and display secure codes for authentication. A software token, which is a digital counterpart to the hardware token, existing as an application or software module on devices like smartphones or computers. It also generates and displays secure codes for authentication, but only to users with the required software access. One-time passwords, also referred to as OTPs, are unique, time-sensitive codes sent to a user's device, often via SMS text or email, for a single-use authentication. Continuing on, we have the something you are authentication factor. This factor is about unique characteristics inherent to the user, or you may have heard the more common term, biometric data. Biometrics can include many user characteristics, but for the purpose of brevity, I will stick to a few of the more common biological metrics. Fingerprints are unique patterns formed by ridges on the tips of human fingers, and when used for authentication, they validate identity based on these distinct patterns. The iris and retina are parts of the eye with intricate patterns that are unique to each individual. As facets of the something you are category, iris and retina scans provide biometric authentication by analyzing these patterns, ensuring a high level of security due to their distinctiveness. Facial recognition technology analyzes distinct features of an individual's face, such as the distance between eyes or the shape of the nose, to authenticate identity. Facial authentication leverages the uniqueness of one's facial structure to grant or deny access to systems or resources. Now for one last factor. Somewhere you are. This authentication factor is based on the geographical or physical location of the user. By determining where you are, systems can grant or restrict access based on whether the user is logging in from a recognized or safe location. Examples include geofencing, where access is only allowed from specific geographic regions, or IP address checks that verify if a user is connecting from a known network or country. This factor adds an extra layer of security by ensuring that even if someone has your authentication details, they might be prevented from accessing resources if they're not in an approved location. Exam Objective 6.1 Explain fundamental security concepts and frameworks. Single factor versus multi-factor. When accessing digital systems, we often encounter prompts asking for credentials. Using just one authentication factor, like a password, to verify your identity is known as single-factor authentication. This straightforward process, often abbreviated as SFA, verifies your identity using only one piece of evidence. However, as our security needs have evolved, so have our authentication methods. Enter multi-factor authentication, or MFA. This method requires two or more pieces of evidence conforming to multiple authentication factors in order to verify your identity. MFA can involve a combination of elements, something you know, like a password, something you have, such as a mobile device receiving a code, something you are, like a fingerprint or facial scan, and somewhere you are. This layered approach to authentication significantly enhances security by ensuring that even if one factor is compromised, there are additional barriers to unauthorized access. Now, if that was not enough, you are also likely to come across the concept of two-factor authentication in your IT journey. Two-factor authentication is often referred to as 2FA, and is a specific form of MFA that uses exactly two authentication factors to verify your identity. It strikes a balance between enhanced security and user convenience, often combining a password with a mobile code or another easily accessible method. In the realm of IT, understanding the distinctions between single-factor, two-factor, and multi-factor authentication is essential. As you prepare for your CompTIA Tech Plus certification exam, remember that the choice of authentication method can greatly impact the security of systems and data. Now let's practice this concept to ensure you are exam ready. To do this, I will present a few authentication scenarios where two authentication elements are used. We will then classify each authentication element according to its authentication factor type and then see if a single factor or multiple factors were used overall. With that explained, here is the first authentication scenario. The user has provided a username, which is something you know, and a complex password, which is also something you know. As both authentication methods are something you know factors, this would be considered single-factor authentication or SFA. Authentication scenario number 2. The user has provided a smart card, which is a form of a hardware token. This falls into the something you have category. The user has also provided a PIN number, which is something you know. In this scenario, we have multiple authentication methods being utilized, so this would be considered multi-factor authentication or MFA. Okay, don't beg. I will do one more scenario, just for you. Authentication scenario number 3. In this last scenario, the user is subject to geolocation. This falls into the somewhere you are category. The user must also provide a retina scan, which is something you are. In this scenario, we have multiple authentication methods being utilized, so this would be considered multi-factor authentication or MFA. Great. Now you are a certified SFA, 2FA, and MFA master. Exam Objective 6.1, Explain fundamental security concepts and frameworks. Single sign-on. How often do you find yourself juggling multiple accounts, each with its own unique username and password? This can become cumbersome and challenging to manage. That is where single sign-on comes in. Single sign-on, commonly referred to as SSO, is a user authentication service that permits a user to use one set of login credentials, like a username and password, to access multiple applications. Think of it as a master key that unlocks several doors, eliminating the need to have multiple keys for each door. So, how does single sign-on work? Well, when you first log into an application that uses single sign-on or SSO, the system checks if you've been authenticated by the central SSO solution. If you haven't, it prompts you to log in. Once you provide your credentials, the SSO system validates them against a central database. Upon successful validation, the SSO system issues a token, a kind of digital stamp of approval. This token is then used for subsequent authentication requests during that session. As you navigate to another integrated application, instead of asking for your credentials again, the system requests the SSO solution to verify the token's validity. If the token is recognized and still valid, the second application grants you access without requiring another login. This process of token verification repeats for all integrated applications, ensuring a smooth and uninterrupted user experience. Now that makes things much easier, doesn't it? Now, behind the scenes, the SSO solution and the applications communicate using special protocols. These protocols define how the applications request authentication and how the SSO solution responds with the user's authentication status. But what happens when you log out or when the session expires? Simple, the token becomes invalid. As a result, the next time you try to access an application, you'll be prompted to authenticate again, and a new token will be issued for that session. Incorporating single sign-on not only streamlines the user's experience but also consolidates the authentication process for IT administrators. They can monitor user activities, manage permissions, and enforce security policies, all from a centralized location. Exam Objective 6.1, Explain fundamental security concepts and frameworks. Authorization. In the world of information technology, having access to a system is only part of the story. What really matters is what you're allowed to do once you're in. This concept is known as authorization. Authorization determines what actions, resources, or services a user is permitted to access. Or more simply, it answers the question, what can you do? That leads us to permissions. Once you're logged into a system, permissions define the specific rights or privileges granted to users or software. These are the detailed rules that decide what you can and cannot do. For example, you might be allowed to read a file but not modify it, or access a database without being able to change any records. Permissions are what give structure and control to a user's role in a system. Now, managing those permissions correctly brings us to one of the most important security practices in IT, the principle of least privilege. This means giving users or systems only the permissions they absolutely need to perform a task or job function and nothing more. If someone just needs to print a document, they don't need full access to the print server's configuration. The more precisely we limit access, the better we protect the system from mistakes or malicious activity. Understanding least privilege also means understanding the types of user accounts. Most users operate under a standard account. This is ideal for daily tasks like browsing the internet, running applications, and working with personal files. But standard accounts can't install software or make major changes to the system, which helps reduce the risk of accidental or unauthorized modifications. Then there's the administrator account. This is the high-level account with full control over the system. Admins can install programs, change system settings, and manage other user accounts. While powerful, this level of access should be restricted to only a few users. Following the least privilege model, it's best to reserve admin rights for specific tasks and stick to a standard account for everything else. To help enforce these boundaries, Windows includes a built-in feature called User Account Control, or UAC. UAC adds an extra layer of protection by prompting the user anytime a program tries to make system-level changes. Even administrators see this prompt. It's a simple but effective checkpoint that asks, "Did you mean to make this change?" If not, it could be malware or an unauthorized action trying to sneak in. In this way, UAC acts as your last line of defense, preventing unwanted or accidental changes before they can take effect. When combined with thoughtful use of user accounts, permissions, and the least privilege model, it helps create a more secure and stable IT environment. Exam Objective 6.1 Explain fundamental security concepts and frameworks. Accounting. At its core, accounting is the process of recording, summarizing, and analyzing financial transactions, ensuring that records of individual financial transactions are accurate and up-to-date. This meticulous process has been the backbone of businesses for centuries, helping them understand their financial health and make informed decisions. But in the rapidly evolving world of IT security, accounting takes on an additional meaning. Here, it doesn't just deal with dollars and cents. It refers to the tracking of user activity and system events. Just as financial accounting keeps track of money, IT accounting keeps track of data and user actions, and answers the pivotal question, what did you do? One of the primary tools used in IT accounting are logs. Think of logs as the digital footprints left behind in a system. These footprints, or logs, are records that provide a chronological account of events in a system. They can track a wide range of activities, from user logins, file accesses, to even the smallest system errors and security breaches. The importance of logs cannot be overstated. They are the silent guardians of the digital world. They assist system administrators in diagnosing problems, almost like a doctor referring to a patient's history. They provide a clear, traceable trail for auditors to ensure compliance with digital policies. And perhaps most importantly, they can be instrumental in detecting unauthorized or potentially malicious activity. By answering the questions of who, what, when, and where, logs provide a comprehensive view of system activities. Building on that idea of where, another vital component of IT accounting is location tracking. Modern devices and applications often include location services that can pinpoint where a device, or the person using it, is located. This kind of data is typically gathered through GPS, Wi-Fi signals, IP address mapping, or even Bluetooth beacons. Location tracking serves many purposes. It can enhance user experiences by delivering location-based services or content. For system administrators, it can help identify suspicious behavior, like a login attempt from a different country that doesn't match a user's normal pattern. In enterprise settings, it can be used to enforce policies, for example, restricting access to sensitive systems based on physical location. While location tracking can raise privacy concerns, when used responsibly, it becomes another powerful tool for accountability, security, and system integrity. That brings us to web browser history. Let's take a moment to think about this familiar feature. Your browser history not only lets you revisit previously accessed sites, it also serves as a detailed record of your online journey. For individual users, it's helpful for remembering where you've been. But for organizations, monitoring browser activity plays a much larger role. It helps ensure employees adhere to company policies. It helps block access to malicious or inappropriate sites. And in the context of cybersecurity, web history can become a crucial clue when piecing together how an attack may have started. Like logs and location data, browser history contributes to the bigger picture of user activity. Now, it's easy to perceive IT accounting as a form of digital surveillance, and to some extent, that's a fair concern. But it's important to view it through a wider lens. IT accounting isn't just about monitoring. It's about building a secure, transparent, and accountable environment where people, data, and systems are protected. It helps ensure that everyone is playing by the rules, and that the integrity of the digital space is preserved. In a world where trust is often hard to come by, IT accounting helps earn it, one log, one location, and one browser click at a time. Exam Objective 6.2, Explain methods to secure devices and security best practices. Security awareness. Are you good at getting people to do what you want? If so, you might be a natural at something called social engineering. In the world of information technology, social engineering is the act of manipulating individuals into revealing confidential information or performing actions that compromise security. It often involves exploiting human trust, curiosity, or urgency to gain access to systems or data. Or, as I like to call it, hacking the human. And make no mistake, all the firewalls, encryption, and multi-factor authentication in the world can't protect you if you're tricked into handing over the keys yourself. Now, one of the most common forms of social engineering is phishing. Phishing is where an attacker sends fraudulent communications, typically via email, that appear to come from a legitimate source, maybe your bank, your boss, or even your favorite online store, all with the hope of reeling in your personal info. For example, you might get an email saying, "Urgent, your account has been compromised. Click here to reset your password." Spoiler alert, that link leads straight to a hacker's website. So how do you fight back? To start, try using a spam filter. A spam filter is like posting a bouncer at the door of your inbox, keeping shady messages out. Also, knowing how to spot red flags, like misspelled URLs or sketchy sender addresses, can stop a scam before it starts. Now here's the twist. While stealing your login information is one common goal of phishing attacks, it's not the only one. In many cases, the attacker's true objective is to get you to open or download malicious or compromised content. That might be an attachment pretending to be a receipt or a link that looks like a PDF or a trusted website. But hidden behind that innocent-looking file or link is malware, software designed to damage your system, steal your data, or give attackers remote access to your device. In other words, phishing is just the bait. The real catch is what comes next, be it spyware, ransomware, keyloggers, or worse. That's why it's so important to stay cautious. Never open unexpected attachments. Be skeptical of urgent messages. And always verify the source before you click. Exam Objective 6.2, Explain methods to secure devices and security best practices. Securing devices. Securing devices, like mobile phones, tablets, laptops, and workstations, is a critical part of any overall cybersecurity strategy. These devices store sensitive information, connect to company networks, and are often targeted directly by attackers. Even with strong network defenses in place, a single vulnerable device can still become the entry point for a threat. That's why securing individual endpoints is just as important as protecting the network itself. In this video segment, we'll walk through some of the foundational methods used to secure a device. And a great place to start is with authentication. Every device should require a secure login, as this is your first line of defense against unauthorized access. That means using strong, unique passwords or other methods like PIN numbers and biometrics. Some organizations even add multi-factor authentication, requiring 2 or more authentication factors to be used. Once you've locked down the front door with proper authentication, the next step is protecting the inside of the house. That's where anti-malware software comes in. Next, let's talk about anti-malware protection. Anti-malware software is designed to detect, prevent, and remove malicious software, also called malware, from a device. Its job is to ensure the device's safety and integrity by acting as a barrier against threats like viruses, worms, ransomware, and spyware. There are 2 main methods these tools use to catch malware. The first is signature-based detection. This method scans files and compares them to a database of known malware signatures, like digital fingerprints. It's fast and effective for known threats. The second is behavioral-based detection, also called heuristic analysis. This method monitors how programs behave. If something starts acting suspicious, like trying to access secure files or disable security settings, it's flagged as a potential threat. Most modern anti-malware tools use both methods to stay ahead of attackers. And if malware does sneak onto a device, these tools are often the last line of defense before real damage is done. Now let's move on to the host firewall. A host firewall is software that provides protection to an individual device by monitoring and controlling incoming and outgoing network traffic based on predetermined security rules. Think of it like a personal security guard that checks every data packet before it enters or leaves your system. Host-based firewalls are especially useful when devices are outside the safety of a company network, like when you're working remotely or using public Wi-Fi. These firewalls can block unauthorized connections, filter traffic by port number or protocol, and even alert you when something suspicious is happening. But a word of caution, misconfigured firewall rules can accidentally block legitimate services. For example, if two workstations need to communicate and one of them has a rule that blocks a necessary port, that connection will fail. So always test firewall settings after making changes to ensure that essential access remains intact. Last but not least, we have patching and updates. Software vulnerabilities are discovered all the time, and attackers move quickly to take advantage of them. Installing updates and patches helps to close those gaps. This includes not just the operating system, but also your firewall software, browser, anti-malware programs, and other essential applications. Updates often bring new security features and performance improvements too, making them a quick win for boosting protection. When your device asks to install an update, don't put it off. Every minute you wait could be a minute that a vulnerability remains exposed. Exam Objective 6.2. Explain methods to secure devices and security best practices. Physical device security. When most people think about cybersecurity, they picture firewalls, antivirus software, and complex passwords. But here's the thing. No amount of software protection can help if someone walks off with your device or plugs something malicious into it. That's why physical device security is just as important as digital protection. Physical device security refers to the use of physical tools or restrictions to prevent unauthorized access, theft, or tampering with a device. It's all about protecting the actual hardware, not just the data inside. So what does that look like in practice? Let's start with one of the simplest and most widely used solutions, the cable lock. A cable lock is a physical security device that secures a laptop or desktop to a fixed object, making it harder for someone to walk off with it. Imagine you're working on your laptop at a coffee shop. You step away for a moment to grab another latte, and when you return, your laptop is gone. It only takes a few seconds for a thief to act. A cable lock, which works much like a bicycle lock, physically connects your laptop to something sturdy like a table leg. It may not stop the most determined criminal, but it definitely slows them down and makes the device a less attractive target. Now let's talk about USB locks. A USB lock is a small physical device that blocks access to a USB port, preventing unauthorized devices from being plugged in. USB ports are incredibly useful, but they're also a major security risk. Someone could use a flash drive to upload malware or steal confidential files. With USB locks in place, the ports are physically blocked. It's like putting tiny padlocks on every USB slot. And for added protection, many organizations also disable USB functionality through software settings. But having a physical USB lock means you're not relying on software alone. Exam Objective 6.2. Explain methods to secure devices and security best practices. Software licensing. Think of software licensing as a set of rules and permissions that govern how you can use a piece of software. It's like a digital contract between you and the software creator. These licenses spell out what you can do with the software, whether you're allowed to modify it, how long you can use it, and whether you're permitted to install it on one device or several. To make this next topic easier to visualize, imagine software as a recipe. With open source software, the recipe, or source code, is openly shared with the world. Anyone can view it, change it, and even share their improvements. It's like a community cookbook where everyone is welcome to add their own twist. This approach encourages collaboration, transparency, and faster innovation. Developers from all over the world can contribute fixes, add features, and help improve the software over time. In contrast, proprietary software is more like a secret recipe that only the original creator is allowed to see. The source code is hidden, and users are not permitted to modify or distribute the software. When you use proprietary software, you're not buying the program itself, you're purchasing a license to use it under specific terms set by the developer or company. These terms often include restrictions on copying, sharing, or altering the software. While you don't have access to the underlying code, proprietary software is typically maintained by a dedicated development team that handles updates, bug fixes, and technical support. So while open source gives users the freedom to explore and modify, proprietary software offers a more controlled, hands-off experience with formal support and strict usage guidelines. Now let's shift to how software is licensed in terms of payment and usage duration. The two most common models are subscription licensing and one-time purchase. Subscription-based licensing is more like a service. You pay on a regular schedule, such as monthly or annually, and as long as your subscription remains active, you can continue using the software. This model ensures you always have access to the latest features, security updates, and technical support. Subscriptions offer greater flexibility and ongoing improvements, but they also require continuous payments that can add up over time. One-time purchase licensing, on the other hand, means you pay a single upfront fee to own a license for that specific version of the software. Once it's installed, you can use it indefinitely without any additional payments. However, you won't automatically receive future updates or new features unless you choose to purchase a newer version later. This model can be more cost-effective over the long run, especially if you're comfortable sticking with the same version for an extended period. No matter the license type, many software products also require a product key during installation. A product key is a unique combination of letters, numbers, or characters that acts as a form of verification. It ensures that the copy of the software being installed is legitimate and has been properly licensed. This key unlocks full access to the application, confirming that the user has the right to use it. Without a valid key, the software may run in a limited mode or not work at all. Exam Objective 6.2 – Explain methods to secure devices and security best practices. Software sources. When installing software, where it comes from is just as important as what it does. Choosing the right software source can make the difference between running a clean, secure system or accidentally infecting your device with malware. Let's start with how to research and validate legitimate sources. Before downloading any application, it's important to verify that the website or app store is trustworthy. Look for signs like secure website addresses that begin with HTTPS, a professional layout, and contact or support information that actually works. Reviews and user ratings can help too, but be cautious. Fake reviews are common. When in doubt, search for feedback from independent tech communities or forums to see what other users are saying. Next, let's compare OEM websites to third-party websites. An OEM, or original equipment manufacturer, is the company that created the device or software. Downloading drivers, utilities, or updates directly from the OEM's official website is generally the safest choice. These downloads are tested and verified to work with your specific hardware. Third-party websites, however, may host modified or outdated versions of software. Some are legitimate, but others are designed to trick users into downloading malware. Unless you trust the source and have verified its reputation, it's best to avoid third-party download sites altogether. Application stores are another common source, especially on mobile devices. Stores like the Google Play Store or the Apple App Store add an extra layer of security by scanning apps for malicious code before making them available to users. That said, even official app stores are not perfect. Always check reviews, developer information, and requested permissions before installing. Once software is installed, it's also important to know how, and when, to remove it. There are three main categories of software you might need to uninstall. These are unwanted software, unnecessary software, and malicious software. Unwanted software includes programs you didn't intend to install. Maybe they were bundled with something else or came pre-installed on your device. These often slow down your system or show annoying pop-ups. Unnecessary software refers to programs you no longer use. They might not be harmful, but they still take up space and resources. Regularly reviewing and removing unused applications helps improve system performance and reduces clutter. Malicious software, or malware, must be removed immediately. These programs are designed to harm your system, steal data, or compromise security. If you suspect an application is malicious, uninstall it using safe methods and run a full system scan with anti-malware tools. Now let's talk about something serious: software piracy. This is the illegal copying, sharing, or use of software without a proper license. Pirated software is not just unethical, it's dangerous. These unauthorized copies often come bundled with hidden malware, spyware, or backdoors that put your device and data at risk. Plus, pirated programs don't receive updates or support, which leaves security vulnerabilities wide open. Always use legally licensed software from reputable sources to stay safe and stay compliant. To wrap it up, responsible software management starts with choosing trustworthy sources, removing anything that doesn't belong, and staying far away from pirated content. A secure system doesn't just run better, it gives you peace of mind. Exam Objective 6.2 Explain methods to secure devices and security best practices. Website security certificates. To begin this video segment, let's discuss what a website security certificate is. You can think of a certificate as a digital ID card for a website. Just like you need identification to verify who you are, websites need certificates to prove their authenticity and ensure secure communication. Imagine you're about to enter a secure website. Your web browser checks this certificate to confirm the site's identity, like a virtual handshake, before it establishes a secure connection. These certificates are crucial in safeguarding sensitive data, such as personal information or credit card details, from falling into the wrong hands. So how are certificates acquired? Great question. Certificates are issued and managed by trusted third-party entities known as certificate authorities or CAs. These CAs act as digital notaries, verifying the identity and authenticity of the websites. When a website owner wants a certificate, they go through a validation process with the CA. The CA will verify the website owner's identity and domain ownership to ensure they are legitimate. Once the validation is successful, the CA issues a digital certificate containing the website's public encryption key and other essential information. Let's now look at the process step by step. Just keep in mind I will be presenting you with a simplified version of this process that is appropriate for the Tech Plus certification exam. Okay, step 1, the CA issues a certificate to the server. Next, a client will request identification from a server. The server will then send its certificate and a public encryption key. The client will then verify the authenticity of the certificate with the CA. If all goes well, a secure connection will be formed between the client and the server. So that was a little bit of a behind-the-scenes view of certificates. Now I will move to a user's viewpoint. When you access a website using HTTPS in the URL, your web browser recognizes this and checks for a valid certificate. If the certificate is valid and trusted, your browser establishes a secure encrypted connection with the website's server. The lock icon you see in the browser's address bar indicates a secure connection. It means your data, such as login credentials or credit card information, is encrypted while being transmitted, making it extremely difficult for hackers to intercept or decipher. But be careful, not all certificates are trustworthy. Let's talk about valid and invalid certificates. A valid certificate is one that has been issued by a reputable CA and is within its expiration date. On the other hand, an invalid certificate raises a red flag. This could happen if the certificate has expired, the website's domain name doesn't match the certificate, or the certificate was issued by an untrusted or unauthorized CA. When you encounter an invalid certificate, your web browser will display a warning message to protect you from potential security risks. In such cases, it's best to avoid proceeding to the website. Exam Objective 6.3 Explain password best practices. Passwords serve as a primary method of authentication, but surprisingly, many individuals often overlook their significance. Some might attribute this to complacency, while others simply might not be aware of the importance. Fortunately, there are established password policies and best practices that guide users in creating robust passwords, thus ensuring enhanced protection for both personal and professional data in our digital landscape. First and foremost, why are good password practices so essential? Think of passwords as the keys to your digital home. Just as you wouldn't want a flimsy lock on your front door, you wouldn't want a weak password guarding your personal and professional data. Strong password practices ensure that your digital doors remain locked against potential intruders. Now, let's look into some key password policies, which are designed to fortify our digital security. To kick things off, I will start with a well-known policy, the password length policy. This policy is an uncomplicated yet vital aspect of digital security. At its essence, this policy determines the minimum and maximum number of characters that a password should contain. Picture this in terms of a physical safe. Just as a safe might have a combination code of varying lengths, a password has its own length criteria. The analogy runs deeper when you consider the security implications. For a safe, a longer combination, with more numbers or sequences to guess, naturally becomes more challenging for a thief to decipher. Similarly, in the digital realm, a longer password inherently possesses more potential combinations of characters. This increased variability makes it exponentially harder for malicious actors to guess or use brute force attack methods against your password. Then there's the password complexity policy. This policy emphasizes the need for a diverse mix of characters in your password. It recommends using a combination of uppercase letters, lowercase letters, numbers, and special characters. Such a varied composition not only ensures your password's uniqueness but also strengthens its defense against typical hacking methods. A password with this mix is much harder for hackers to guess or breach using brute force techniques. It's also crucial to avoid using dictionary words in your password, regardless of their length. Hackers often use dictionary attacks, where they methodically test every dictionary word to decipher passwords. By incorporating a variety of character types and steering clear of standard dictionary words, you substantially lower the chances of falling victim to these attacks. Next, we have the password history policy. This policy's primary objective is to deter users from reusing their recent passwords. By monitoring and remembering your past passwords, the system can ensure that when you're prompted to update your password, you're guided towards crafting a new and unique one. This proactive approach to password management is designed for mitigating risks. For example, if an old password was ever compromised, ensuring it's not reused eliminates the chance of that particular password being a recurring security weak point. In a nutshell, the password history policy serves as a protective measure, encouraging users to consistently renew their passwords, thereby enhancing their overall digital security. Now, our next policy, the password expiration policy, complements the previously discussed password history policy by setting an expiration date on your passwords, ensuring they don't remain static for too long. By doing so, it mandates users to refresh their passwords at predetermined intervals or on a certain date. Imagine this as a routine maintenance check. Just as machinery or software might need regular updates to function optimally, your passwords require periodic changes to remain effective against potential threats. This consistent cycle of change reduces the window of opportunity for malicious actors to exploit a possibly compromised password. In essence, the password expiration policy acts as a proactive nudge, reminding users to stay vigilant and continually reinforce their digital barriers. And adding one more to our list of essential password policies, let's discuss the password lockout policy. Ever mistyped your password several times and got locked out of your account? That's this policy at work. The primary purpose of the password lockout policy is to hinder unauthorized users from endlessly guessing your password. This previously mentioned attack, known as a brute force attack, is more common than you might think. The policy works very simply. After a set number of incorrect login attempts, the account gets locked. It remains inaccessible for a set period of time or until an admin steps in to unlock it. This strategy not only stops hackers in their tracks but also signals to users and administrators about possible unauthorized access attempts. All these password policies play a role in guiding users to set and maintain secure passwords. However, there are additional practices that further enhance our digital security. Firstly, it's important to avoid using the same password across multiple accounts. This huge mistake is known as password reuse. If you reuse the same password everywhere and it gets compromised, all your accounts become vulnerable. Ensure every account has its own distinct password for optimal protection. For those juggling numerous accounts, a password manager can be a lifesaver. It's challenging to remember countless complex passwords. A password manager acts as a secure digital vault, storing and even autofilling your passwords for you, making sure your credentials are organized, secure, and readily available when needed. Lastly, I have an important note for password administrators. When users need to reset their passwords, always prioritize verifying their identity, using multiple verification methods if possible. After confirming their identity, assist them in the reset process, highlighting the need to establish a strong and unique new password. Exam Objective 6.4 Identify common use cases for encryption. Plain text versus ciphertext. Understanding the distinction between plain text and ciphertext is the very first step when venturing into the expansive realm of encryption and its study, termed cryptography. So let's take that first step and begin with a quick look into plain text. Picture yourself jotting down a message to a friend. This message, in its original, readable form, is what we term as plain text. In the realm of IT, plain text is any data or text that hasn't undergone encryption, making it readable by both humans and computers. But here's where the plot thickens. When we aim to safeguard our data or message, especially in the digital domain, we resort to encryption. This encrypted form of our plain text is what we refer to as ciphertext. Think of ciphertext as a coded message. To the untrained eye, it appears as mere gibberish. This encryption ensures our data's confidentiality, shielding it from unwanted attention. To reiterate and further define this concept, plain text is data presented in a format that is immediately understandable and accessible. It's in its most basic, unaltered state, free from any form of encryption or coding. This means that there are no protective layers or barriers concealing its content. Whether it's a simple message, a document, or any other form of data, if it's in plain text, it retains its original clarity and meaning. Anyone who comes across or accesses this data, be it a human or a computer, can easily read and interpret its contents. In essence, plain text is like an open book, transparent and straightforward, waiting to be read by anyone who stumbles upon it. As for ciphertext, it stands in stark contrast to plain text. It is the result of taking understandable, clear data and transforming it into a format that appears random and nonsensical at first glance. This transformation is achieved through a process called encryption, which employs specific mathematical algorithms to jumble the original data. These algorithms rearrange the data in such a way that its original meaning becomes obscured. The primary purpose of this scrambling is to protect the data's integrity and confidentiality. Without the correct decryption key or method, which acts as a sort of digital password or blueprint to reverse the encryption, the ciphertext remains a puzzling array of characters, numbers, and symbols. Only those possessing the right key can revert the ciphertext back to its original plain text form, making it a perfect mechanism to safeguard sensitive information from unauthorized eyes. In the vast digital landscape, where data breaches and cyber attacks are prevalent, ciphertext serves as a fortified shield, ensuring that even if data is intercepted, it remains indecipherable to those without the means to decrypt it. Exam Objective 6.4 Identify common use cases for encryption. Data at rest. Imagine a calm, serene lake with the sun setting in the background. The stillness of the water is reminiscent of data at rest in the world of information technology. Simply put, data at rest refers to data stored on devices like computers or servers, not actively being used or transmitted. More specifically, it is the files and documents that sit quietly on your hard drive. However, this stillness doesn't guarantee safety. That's where encryption comes in. The first type of data at rest encryption we will discuss is file-level encryption. Additionally referred to as file-based encryption or file folder encryption, this method is distinct in its approach to data protection. Instead of encrypting an entire storage medium or device, file-level encryption zeroes in on individual files or directories, encrypting them directly through the file system. This granularity offers a unique advantage. It provides each user with the autonomy to decide which specific files or folders they wish to encrypt. By allowing each user to encrypt their own files or folders, it ensures that even if someone else has access to the storage medium, they cannot decipher the encrypted content without the appropriate decryption key. Moreover, this method establishes controls against potential misuse by privileged users or system administrators. In many IT environments, administrators have overarching access to systems and data. However, with file-level encryption, even they cannot access the encrypted content without the user's decryption key. This decentralization of encryption power not only enhances data security but also fosters a sense of ownership and responsibility among users regarding their data's safety. While file-level encryption focuses on safeguarding specific files or directories, disk-level encryption takes a more comprehensive approach. Think of disk-level encryption as a protective shield that encompasses the entirety of a storage device, such as a computer's hard drive or an external storage disk. When we talk about protecting everything on your computer, disk-level encryption is the go-to solution. Now, let's delve deeper into a real-world scenario: the theft of a laptop. Laptops, given their portability, are prime targets for theft. When a laptop is stolen, the thief isn't just after the hardware, the real treasure often lies in the data stored within. This could be personal photos, sensitive documents, financial information, or even proprietary business data. Without encryption, a savvy thief could potentially extract this data directly from the hard drive, leading to breaches of privacy or even financial loss. However, with disk-level encryption activated, the entire contents of the hard drive is rendered unreadable without the correct decryption key. Even if the thief removes the hard drive and tries to access it using another device, the data remains encrypted and inaccessible. In short, disk-level encryption transforms your computer into a digital fortress. Even in the unfortunate event of theft, the data within remains shielded, ensuring that your personal and professional information stays confidential and secure. Exam Objective 6.4: Identify common use cases for encryption. Data in transit. For this topic, I would like you to picture a massive freight train chugging along the tracks, loaded with valuable raw materials like coal. As the train moves from the mining site to its destination, the coal is in transit, exposed to the elements and potential theft unless it's properly safeguarded. In the digital world, when data travels from one point to another, we refer to this as data in transit. Just as the coal on its journey can be vulnerable, so too can data unless it's adequately protected. Sending an email is a great example of data in transit, as it involves transmitting data across networks to reach its intended recipient. As the email travels, it passes through various servers and networks, making it vulnerable to interception by malicious actors. Without proper protection, these actors can eavesdrop on the content of the email, potentially leading to breaches of privacy or data theft. Encryption plays a pivotal role in safeguarding this data. When you send an encrypted email, the content is transformed into a scrambled code, making it nearly impossible to decipher the original message. Another example of data in transit is internet traffic. When browsing, you might notice HTTPS at the far left of your browser's address bar. This signifies the use of SSL encryption or its successor, TLS encryption, to protect the communication between your browser and the websites you visit. By using the HTTPS protocol, you are ensuring that sensitive information, like passwords or credit card details, are transmitted securely over the internet. Essentially, SSL and TLS act as digital handshakes, agreeing on encryption methods to keep your online interactions private. Continuing with our study of data in transit, another encryption option that we have at our disposal is a VPN. A VPN, or virtual private network, creates a secure, encrypted connection between your device and a remote server, acting as a protective tunnel for your data. This is especially vital for secure remote access to servers, allowing users to retrieve or send information without exposing sensitive data to potential threats. Lastly, think about the mobile applications on your smartphone. Every time you use an app, data is sent and received to and from servers. It's important that these apps use secure protocols to protect this data during transmission. This ensures that your personal information, conversations, and other sensitive data remain confidential and aren't compromised by potential threats. In summary, data in transit refers to information as it's being transferred from one location to another. In the same way you'd want valuable goods to be safe during transport, in the digital realm, we employ encryption techniques to make sure our data is delivered securely and intact. Exam Objective 6.5: Given a scenario, configure security settings for a small wireless network. Wireless network best practices. Whether you're setting up an access point, a wireless router, or a SOHO router, there are several essential tasks to help keep your wireless network secure. The full list can be extensive, but CompTIA narrows our focus to two critical configurations. These include changing the SSID and updating the device's default administrative password. I will assume for a moment that you are unfamiliar with the term SSID and will therefore explain what it is. The term SSID stands for Service Set Identifier. The SSID is a unique alphanumeric identifier given to a wireless local area network. The SSID serves as the name or label for the network, allowing devices like computers, smartphones, and other Wi-Fi-enabled devices to recognize and connect to it. The SSID is essential because it helps devices identify and connect to the correct wireless network. When you want to join a Wi-Fi network, you select its SSID from a list, like the one behind me. Look familiar? Now that you know what an SSID is, why should you change it when setting up and configuring a new wireless network device? Changing the SSID when first configuring a wireless device is a security best practice that is designed to enhance the overall security of your network. Most routers come with default SSIDs set by the manufacturer. These default names are often well known and can be easily identified. Malicious actors or the bad guys might use this information to specifically target networks with default settings for potential attacks. In addition to changing the default SSID, you should also change the default administrative password on the wireless network device. This password serves as the device's login credentials and is used to access and configure the device's settings and features. Again, just like the default SSID, default admin passwords are often well known and can be easily exploited by malicious actors or the bad guys, if not changed right away. So to recap, when configuring a new wireless network device, it is best practice to change the default SSID and the default admin password as soon as possible. Exam Objective 6.5, given a scenario, configure security settings for a small wireless network. Encrypted versus unencrypted. When configuring a wireless network device, you will be presented with a very important security option. Do you want to encrypt your wireless network? Now before you jump right in and say, "Of course I want to encrypt," I will cover a few cases where you might want to leave your wireless network unencrypted. Leaving your wireless network unencrypted or having what is called open authentication allows unrestricted access to the network without requiring a password or authentication credentials. This can be useful in public spaces or guest environments to offer convenient and seamless internet access to a wide range of users. A perfect example would be a popular coffee shop in the heart of the city. With an open authentication wireless network in place, customers can easily connect to the internet without the need for a password or any authentication process. This makes it hassle-free for patrons to use their laptops, smartphones, or tablets. In doing so, users do need to be aware that they are responsible for their own data security while using the open network. Using an unencrypted wireless network is risky due to lack of password security protocols. Without encryption, information on the network can be seen by others. So try not to log into your bank account while connected to one of these networks. Paired with open authentication, you will often come across captive portals, and keeping in step with our coffee shop scenario, on the right, we have a captive portal from my local Starbucks. Captive portals are commonly used with open authentication networks to provide an additional layer of control when sharing a wireless network with strangers. Even though we may not be requiring a password to authenticate, we may still want a user to at least agree to some terms and conditions of use. Some additional reasons for a captive portal may include informing a user of data collection or to provide management of a user's session. Captive portals are typically displayed as web pages that appear automatically when a user connects to an open network or attempts to access the internet for the first time after connecting. These web pages are designed to capture the user's attention and require them to take specific actions before gaining full access to the network. Now that we have covered the unencrypted option, let's switch over to encrypted networks. We will be covering 4 key encryption standards: WEP, WPA, WPA2, and WPA3. Now, as I briefly work my way through these 4 wireless encryption standards, use the table behind me to keep yourself organized. I will start at the top and work my way down. First up, we have WEP, or Wired Equivalent Privacy. This is the oldest and weakest of the encryption standards. WEP used an RC4 encryption mechanism, which had some serious security flaws and could be easily cracked by determined hackers. So, it's best to avoid using WEP and opt for a more secure option. Next, we have WPA, or Wi-Fi Protected Access. WPA was an improvement over WEP and offered better security. It used a more robust encryption mechanism known as TKIP. This made it a bit harder for attackers to break into your network. However, like WEP, WPA is also considered outdated and not the best choice for modern Wi-Fi security. Moving on, we have WPA2, or Wi-Fi Protected Access 2. This is a more modern standard for securing Wi-Fi networks and has been widely used for years. WPA2 uses a stronger encryption mechanism known as AES. AES is highly secure and much more difficult for attackers to crack. If you have a relatively new router, it will likely support WPA2. And now for the last encryption standard, WPA3. WPA3 is the latest and most advanced wireless encryption standard. WPA3 builds on the strengths of WPA2 and adds even more security features, such as the SAE encryption mechanism. WPA3 is currently the gold standard for Wi-Fi security, and if your wireless network device supports it, it is the best choice for keeping your network safe. One last note about these encryption standards. Just because your wireless network device supports a specific encryption standard does not mean the wireless clients do. It is very common that an older wireless client, such as a laptop, smartphone, or even a wireless IoT device like an oven, refrigerator, or light switch, may not support some of the newer encryption standards. If this happens, the client may not be able to connect to the network. Just some food for thought. Congratulations on completing our CompTIA Tech Plus training course. The commitment and drive you have demonstrated to arrive at this milestone is truly commendable. Whether you started with no prior IT knowledge or you had some previous experience to draw upon, you've journeyed a great distance. Now you stand at the threshold of your next big step towards obtaining your CompTIA Tech Plus certification. But before you go ahead and book your test, we have a new challenge lined up for you. We've assembled an exclusive practice exam on our channel, packed with 200+ questions meticulously designed to test your knowledge and simulate the format and difficulty of the actual exam. It's essential to remember that repetition is the key to mastery. The more you practice, the more confident you'll feel. Also, as you navigate through our practice exam, be sure to make notes of areas you're unsure about, and feel free to revisit any part of our training course as needed. So are you prepared for our practice exam? Great! Then click on the link to my left to get started. This CompTIA Tech Plus practice exam will challenge you, gauge your readiness, and move you one step closer to your certification goal. We wish you all the best, and here's to you, passing that exam.